Yeah, hello everyone. I'm not sure actually if you can hear me and see me, but today we're celebrating, and it's really honor for me to open our React JS Global Summit 2022 second edition. This year, this is the second event about React, and I'm so excited because the React community is one of biggest communities for Geekle, and I'm so happy that you guys are appreciate our event and join us and help us grow. Thank you very much, and this is an honor for me to open this event. So. My congratulations, we are live. Let me know if you can hear me and see me well. What about sound? It's a kind of sound check. Just let me know if you can hear me well. Yeah, I see. It's Looks like everything goes well. Yep. And now then I'm inviting Anna. Anna is a community manager of React Global Summit. Hi, Anna. How are you?
Hi! Hi, everybody! So glad to be here and so glad that this event happening today.
Yeah, and you're right now in India, am I right?
Yes, but I painted Ukrainian flag and now I have a background, so it doesn't matter where I am. So I'm still Ukrainian.
Yes, Ukrainian, Indian tech people are here in the stream. That's correct. Yeah, we are Ukrainian team. We're born in Ukraine, and yeah, and actually, I want to thank this community for that huge support that you provide, guys, to us because it's so important. And today, usually this event helps us, like Nick helps us to open, and because he's the technical director, he cares about all the stream and everything. But because of war, we have this, lots of cities in Ukraine are out of electricity, so he has no internet connection now, and he cannot like help us. But I think we will do it because we're professionals, right? And so anyway, what do you feel? Tell us more about this event.
Yeah, I can just mention that it's our fifth React event. So guys, just listen and it's fifth event that we're trying to do. And I hope this one you also will enjoy like you enjoyed previous one, because of course we are gathering your feedbacks and we will be glad to receive feedback from this event as well. So yeah, this event will be 2 days. Today we have junior track, free day for everybody. Anybody who interested in React, please watch us, join us from anywhere where you can. Please also share this link from YouTube, or if you already watch us on other platform, just let know your friends that they also can watch us on YouTube today. And don't forget to subscribe, follow, like, so it will help us to grow and will help to share information with others as well. So yeah, it was just short advertisement again our YouTube channel, but yes, today we have amazing day with 4 blogs. We have amazing speakers that will share their own use cases, what they learned, how they were growing, how you can implement their knowledge and skills in your own project. It also matters. So yeah, it's
Yeah,
really
absolutely.
fun.
Thank you for this introduction, and lots of hands-on experience, lots of understanding or re-understanding of using some tools. Yeah, and people, I still well. I am in Nice, in France now, but let me know where you are now, because usually people type lots of cities and countries, and it really excites me when I see that people from all around the world watch this event, and now we have almost 500 people already on the stage. Wow, and it counts. Cool. Okay, Anna. Do we have any like Q&A sessions interesting or whatever? How it works? Just let's disclosure more.
Yeah, I'll explain more. So yeah, we have Q&A session. We have a separate Q&A session with topics that are completely unique, and I just didn't want to waste speakers' time to answer for some other questions because their topic is so unique. And mostly we will talk today about performance, how to make your app fast, how to run tests, how to make sure that everything works perfect, and you can use some additional tools also to make your apps better. So this is what it's about, and you can ask any questions that you want to know. So today is that day where you can, if you have any doubts, if you have any question regarding React, just type us and we will definitely ask speaker and you can get answer for that question.
Yeah, cool. Thank you. I would, but I don't do React, unfortunately. Look, do we have any gifts or something sweet for our audience today? Maybe some free tickets for next one or some sales. Yeah, just it's time for
We
it.
have
Let's do it.
everything. So, first of all, before we send some kind of form to our already registered attendees to ask questions that they have on their mind. So we will just give away 10 tickets for or tomorrow or any other event that you can, if you already have tickets for tomorrow, of course. So we can share for next one or for any other ticket that that's my some of here. So, and you can get for any next event. Or if you are very active, you are asking us questions, you're really staying with us from the beginning till the end, you also can get free ticket. We will, of course, active attendees you cannot see, so it's very visible. So we will see you, but of course, don't text us like hi million times. Just ask us something relevant and be interested in attendees and give us some more information to grow and to find answers for your questions.
Yeah, as always, we have plenty of gifts. Yeah, and hello from Ghana, from Tunisia, from Palestine, Italy, Indonesia, India, Argentina, and Poland, and Canada, and Ukraine. People from all around the world. Yeah, that's what excites me most. Anne, I remember the time that when we had this 24 hours online streams. Right now we do like 8 plus 8 hours, right? 24 hours, because we had an idea like to provide this possibility to every country of the world, like jump in for a few minutes and like enjoy this atmosphere, right? And 24 hours, some guys were watching us like for 24 hours, and like it was like I can't even like forget it till today. Yeah, and more and more, and from Ukraine and California and Saudi Arabia, and like from India again, like so many people. Cool. Anyway, today we also have our speaker, our sponsor, from company AG Grid, Neil Crosby will present him from like this company. And I really thankful to this company and my colleague from this company, CEO, for supporting this community. People, thank you very much. Because of you, we can like grow, we can gather more innovations and spread it out all around the world because of your support. Thank you very much. And kind of that. And by the way, we have Paul with us here on the backstage. Paul, I inviting you here, like join us and tell us more about this beautiful partnership or whatever.
Yeah, so thank you once again. We wanted to thank you for joining us, and we wanted to say thank you to everyone who actually supports us by buying tickets, and also to our sponsors, to Neil. And Neil's going to be one of the speakers and one of the moderators. I guess one of the moderators 2 times during this conference. So we'll hear from him. Also, yeah, and if I'm not mistaken, Neil is one of the speakers who started like since the very beginning of the React. He's been a speaker multiple times already, if I'm not mistaken. Yeah, so thanks again. And if you want to check out their highly customizable data grid, check out AG Grid. And I'm absolutely sure that if you ask for some kind of special promo in the chat, I guess Neil will have something for you. So yeah, we're looking forward to having some amazing time together with every one of you. And yeah, thank you once again for joining this event. And we're happy to see everyone. So, and yes, please stay active for the Q&A sessions, because this is one of the coolest things that we have, where you can actually participate in meaningful discussions, though in the form of chat, but you can ask questions to those people from different companies from across the world. And maybe I'm thinking too much of myself and ourselves, but I'm not sure this is possible anywhere else, where you can talk to guys from other huge companies and ask about very practical stuff that they do. So yeah, use this opportunity.
Thank you, Paul. Thank you. And Mali, Kharkiv, India, France, Kenya, Kyiv, Ukraine, Portugal, India, Poland, Romania, Nigeria, Slovakia, Chicago. Special promo. Someone is waiting for special promo. Yeah, cool. I'm sure we're going to see some links here and explanations and something like that. Okay. Yeah.
One more sentence I have to mention, otherwise I will not survive till next React event. We have our program committee members. They handling me for so many events and really staying with me and helping us to build this great event, choosing a lot of topics, reviewing them, giving the feedback, spending hours of their time just because we are asking them to do that. So guys, I really love you so much. Thank you for being with us and thank you for your support, because we have next React Global Summit, online summit, that will be in April. So I again text you, be ready for that. So yeah, this is what I have next.
Absolutely. Thank you. Thank you. Macedonia, Georgia, India, Hungary, Brazil, and Turkey sends us their love again. And the last word, guys, Geekle is about finding innovations from very first hands and spreading out all around the world without borders, without need to be physically in some place. And here we go today. And I don't know what's next. I want to give this stage up to our moderator, and I can't wait to start it. Anna, what we do?
Yes, what we have to do, we have to leave the stage for Neil, and he knows what to do next, because he has long 4 speeches that he has to moderate, and he will be with you guys. See you.
See you, everyone.
See you. Hi, Neil. Hi, Neil.
Good morning.
Happy to see you here today. How are you, and where are you now?
I'm doing very well, thank you very much. I am in Dublin, Ireland. As you can see, the beautiful Irish green weather. We're famous for 2 things in Ireland: drinking and green. So delighted to share with you our weather today.
I feel like I'm Irish myself, at least twice a week. Yeah. Okay. So
fair enough.
What do you have for this event today? Yeah. Maybe I'll just leave and give you this stage. Is it okay?
Absolutely. Yes. Thank you, Ed, and thank you, Anna and Paul, for earlier, for your kind words about AG Grid. So today is not about me, it's not about AG Grid. Oh, in and out. Sorry, accidentally came in and out. So yeah, today is not about me. Today is about React Global Online Summit and all of the brilliant speakers that we have. I will be moderating the first 4 talks. What we will do is we will either play the pre-recorded talk, or we'll have the person here live on the stream. And then after each talk, we'll have a quick Q&A session. So without further ado, we're going to play the recorded talk from Sohini, who is the Associate Product Manager at Akintayo, and her talk is Composable Microfrontends with React. So let's play.
Hey there. Hey, everyone. Hi, Neil.
Hi, Sohini. Oh, I beg your pardon. I thought your talk was pre-recorded. Is it live?
It is
pre-recorded. Just to say hi to everybody, and we will see the speech. Just to say hi to everybody.
Ah, okay. Sohini, welcome. Good morning. Or good evening.
It's good afternoon here. It's, I don't know, it's around 3:45 here, PM in India. It's afternoon.
Very good. Which city?
It's Bangalore.
Bangalore. Fantastic. So are you looking forward to your talk?
Yes, absolutely.
Cool. All right, let's press play, and we'll catch up again in about 25 minutes.
Done. That works. I am Sohini, and I work as an associate product manager at Akintayo. Previously, I've worked as a developer and developer advocate with multiple communities and projects. I have experience on teams at Double Lab, American Express, and Amazon Alexa. My current goals are to help developers, architects, and enterprises learn, adapt, streamline, and accelerate development through the use of modular architectures and composable applications. So yeah, that's a little about me, and today I'm going to be talking about composable micro frontends with React. So before I actually get started with the rest of the slides, I just wanted to say I'm going to take you all over a history of what it has been in tech and how we have come to micro frontends from giant monolithic applications, and what we are aiming towards tomorrow with the micro frontends that we are building and will be building in the future. So for that to happen, we need to talk a bit about the past. So the first few slides are going to talk about our history, and then I'm going to jump into all about micro frontends so that it's easy for all of you to understand what I'm trying to talk about. So yeah, that's a little about my introduction, and then I'll be going to the strategic technology trends of 2022. So here, if you see, we've got two trends. The first one is composable applications and the cloud native platform. So I'm quite sure all of you are quite familiar with cloud native platforms. We know what these are and how these can help you build new application architectures that are resilient, elastic, and agile. And we've heard a lot about it. Lots of information on the internet and lots of stuff to learn about cloud native. And I think lots of products have come up that supports cloud native thoughts and cloud native architecture. But composable application is still something that not everyone is aware of. And I think it is important we all know and understand composable applications, because that's a big part that relates to micro frontends. So typically a big relational statement is, if you want to know like what micro frontends are, of course they are something that are really useful and helpful, but only those micro frontends and microservices can help build a modular application, and a modular application is the composable application. So composable apps are built from business-centric modular components. So here's the word, modular, and make it easier to build and reuse code, accelerating the time to market for new software solutions. So the concept is to have modular applications and not large, giant, monolithic applications. And because, of course, let's just imagine trying to update or edit or change something in a large part is much difficult than having to change the same thing in a small area, because you know where to go, where to change, and what to update. So you're just clear in your head about that. You don't need to spend a lot of time on that. It's easy, quick, and simple. So that's why composable applications is something that's on the trend. Well, of course, it's 2022. It's on the trend right now. It's going to be more popular in the upcoming years. And as I said, not many people are aware about it. And so if you are really excited about it, then make sure you make others aware about it, because composable applications are really cool, and there are so much to learn from it. Now going to application modularity. So we've got four, so don't get afraid of this image. It looks a bit, I know, lots of stuff in here, but I'm going to make it very simple. And I'm going to explain how this trend has been swimming through monolith to fully modular. So we were in 1970s when we had the giant applications, the giant monoliths, and then we came to modularity. So here in the first column, as I said, we've got monolithic architecture. So in the past, these could be large web applications which were deployed in a servlet container like Tomcat, or they could be in enterprise application archive deployed on WebSphere. And then if you come to 2000s, which is the second column, so it represents the separation from the front end of the front from business logic, and backend services would be called from a service layer, which could be called using technologies like Spring, then EJBs or ESBS. So that's what was in the second part. In the second part, we can still see that there is a front end and a back end. But that was it in 2000s. And then we came to 2010s, which is the third column. So this represents where we are today. And yeah, like we can say we're 50-50 in here today. So 50% of people are in here today and 50% have already shifted to the fourth column, which we are going to talk about and which relates to our topic for today. But still thinking about the 50%, which is still in the 2010s, the third column, we here the backend is broken up into microservices. And this is what many technology vendors are promoting today: microservices, containers, and cloud-based infrastructures. And this is well suited for large enterprises where the need to simplify the management of thousands of backend services makes the cost of switching architects worth the effort. But as I said, like, modularity is so cool. So if you come to the fourth column, it represents the next step to modularize applications. So modern applications are developed as React, then Angular or Vue apps. So JavaScript applications, other significant benefits in development speed and modern user experience. And as these applications grow more and more complex, they're becoming the new front-end monolith. And microfrontends apply the same architectural discipline to the front end to make it easier to manage large, complex front-end applications across large distributed teams. So that's a little about microfrontends here. So the microfrontends are the evolution or the next logical step of microservices. And microservices grew out of a need to manage increasingly complex applications across large distributed teams. So microfrontends apply the same architectural principles to the front end, and then they break up the front-end monolith into small, self-contained components, and they make it easier to manage complex front-end applications across large distributed teams. So here we've learned about a couple of benefits of micro front-ends, and I think, as I said, it follows the same architectural principles to the front end. It's just that the packaging and all are going to be just a bit different compared to what it was to building normal front ends and then what it is to build micro front ends. So that's a little bit of difference in here. Now here in this slide, you can see ACP. So what is ACP? So we have spoken about application composition, and the P stands for the platform where we can do the application composition thing. So just to tell you people why I am speaking about composability so much, I think this slide explains why and how I'm related to the composable background. So to support the composability thought or the composable way of building your business, we have built the ACP, which is the Application Composition Platform, where you can build fully modular applications. So where technically the fourth slide is possible, where you can build those micro frontends and here those microservices, if you take a look at the fourth column, but you can also keep multiple micro frontends into a small PBC, which is a packaged business capability. We'll talk about that as well, because I don't want to confuse you people with all these new terms. But yeah, we'll come to those. And so we've built the application composition platform which supports this concept and this thought process. And that's the reason I've been speaking a lot about application composition, because I have, I can show how the ACP can help you lower cloud runtime costs, and accelerate application development. So definitely it's beneficial. And so here you can see a couple of benefits of the application composition platform, and this is where we stand. But yeah, of course, not talking much about these, and moving on to the next slide is what is application composition platform? In short, if we want to know about what this is, so we've spoken about composable business, composable thinking. So here is the where we can implement our composable business and composable thinking, the ACP. So an application composition platform provides developers with tools to rapidly build, design, and assemble applications from microfrontends, microservices, and web content. And built on the principles of modularity, application composition platforms, ACP, enable enterprises to promote developer productivity in a Kubernetes environment, and ACP can help your enterprise accelerate the speed with which you update applications, lower runtime costs, and of course, streamline reliability and security through modularity. So the application composition platform that we have built here at Intando is a set of technologies that enable teams to build, deploy, run, and manage applications developed by composing together components and business capabilities. Now, business capabilities is what the packaged business capability is, and we will take a look at that as well, because again, this is another important part which relates to microfrontends when we are building microfrontends in the ACP. So yeah, like of course you can build microfrontends part of your project normally, but with the help of the platform, you can have it all together because we have everything ready. You're just gonna need to write code for your microfrontend, then publish it as a bundle, and then drag and drop in the application composition platform that we have. But you can also encapsulate the microfrontend and a microservice inside a particular PBC. So a PBC encapsulates data, logic, and processes that implement a well-defined standalone business capability. They are opaque in that their internal design, including internal data schemas and services, is not published and not accessible directly by any means. So if you want to do interaction in and out of PBCs, then it should be via authorized and published APIs and even channels. So that's how you can do interaction. So that includes both business interactions and governance. So we're going to come to the part where you'll see the design, the schema, the diagram of a PBC and what exactly you can put inside of it. But before that, we're going to discover at which phase you can build. So if you're using the application composition platform to build, to put your microfrontends and microservices together in a web page or a website or application, then how you can do that, we're going to come to that section. So the application composition platform, which I spoke about, has got all these processes. So to create the application composition platform's architecture, we recommend distributing responsibilities across 4 separate roles or functions. So we're gonna, so here you can see there are 4 roles, but we're not gonna spend time on all the 4 roles because our main focus is on the create phase, but I'll still walk through the rest of the phases so that you know what they mean. So in the first stage, we create. So in this stage of the process, developers create the building blocks that will become applications. So building blocks is what those PBCs are. So, and then inside of PBCs, you can put the microfrontends, microservices, or just microfrontends, or too many microfrontends and not too many, just maybe 2 microfrontends or 2 microservices, something like that. And then these building blocks may be subcomponents, components, widgets, packaged business capabilities, just as I said, or even full solutions. So you can have a particular microfrontend built and published in here as well, which is a component, just as I said. So this is mainly taken care of by developers. So that's what the create phase generally means. And then we move to the curation stage. This involves cataloging the different building blocks of applications on centralized hubs and creating categorization and logging inventory. Curators also ensure that components, business capabilities, and solutions are ready for composition, defining prerequisites and then updating capabilities with the latest patches or upgrades. So here, a curator is going to act like the security person. So they're going to take care if you have followed all the rules and regulations for building the micro front end, if there is anything that's needed, if there's anything that's incorrect, if there's anything that's missing, or if it doesn't pass the validation, then it won't be moved to the hub. So we're going to talk about the hub as well. We're going to come to the hub in the next slide, what the hub is. But the hub is kind of a centralized repository that keeps all these PBCs, components, solution templates, building blocks, and everything together so that you can show it to other people and they can take a look at what's happening. And then at the composition stage, enterprises create composable applications by pulling the necessary building blocks from the curated hub and integrating them based on their prerequisites and the given needs of an application. So developers working on composition are responsible for delivering user interfaces and experiences that will be enjoyed by the end user, whether that user is an internal business user or an outside client or a customer. So that's what the composer is going to take care of. And in the composition phase, you can actually drag and drop those components that you have built to the app builder of the page. And we're going to see an example of that as we go through the standard banking demo, which I'm going to show today as an example of the microfrontends that we have built and how you can use that if you want to take a look at how those microfrontends work and how you can use it and how it can benefit you. So we're going to take a look at that. So yeah, those who consume, and then in the fourth phase, those who consume the application are then able to evaluate the usability and effectiveness of the application, communicating necessary changes and feature updates to be addressed at the curate, compose layers of the process. So yeah, I hope I haven't spoken a lot about this for processes because initially in the beginning it's going to feel like so many new words and new stuff and it becomes a bit confusing. So actually I could explain a lot of new concepts, but again this is going to take a whole lot of time, so that's the reason I'm keeping it all short and simple. Then this picture is what I was talking about. So you can see the curate and the compose sections. So they are not that important because we're going to focus on the create phase. So in the create image, you can see there's a PBC. And inside of PBC, you've got the login or sign up PBC, the product catalog PBC, and the cart PBC. Now, let's come to the product catalog PBC. So a product catalog, you can imagine how it looks like. It has got many small components inside of it. So it can have a section that shows all the products, and then it can have a section where it gives us the description of the products. So all of these could be different microfrontends, but yes, of course, a microfrontend should have its own functionality. In you can so to make the product catalog, you can have one microfrontend and one microservice working together. So this way, inside of PBC, you can see we've got I think three components, and those could be either a mix of a microfrontend and a microservice, or just a microfrontend, or just a microservice. So it could be any of those. And that is what an example of a PBC is, just as we spoke about in the previous slide. So yeah, here. So just again, under the create phase, you can do this. And yeah, now what is the hub? If we come to the curate part, and I think I have spoken a lot about the hub, but let's understand what the hub is. So the Intando hub is a repository, and it could be local, remote, public, or private, that contains components. And the hub lets you share single components, component collections, then solution templates, or package business capabilities that creators build. So this is the hub. And before your PBC gets in the curator or group of curators would check if your PBC was made with all the requirements, just as I said before in the previous slide. So this is a kind of validation the curator would do for your PBC. And then finally, when your PBC has passed the validation, it'll be up on the hub. So finally, the composer you see or the group of composers would use this PPC or single page application or a full stack application. And finally, the consumer will be able to use the application. So they could analyze or monitor it. So yeah, that's all about the 4 C's of application composition. But we're only going to focus on the create phase because we're going to build lots and lots of microfrontends in the future. So again, what a microfrontend is. So microfrontend architecture is an approach to developing web applications as a composition of small microfrontend apps. And I think we all understand what a microfrontend is, but still I just wanted to keep a small definition here so that we all have it clear in our heads what it is. And why we would prefer React to pretty much use it, because of course we can see it's the most popular front-end framework and it has the ability to quickly build single page applications, of course, and it's easy to plug into an existing web application, has a broad ecosystem, which is very true, and has lots of templates and tooling to support it. But the most important reason why we should use React is because it's a very lightweight framework. And I think it's quite recommended. Even the engineers in our teams who have built many microfrontends in the past and we're still building microfrontends and other partners, they have always said that a lightweight framework helps build nicer or great good microfrontends. And React is one of those. So yeah, we've understood why we're building, why we recommend building microfrontends using React. Now, this is a demo that we have built, and this is easily you can use this easily. I'll share the link on the chat. You can see. So this page that you see is built with the help of microfrontends, microservices, all those PVCs and stuff. And how we're going to take a look at that. So the Intando standard banking demo provides a set of microservices, microfrontends, and content management systems components to demonstrate how you can leverage the platform to develop, deploy, and make your applications available for your users. And again, the link that I just shared is the GitHub link where you can get full access to it. And if you want to use it, you need to make sure that you've installed Intando, and then you're using this from there. Sorry for the noise if there is any. And the standard, this image you see is the dashboard page, and it's the best example we can take from the standard banking demo to understand how it's built. So several microfrontends gathered under the same page to serve a business purpose. So microfrontends present in this page are React or Angular applications using custom elements wrapped as a web component and using REST APIs to reach the backend APIs through HTTP calls. So yeah, so this again is, now I'm going to show you how we do it. So if you install Intando and if you go to the page designer section, then it allows you to compose pages with components such as microfrontends. And this is the compose phase of the 4 C's of application composition. So if you remember, I spoke about a third phase. So the creator has created the microfrontends, microservices, and they have published it. Then there's a validator, and the second phase is going to check if all of this is done. And in the third phase, there's a composer. So the developer who has built it can also be the composer, or it could be some other group of people who are going to do it. So now let's say you are the composer yourself. So if you go to the page designer, and it's available under, so if you go to the app builder and then from there pages and then management menu, I could show a demo, but again, we don't have so much time and if I show the demo, I would need to explain each and everything that we have in the application, in the Intando's application composition platform. There are lots of new terms and lots of new stuff that I would need to explain, and that's going to take a whole lot of time. So just to give a little quick summary of it, if you go to the page where I said you can design it by clicking on the design entry in the page menu, and then you can drag and drop components to compose your page. So yeah, so this is just a little bit of logic and how the thing is happening, and this is how it is in the page designer. So the ones in the blue are micro frontends built on top of React, and the ones in the red are micro frontends built on top of Angular. So that's another big benefit. So can you imagine having one, you're building a website or a demo that consists of micro frontends from other frameworks, one with React, one with Angular, and who knows, you can go ahead and build one with the help of Vue. So that's the fun, having all of these and taking the best parts from all these frameworks and building something really cool and having it in a single page. I think that's awesome. And that is composability, so much flexibility. So this is how the Intando page designer looks like, where you can drag and drop these micro frontends and put it up in here, just like it is over here. So if you, and going further, if you don't want one of the widgets in here, you can call these widgets, you can remove it and then save the page, and then it's going to be, so these are just like little building blocks which you can add or remove and just keep going ahead. So yeah, that's a lot that I could. That's a little that I could share in this time frame. Of course, there was a lot more, and there is a lot more that I can share. But to go through all of those, we would need to start from scratch, from the app builder, the code, and everything. So what I'm going to do is put up the resources here. You can find more information on micro frontends, how we are building those micro frontends on the Intando application composition platform, and how we're writing code, how we're bundling it, how we're publishing it. You're going to get all the information in these resources. And definitely next time I'm going to come up with a more technical presentation, because this overview was more important. So yeah, that's a little. And now I'm gonna go to, so if you want to find me, then these are my details. You can find me from here. And now I'm gonna go to Q&A. So feel free to ask any questions that you'd like.
Sohini, thank you very much. Do you want to, let's bring you back in.
Here
Sohini,
I
that was
am.
fantastic. Thank you.
Thank you so much. I was just trying to send across all the links, and yeah, that's it. I think I've shared those. Okay.
Perfect. Thank you. Did you do that recording in just one take?
Yeah, just one take.
Wow. Wow. I would not be able to do that. My talk is tomorrow, and you'll see it's edited, completely edited afterwards. So no, hats off. That was a fantastic presentation. I liked the evolution of micro front ends. You said WebSphere, and I was like, wow, that brought me right back to the 90s. But yeah, it was wonderful to see. And then today, where it is now.
Yeah, it has really changed today, and not everybody is still aware of it. So I first came to know about it when Gartner defined it, and I should have added that slide actually, but I just went away from my head. But it was from Gartner's review of composability, and we've been following that at Intando as well. And yeah, that's how it is. So by 2023, the adoption rate is going to be a lot more than how it is today and it was yesterday. So yeah, it's great, I think.
Okay. We got some questions on the channel, so let's get straight in. We'll start with an easy one. Since I'm new in learning React, what would be the best approach to understand and use micro front ends?
Okay, so I mean, the main thing about building micro frontends is how you're packaging stuff. And you can build many front ends, but micro front end is all about breaking down a big large piece of front end into a smaller one. So you got to make sure that you're building a really nice micro front end. And then like the way we do it here at Intando, it's a bit different. So we create bundles, and then that is the main engine of the entire process. So the bundle helps your micro frontend to get packaged properly, and then it puts it up in the app builder. So that's what we generally do, and that is what we generally provide to people when they're writing micro frontends. So yeah, it's all about bundling and packaging your micro frontend.
Okay. I'll go to the next question. What is a good tip or rule of thumb when it comes to choosing site features to be in its own micro front-end repo?
Side features, well, not quite really, a lot of, I don't have a lot of experience with this. I think this is something that our engineering team would be able to tell us more about, because I've just been a developer advocate and I've just made a couple of micro frontends, not a lot of them. So yeah, I just don't have an exact answer to this, but would definitely ask our team and get back with an answer soon.
Okay, cool. On to the next question. We get markup named collisions, a routing problem, which the monolith solves, design update problems, and so on. What advice can you give to avoid this?
Well, I don't think you're gonna have any kind of routing problems, because I think we try to make sure that everything is easily bundled up, and also if there's an issue with it, you're gonna get that before the macro front end goes up into the app builder or it gets bundled up. So, but yeah, like I don't really think we get this kind of problems here generally.
Okay.
Yeah.
Right, we'll go for maybe two more questions, then we'll have to finish up. So we'll move on to here. Can you give us some examples of what companies or web apps are currently using micro front-end architecture?
Oh, that's a good question. I think not a lot of them, but I think we are using it. So I have that. Also, a couple of more companies, but I don't remember. I just talked about this a couple of days ago, but I don't exactly remember some of the companies, because anyway, this is quite new. This is something that's still getting adopted. It hasn't been into it already, and people are not already shifting towards it, because there's a little bit of fear if previously built application infrastructures or architectures are going to get lost, or if there's going to be a problem or something. So yeah, not a lot of companies are still using micro frontends, are yet using micro frontend architecture. Still
Okay,
getting
very
it.
good.
Mm-mm.
Right, and let's finish up with this question. I guess this is a general one. What are the key factors in an existing monolith project one should look for, which will help us to identify whether to go fully modular or not? I guess this is what smells would you see in a project which would lead you to go, that should be a micro front end?
Yeah, lots of things. So I think generally it is better. Let's say you're working on an e-commerce website, and if you try to put up everything together, like the order, the images that you're putting, I mean the products in the page, and then you have the cart, and then you've got the checkout thing, all of these things together, and then tomorrow, let's say there's a bug in any one of those, you need to go back and just make a change in that application, and then you need to, I don't know, like it's going to be a long process, and then you have to put out that update. So instead of doing that, breaking that big e-commerce website into smaller parts, let's say you're doing a separate micro front end for the cart, you're doing a separate micro front end to display all the products, and wherever it's pulling the images and descriptions of the products, it's going to be a second micro front end, and it could be in some other language as well, just as I explained in the previous one. So that way, if you've got separate micro front ends for different functionalities of the same page, I think it's easier. Then what happens is, if you need to make a single change in the let's say in the product display area, you can just hit on that particular micro front end to make a change without affecting the other micro front ends. But generally, if you have a modular project, then it's going to be like you have to, again, whatever you do, the entire project might get affected by it. So there's a big risk in it. You need to be very careful. So yeah, it's about, you need to figure out in one single page how many different functionalities are working. with that, with respect to the functionalities, you can divide those into separate macro frontends. I think that's how we would do it.
Very good. Excellent. Okay, my apologies to those who did post questions we didn't get to ask. There's lots of more questions here. I believe, Sohini, you gave your contact details at the end of your presentation, so if people do want to get in touch with you directly with follow-up questions,
Absolutely.
They can do
so. Also, you can send me an email or reach out to me on LinkedIn, and yeah. And sorry for
Brilliant.
not being able to answer a couple of questions, because I think our engineering team does an intense work with all the micro frontends, microservices, a lot more. And also I've shifted to another role currently. So that's why they probably have a lot of more experience to answer those questions, and we'll get back with us soon.
Excellent. Thank you. Sohini, thank you very much for joining us. Take care.
Thanks so much, Neil. Bye-bye.
Excellent. Okay, next we're going to have Jason Hogan, who I'm going to bring into the stream now. Jason, good morning.
Hello.
Good afternoon.
Good morning.
And where are you dialing in from this morning?
I'm dialing in from Dublin in Ireland.
Where are you? Jesus, where are you? I can't see you.
I'm
this is
Grand Canal Dock.
Oh, grand. I'm down in Glenageary. So this has become
nice.
The Dublin show for everybody else dialing in online. Right. So Paul works for, so you're the lead developer at Inner Strength Health, and
Yep.
you're going to be talking to us about the next generation of state management.
Yeah, that's correct.
Okay. So in your own time, if you'd like to share your screen, and we can get going.
Great. Yeah, I'll share my screen here. So hopefully you guys can see that. I don't have a slideshow, I'm afraid. So this is a demo I'm going to show in a few minutes, but just bear with me while I give some brief introduction. So yeah, a lot of React apps use Redux, obviously, for state management. It's kind of become the default. Teams all over the world use it. But there's a lot of problems with it, and there's a lot of new alternatives out there and new ways of doing React state management that solve a lot of these problems. So I wanted to talk about some ways of thinking about state management differently, and reasons why you might want to think of a new approach instead of going with the kind of classic default of Redux. And this is a problem that I've encountered in my own career. I used to work on an app that was based on Redux, and where I work currently, I'm, as Niall said, the lead mobile developer, and we're developing React Native apps there. And yeah, we decided to use a different state management library called MobX State Tree, and I've found it just a dream to work with, and such an exciting change to how we can look at state management in our React apps. So I'll start by giving just some of my thoughts on the things that can make Redux hard. Redux is based on the flux pattern, which is really complicated. It's pretty hard to explain and get your head around. So right from the outset, it's kind of not the most intuitive model. There's a pretty steep learning curve. Redux introduces a lot of concepts like reducers and selectors and thunks and sagas and these kind of strange words that a lot of developers don't necessarily have a kind of mental model for already. So you've really got to familiarize yourself with that. And yes, some confusing logic, such as like things called actions, but really what it is a message object, and so on. So it's not the most intuitive. Another problem is that Redux is infamous for having huge amounts of boilerplate and really bloating your code base. You need tons of files and directories for actions and reducers, and you need to manually define, sometimes hundreds or thousands of selectors, and it's hard to maintain, and it adds a ton of files to your code base. And then every time you kind of want to extend your state, add a new facet to your state, you've got to update loads of different files in loads of different places. It's also not the most performant. It's quite easy for Redux apps to become very sluggish. Yeah, it can be pretty heavy performance-wise. Another issue is that there's no kind of obvious way to handle side effects, being asynchronous events like outside of the control of your app or outside of your state. And that's where like Redux middleware and thunks and stuff come in. but it's not as easy as it could be. I will say there's been some new kind of approaches to Redux itself in recent years to try and address some of these concerns. Things like Redux Toolkit gives a lot of tools for streamlining and trying to address some of these problems, and it does a pretty good job. But it still suffers some kind of core drawbacks of Redux, being it still needs quite a lot of boilerplate, a lot less than classic Redux, but still quite a lot. And it still struggles with the kind of absolute immutability of Redux. Immutability is generally a good thing, but Redux kind of takes it to the extreme and really relies on this fundamental principle of the entire global state store being entirely immutable. And we've seen, like in Redux Toolkit and even in Redux itself, a lot of steps to try and kind of sidestep this to actually make it a bit more usable. Redux Toolkit claims that it implements mutative immutability, which is kind of a paradoxical concept, and brings in concepts like slices, I think is the term in Redux Toolkit, for allowing you to kind of modularize your state store a little bit. But it's all kind of Redux inventing its way out of a problem that it created and requiring the developer to do the mental labor of learning the new kind of concepts. And it's still quite easy to write not very performant apps with Redux Toolkit. So yeah, I'm going to look at a state management library called MobX and MobX State Tree, which is kind of built on top of that. So there's kind of three parts to this. We have MobX, which is a functional reactive state library. And this is kind of the engine that drives the state management. MobX State Tree is a state container system built on top of MobX. So it gives it some kind of usable structure with models and stores and so on. And then in this React app, we've got MobX React, which is a really cool library that lets us wire up MobX to our React apps in a very performant and efficient way. So if we jump into the code here, and I can show you what I mean by some of these concepts. So let's start with the very kind of basic building block here, which is a model. So first thing we get from MobX State Tree, we get types, which are what they are, a type. These are typed at runtime. So you don't have to use TypeScript to get this type declaration here. One of the types is a model itself, and then it also contains more primitive types. So as you saw from the previous screen, the example here is super basic. It's just an app that has a counter. You can count up or count down or fetch a random count from an asynchronous source, just to demonstrate some of these concepts. So our most basic model is just a counter, and that counter has a property called count, which is a number. Very straightforward. But yeah, your models can be anything. In one of my current projects, we have a React Native app that's using MobX State Tree, and we have models for our user accounts and so on that are quite rich and fleshed out. So then we define a store, and a store again is itself a type of model from MobX State Tree, but it's a model that can have actions and views. So I'll go from the top down here. Our store contains a counter, which is that model of the counter that we just looked at. And it also contains a more primitive property of just a status, which is a string. Then on our store, we can have actions, and those are where we can update our state. So all of the properties of the state in MobX are always immutable except for within an action. So we have an action here to update the count, and that means we can update the value of our counter or the status and so on. Again, pretty straightforward. Then I mentioned, side effects earlier, fetching data from an asynchronous source where we can't control how long it takes, and it's going to come from an outside context. MobX State Tree makes this super easy. It gives us this flow, the concept of a flow, which just wraps a function and lets us do asynchronous stuff. So here we have a flow wrapping a generator function here, which for anyone not familiar, a generator function is basically a lower level version of an async function. And we use generator functions instead of async because generator functions allow us to maintain the context when we jump in and out of them. So that's crucial because we need the context of being in an action. Otherwise, we won't be allowed to mutate our
Jason, can we ask you to up the font size a small bit? There's some people saying they can't see it.
Oh, yeah, sure. Yeah, no worries. Sorry about that.
Lovely. Thank you very much. Sorry for the interruption.
No, that's great. Hopefully that's a little bit more readable. Let me know if that's still too small. But yeah, as I was saying, we need to maintain our context of being within an action so that we can change our state. If we used async here, as soon as we hit an 08, we kind of lose that. We have to jump out of the action context. So when we come back from the 08, we're no longer allowed to update. So that's just why we use generator functions. But yeah, we have a simple generator function where, in this case, I'm just fetching a random number from an API, just as an example of an asynchronous action. Yield functions just similar to the await keyword that everyone will be familiar with. So we yield a random number and then we update our state with that, and just wrap it in a flow, and simple as that. And then the last part of this is views, and views are computed values. So kind of common logic that we want to do on our data, transformations we want to make before the data is consumed. So we're working with a count, which is just a number here. Again, a pretty kind of trivial example, but say we wanted to get that number as a binary string. Maybe we have 20 different components all using this store, and they're all going to want to do that computation. We can just do it here in a view and provide it in a getter. These values are also cached. So when it computes the count as binary or whatever it is in your view, it won't recalculate it until the state value itself changes, and then you can query that from anywhere. So those are our kind of building blocks of our state store. So then if we just look at how this is implemented.
Jason, just
Yeah.
1 second, it's Anna. We got few comments and people asking you to zoom in a code because they just can't see it. Can you just go to settings and increase your code a little bit?
Zoom in more.
Yeah, and keep it like that because they just can't see it and ask
Is that okay?
Yeah, I think it should be perfect. Thank you.
Okay. Sorry about that. Okay, I'll keep going here. So if we look at how, let me just zoom in again. If we look at how we want to use these, the state management in our React app, that's where MobX React comes in. And MobX React gives us this concept of a provider, which allows us to wrap our app and provide our state to our components. So it's as easy as just, the home component is the kind of main app here. We wrap it in a provider and we say, I have a store called state. I pull it in from the state store and provide that. MobX also allows you to have many stores, as many as you want, unlike Redux, which kind of has one immutable store. MobX lets you have loads. So if I wanted to have another store equals whatever, I can provide as many as I want here and access them all separately. But for here, we just have one. So we provide that, and then if we jump into our main component, we can see how we can access that. Again, from MobX React, we get a provider context where we can use the use context hook and get our state store from MobX's provider context. And now we have access to our state store. So we can call the actions, update count, whatever, or we can access the properties of the state, such as status or count, or our view count as binary is in here as well. And then the way that we know when the state changes and we know to re-render is that this whole function is wrapped in an observer, which is another thing we get from MobX React. We wrap our function in an observer, and then anytime a value that we use here changes, it'll re-render the component. And the really cool thing is that it will only re-render if the specific properties we use change. So in this state store, if status is the only thing that's actually used in our component, this component will only re-render when status changes, even if other properties in the state store change. So if I jump back to this screen, and I can show you guys, it's obviously a very basic demo, but all of these things kind of working together. Here we have our count 1. Here we have in brackets our count in binary, obviously also 1. So these plus and minus buttons increment and decrement the count in our state as just regular actions. And as we do that, it updates the state, the component re-renders. The view value is recomputed because the count has changed. And then if I want to do something asynchronous, like fetch a random count, we see the status property updated, and then asynchronously we come back, it updates the state with the new random count that it's fetched and refreshes the page with the new state. And one thing I can show you is what I was just talking about with the rendering logic. So if we pop a log statement in here so that we know when we're re-rendering. And let's say we only care about the status in our state. We don't care about the counter or its count. So let me just replace this with just a string that says count, but we're not actually looking at the value of the counter. Now, if we fetch a random count, we see re-renders because we've updated the loading status, and sometimes we get multiple re-renders just because this is it's an artifact of it being a development build. Yeah, the loading status changes, we re-render, it changes again and disappears, we re-render again. But if I hit these action buttons, plus and minus, I'm clicking this and you can see there's no re-rendering. So we're changing other facets of the same store by updating the count, but this screen doesn't use that, so it just doesn't re-render. So yeah, I'll summarize with some just reasons why this is more performant and some of the pros and some of the reasons I like using MobX in this way. So as you can see, it's pretty lightweight. There's not much boilerplate. It doesn't take much to instrument your app with this, especially with MobX React, which is a really powerful tool for just wiring it up so quickly to your React app. It's pretty intuitive and simple to use. It leans on a lot of mental models that developers will already have. You can kind of learn it in about 20 minutes. It's pretty straightforward. It gives you the ability to modularize your state with as many different stores as you want and kind of separate out your data in helpful ways. And as I was just showing, it's very performant. So it allows components to re-render only in very specific scenarios and observe just the facets of the state that they care about, rather than kind of changes to the state trickling down all over the place. We only need to respond to relevant state changes. It's also very easy to maintain and scale. Adding a new property to our state is pretty much a one-liner. And yeah, it scales up really nicely. Then there's a few drawbacks, obviously, there always is. So some cons to this approach. Not a lot of teams use it yet. I think maybe 10% market share or something. It's hard to find actually official stats on that, but I think something around that. So it doesn't have the kind of universal context of Redux, although every team kind of uses Redux differently. So even that is not quite universal, but yeah, MobX is still a little bit niche. The documentation and the community resources are definitely not as plentiful as Redux. There's a ton of blogs and Stack Overflow and community resources for Redux because so many people use it. And Redux has really good documentation. The MobX documentation is okay, but it's not amazing. And then there's some little technical issues, such as we saw that there's runtime type checking with the types that we get from MobX state tree. If you're using TypeScript, those always don't always mesh super well with TypeScript when you get runtime type errors. So sometimes the error messaging is pretty unclear there. just from the interplay between TypeScript and MobX state tree types, they can't always understand each other. So you can get some confusing type errors. But yeah, I think I've certainly found, in my work that moving to MobX was a really great change and really easy to learn, and allowed us to instrument new apps with pretty powerful state management very, very quickly and easily, and it performs really well. So yeah, I think that's everything I had to say. And yeah, if anyone has any questions, please fire away.
Jason, thank you very much. That was fantastic. There are a lot of questions. I guess when you push yourself forward as an expert, you get a lot of people wanting to ask questions. So we'll try and get through as many as we can in 5 minutes. I see React Query has been mentioned a few times. So let me pick one that's kind of talking about React Query to box this off. Basically, why bother on front end if we can have React Query now on the back end? So what are the benefits of using a client state management in context of server state management like Tanner's React Query?
Yeah, that's an interesting question. I've actually never really used server state management. I've never used React Query, so I don't have a lot of context to answer that. Yeah, the apps I've worked on and the way my kind of company's always done it has just been with the assumption of client state management and how we can optimize that. So I'm not super informed really to comment on the trade-offs against server state management. Yeah, I don't know a lot about React Query.
Absolutely fine. Good. Pass. So there's a few other questions I see grouped as migration questions. Let me see if I can get one that covers all. Oops, I'm under pressure now to pick one. And as I'm trying to pick them, they're moving, which makes it slightly more awkward for me to read them. Here's a possibly simple one. As we have hooks now, should we totally eliminate Redux going forwards?
Yeah, that's a great question. Yes and no. I mean, no, not totally eliminate. Hooks are really powerful and really useful, and they can take a lot of things off Redux's plate. So any local state that just exists within a component, hooks are great for that, and you should definitely use them for that. So they can do a lot of work. If you try and I think really what happens if you try and take them too far and kind of implement a more kind of rich global state management framework, just entirely relying on hooks, you kind of end up building something Reduxy anyway, in a kind of convoluted way with hooks. So it's not as simple as just eliminating Redux for hooks. I think the answer really is letting each do what they're best at, and a kind of hybrid approach that lets hooks handle local stuff and Redux handle global stuff in a way that plays nicely with each other. That would be my kind of my view on it. Yeah.
Okay, very good. Then going back to the migration topic, how could we approach async troubleshooting and moving away from the Flux store paradigm?
I'm not sure what that means. Async troubleshooting when moving away from Flux. Yeah, sorry, I'm not really sure what.
Okay,
what
it's called web love. I got that. I don't know what it means either. I'm not a Redux person, so I don't know either. Okay, we'll take one more question. Let's see. So MobX specifically, is MobX also supports? Is MobX also support a logger middleware, or is the logger already part of MobX library?
That's a good question. I'm actually not sure. I know that there's not a lot of kind of third-party middleware for MobX. There's not as many extensions and kind of middleware plugins as you get with Redux. So I actually haven't tried to use a logger with MobX, but if it doesn't come as part of it, my guess would be that there isn't one out there. But yeah, that's not something I've used. But yeah, generally there's not a whole lot of, kind of extra plugins and stuff for MobX. So yeah, it's also a very lightweight library. So
no problem.
I would guess it probably doesn't come with a logger built in, but I'll have to check that and get back.
Okay, right. Unfortunately, we have run out of time, and there were loads more questions in front of me here. So, Jason, if people want to follow up with questions, will you be available in the chat after this session?
Yeah, I can hang around for a few minutes.
Or you can just add one or two questions just in case something just came on top. So like 1 or 2 questions we still can ask. And then, because we really have a lot, maybe we can just cut it a little bit here, and then you can answer others on the platform, okay?
Okay, so we go for 2 more questions. So
Okay.
a functional component is much faster than a class component, right?
I mean, I don't know if it's much. It's not. I don't think there's an inherent big performance difference. We're moving towards functional components because it's just a more modern approach and a more modern React architecture with functional components gives us things like hooks, which are more powerful and succinct. And it's, yeah, the code's a little more succinct and readable. I don't think there's a huge performance difference, but I might be wrong in that. They may be a bit faster, but I know that, I don't think performance difference is the main reason for the move. It's just a more modern approach.
Yeah, no, I'd agree. Same thing, just laid out differently.
Yeah.
Okay, and then we'll finish up with this question. How difficult is it to migrate this sort of state management from Redux? Does it tend to mesh rather well?
Yeah, it is quite difficult, mainly because Redux ends up kind of dominating the architecture of your app. So, the first half of that migration, kind of moving away from Redux, is pretty hard, because it's just, you end up with your code base kind of oscillating around this Redux model, and it takes a lot of work to undo that. As far as adding MobX into new components or kind of introducing it, that part's easy. It's very quick to instrument parts of your app with MobX. But yeah, once you're deep in the trenches with Redux, it's hard to get out.
Okay, very good. Right, we'll finish up there. So Jason's going to stick around for questions afterwards. And Jason, if somebody wants to contact you after the conference, do you have it on Twitter?
I'm not on Twitter, but I'm on LinkedIn. Just I think my LinkedIn maybe is in the website for the event. But just, yeah, Jason Hogan on LinkedIn. I should be easy enough to find, and that's the best place to contact me.
Perfect. Excellent. Jason, thank you very much for joining us.
Okay, thank you. All the best.
Okay, brilliant. Right, the next person we're going to bring in will be Milica, and I hope I pronounced that correctly. So Milica, I'm going to add you to the stream now. Milica, how are you?
I'm great. How are you doing?
And where are you calling from today?
I'm calling from Serbia.
Serbia, very good. I'm doing very well.
Yeah.
Thank you very much. So you're from, let's pull in my notes. You're from Baden-Soft. Would you like to share your screen and we can get going?
Sure. Yes.
Oh, I have to add your screen. I beg your pardon.
Yeah. Thank you. So, hi everyone. My name is Milica, and I will talk about switching from React to React Native. And in this talk, I will go over the challenges you will face in your journey when you're transitioning from React to React Native development. And I will explain the React Native concepts and how to get started with mobile development. As well, you will see how is React different from React Native. So a little bit about me. I'm a software engineer with experience working on React and React Native application. You can also find me on Twitter and Instagram as Milica. And I work in a company Soft, which is located in Serbia in City Niš, with a strong transition in technology and engineering. So as you're familiar with web development and web application are built using the standard web technologies, including HTML, CSS, and JavaScript. And they run inside of the standard web browser like Chrome, Firefox, Safari, and they're built and hosted just like any web application or website on the internet. And the only real difference is that they're built to look good and to function well as on mobile devices and mobile development. But mobile development is a little bit different. And to write a successful React Native app and mobile app, you will need to cover both iOS and Android platforms. And iOS and Android apps are like completely written in different languages. iOS uses Swift or Objective-C, and Android uses Java or Kotlin. And to build an app for both platforms, we need to create two separate but identical applications, which more often means that you will have to have two separate teams in order to develop and maintain both applications. So it can become increasingly difficult to keep the UI and features in sync on both platforms. Mainly because also you need to pay the both engineering teams as well. So instead of having to write the same application multiple times, you can write the one application and all using React Native. That means that for the most part, we are no longer required a deep understanding of Objective-C or Java in order to effectively be mobile developers. And instead, we can use our existing knowledge of React and JavaScript to build this application. So because of this, you can use React Native, and on web, you will previously use React. So starting with React Native comes naturally for React developers because you have a lot of similarities. You will still use components as building blocks. You will use the state and props the same way. You will still use JSX, and you can still use your favorite state management library like Redux or Mobex or something else. But there are a lot of challenges and a lot of differences between mobile and web and React Native. And the first one is development. When you're developing a mobile app and React Native, you're also developing both iOS and Android. And for that, you will need to get familiar with Xcode and Android Studio. But also for that, you will need emulators, simulators, and devices. Because for web development, you only need a browser. For web, you're familiar with the browser. It's easy, just open a browser and start developing and testing. But for mobile, you will need, like I said, to cover iOS and Android. And that means you will need emulators and simulators to build your application. And in that case, simulators are good when it comes to testing or building an application, but they can be wrong in some cases because a simulation can never replicate 100% of the real device, because you will find your app working great on emulators and then build it on your real device, and then you will see that not everything is working so smoothly. So one more tip that I can give you that Android, you need to cover a lot more devices. There's a lot of them, a lot of different screen sizes. So the best tips I can give you is to always test your application on the real devices through the development process. Especially on iOS and Android, if you want your application to work on both platforms. And as I said, maximize the devices you're developing and testing, because everything can be great on iOS, but on some version of Android, it can be running everything smoothly. And also, as I say, like automated both iOS and Android releases, because like you will need to test both on Android and iOS as well. And there is like the next change I want to talk is in React Native, there is no HTML. So when you set up your development and like start to build your first application, the first thing that you will notice is that there's no HTML. Like name for elements you will use in React are different in React Native. So when you're using in React like div, section, header, now you will use like view in React Native. And you will use span paragraph in React, now you will use text. When you use button in React, now you will use also button component in React Native, but also you can use touchable opacity and touchable without feedback. And input is still an input, but now we are using component that is input text. And React Native gives you like a set of basic components you can core components that you can use to build your application that are like ready to use. You can just import them from React Native and start developing your application. So in that, there is like, as I say, view, text, image, text input, scroll view, style sheet. There's also component for user interface like a button and switch. And there's also component to use when you want to show a large list of data like list, like flat list and section list as well. But there's also many other components like activity indicator, alert, animated, linking, keyboard that is like can be specific for just like mobile development, and you need to get familiar for that. So what will be looking like basic example in React Native when we want to display the hello world? We will use our text component, and we will use for the view component, view and text we will import from React Native, and just like in React, you will use them, and like the text will display on your mobile device. The next change I want to talk about is styling. So styling on the web, you will use like with React also a CSS. And a class name is associated with DOM element, and CSS target the element with the class name and inside the set of properties with the associate element. For React Native, you cannot use CSS because React Native does not use CSS for styling. Styling in React Native is done using JavaScript. Since React components have support for the style property, you can also create an object of set of values and pass them onto the component as props. The style name works exactly the same name as in the CSS, except they're written in camel case, as you can see in this example. And a flexbox is still here. A flexbox works the same way in CSS with a few exceptions. The flex direction is now defaulting to the column instead of the row, and the flex only supports a single number as a parameter. And one tip I want to give you when styling is in React Native is that you can use the style components. Style components is the popular CSS in JS library, and it allows you to write the actual CSS code to style your components. And benefit of using style components is that you will get the CSS syntax out of the box. You will get dynamic styling. You can use theming as well. And if you're familiar with style components and use it on React and in the web, my advice is to like go for it and like use it in React Native. It helped me a lot to get the transition from and switch from React styling to React Native styling, and it can be like really helpful and really useful. The next thing I want to talk about is animation. And working with mobile, users have like higher expectation because the mobile application just feels like a lot better than web application. And users really expect your mobile app to flow with some of the standards. And animation are really important to create a great user experience. React Native provides a complementary animation system, what is animated for like granular or interactive control specific values, and other is layout animation for like animated global layout transition. So let's just see the first. First is animated, and the animated API is designed to express a wide variety of interesting animation and interaction pattern in a very performant way. Animated focus on the relationship between inputs and outputs with comfortable transforms in between. And like you can use start, stop methods to control your time-based animation execution. And animated exports 6 animatable components for you to work with, that is view, text, image, scroll view, flat list, and section list. But you can also like create your own using animated, create animated component. And the next one is layout animation. Layout animation allows you to globally configure, create, and update animations that will use for all views in your next render layout cycle. And this is really useful for doing like Flexbox layout updates without bothering to measure or calculate specific properties in order to animate them directly. And is especially useful when layout changes may affect like ancestors, like for example, like a CMOR expansion that is also increasing the size of the parent and pushes down the road below, which will otherwise require explicit coordination between the components in order to animate them all in one sync. And I also want to mention Reanimated. Reanimated is also powerful gesture animation library you can use with React Native, and is like really great. Next thing I want to talk about is navigation. Like in browser, you have a URL, you will have a current page, a back button for history, and you can use like React Router to handle the change and go to the new page as using React. And if you're using React, you're like familiar with that React Router, React Native, and React Native has still like support for React Router, but there's like 2 libraries that you can use for navigating in React Native. That is React Navigation and React Native Navigation. So as I said, in the mobile, you will have the screens instead of the browser, and you will navigate those screens using like several well understood patterns like tab navigation, stack navigation, and backstack. And navigation works like you're having different decks of cards where cards are screened, and you can define different decks of screens for each purpose. And this is because a user could add or go back to a previous screen. It is important to know that on the native, you start from the first screen defined on the deck, and when you add a screen, it goes to the top of your deck. When you go back, it goes off to the top of the deck as well. And this means that the first screen is loaded in the background till you dismiss the stack or go back. Next thing I want to talk about is like platform-specific code. So unlike React Native addresses the need to write like different code for different platforms and build app that follow that platform-specific UI and UX guidances. So React Native offers 2 alternative ways to build like across platform apps. So the first one is platform module. React Native provides a module called platform to detect which platform or which version of platform you're developing for. Like if you check, it is Android or iOS. And it is especially useful when you're using components that contain only a small part of a platform-specific code. So how do you use it? You will like import platform from React Native and then like check if the platform is iOS, and you can set like a different dimension, write a different type of code, and this can be, like I said, really handy. The next one is a platform-specific extension, and React Native will like load matching files for specific platform by automatically detecting whether the file is working has extension .ios.js or .android.js. And this way you can be sure that each time you are like coding for iOS or Android, React Native will always like input the correct required component. Next thing I want to talk about is React Native app state. And that is really one more thing you like don't have to worry on the web, and that is like important to think about when you're working with mobile app and with React Native is that your user can have your app in the background or like in the foreground. And this is very important because you don't want like a user putting your application in the background and then like come back and your application like show anything. Like you want to like update some state or like refresh your calls and like to show the user the right information. So for that, you can use the app state from React Native, and it can tell you if your app is on the foreground or the background, and it can notify you when the state changes. So you will have like 3 states that you can use, like active, when the app is running in the foreground, like background, when the app is running in the background and the user is either in another application on the home screen, or it can be another activity, maybe like there's incoming call or multitasking just. And this is like really handy to like have, and you can use it like in this example, you can use it from the React Native, like import app state, and then like just check whether your application is on the background, and when it comes to foreground, like just to update your state and show the correct data. Next thing I want to talk about is offline mode. When we're talking about mobile devices, your connections may be slow, unreliable, or your device can be offline. And you must build your software to support these cases. And beginning with connectivity prompts and including like offline methods such as caching, and be prepared for the possibility of the connection breaking in the middle of the network activity. So you always need to check what type is your application. Like, does your application need all the time access to the internet, or it can like work offline? And you can always see what makes your offline app good. Like, will you like display some cache, or you will like show like just the screen and like the message that there is no internet connection, and for user like to check internet connections and maybe like button to refresh the page and like to show what is happening. So for this, my advice is to check the net info package that provides information about the user's active network connection and connectivity status of their mobile devices. And it is also identified the user's current network type, such as are user using the Wi-Fi, or user are using in the app the mobile network, and that can be really handy to have and like to check in some cases when your app is like needs to be connected to the internet. One more thing I want to talk about is upgrading React Native, and this can be like really challenging because typically React Native projects are especially made up for an Android project, an iOS project, and a JavaScript project, and upgrading can be like really tricky. And there is currently the 2 ways for upgrading your React Native projects. The first one is that you can use the React Native CLI, or like the React Native CLI comes with upgrade command that provides a one-step operation to upgrade the sources files with a minimum of conflicts. And it's like you just write the command upgrade, and then you can write your version you want to upgrade your React Native. And the next one is React Native Upgrade Helper. And that is a web tool to help you when upgrading your apps by providing the full set of changes happening between these 2 versions. And it also shows you comment on specific file to help understand like what is really happening. As you see, like you can enter the version you're currently on and the version you want to upgrade, and like it will like show you all the differences that is happening between these 2 versions and help you to upgrade correct way. The next thing I want to talk about is testing. So developers make mistakes, and testing is important because it helps you like uncover those mistakes and verify that your code is working. And perhaps even more important, testing ensures that your code continues to work in the future when you add some new features, when you refactor the existing one, or upgrade the major dependencies on your projects. And the default template of React Native ships with its Jest testing framework, and you can also use Jest to write your test in React Native. And there are several libraries that can help you testing, and that is React Test Renderer, that is developed alongside code, provides a React renderer that can be used to render React components or pure JavaScript objects without depending on the DOM or the native mobile environment. And the next one is React Native Testing Library that builds on the top of the React Test Renderer and has like environment and query APIs to describe like the next paragraph. The both applications are really great, so you can choose whatever you like. The next thing I want to talk is debugging. For debugging, you can use in the web, like Chrome developer tools, but with React Native, one thing that really helped me to debug is the Flipper. Flipper is extensible mobile app debugger that is like a platform for debugging iOS, Android, and React Native application. It can like help you visualize, inspect, and control your apps from a simple desktop interface. And Flipper is a tooling that I strongly recommend for mobile developers to try on, because using with Flipper, you will also inherit the plugin ecosystem that exists for native Android and iOS application. And this means that you will be able to use plugins that are aimed at native apps for React Native as well. Like you will include like device logs, device crash report, inspect network requests, inspect app local database, and like cached images and much more. The next thing is like deployment, and on the React Native side, we are like using the native way of deploying application. And remember that React Native is only a tool for writing native apps. You will also have to build and upload your builds for iOS on the App Store, for Google to Google Play Store, and for Huawei to App Gallery. And after your build is uploaded, for example, on Apple, and it will run some automated tests that your app for your app, that it can show that everything is working. And after this, it can like test your like application, and it could take like some time, like maybe a day to your app to pass like this review, or maybe a week. And it is really important here to note that each deployment will need to pass this validation from Apple that will make some days in order to your release to be available to the end of the users when testing phase is over. And I want also to mention the code push. So for Google, you will use the Google Play, but also code push is part of the App Center. So code push as a part of the App Center cloud service that React Native developers like can use to deploy mobile apps update on their user devices. And this can be like really handy because especially when you in a team working with a tester and there's like some bug and you like need like some quick changes, and then like you want to your tester get your build as fast as possible. You don't have to build your application and then to send them. You can use like code push and just push your changes directly to their phone and their mobile device, and they can like check it if everything is working correctly. So that will be all. Thank you so much. I hope that my talk helped people moving from and switching from React to React Native, and my tips were useful from you, and like you can learn from my experience.
Milica, thank you very much. That was fantastic.
Thank you.
Cool. We have a lot of questions coming in, so we'll get right to them. The first one here is actually two questions pumped into one. So with regards, oh, I actually clicked on the wrong one, but let's go for this one instead. What advice would you give to beginners about learning curve for React versus React Native? Which is faster to learn? Okay, so if you're coming at this, what should you learn first, React or React Native? Which is faster?
Yeah, so for me, it was easier because I already knew React. So switching to React Native, you like come to a lot of things that you're familiar and you already know. But I think the people like going straight to React Native that can like goes well, because you then need to like to get familiar with React and like their concepts. So I will advise, if you just to check the React, like get familiar with, and then start with React Native, because that process will be really faster and you're like familiar with the concepts of React.
Yeah, makes sense. So React for the basic concepts, and then go to React Native after. Okay, this question here was the one I was actually meant to click on. What is the performance compared to, well, comparing React and React Native, which is faster?
Yeah, that can be like, I don't think you can compare this, because React is on the web and you're using web application. React Native, you will build your mobile application, and the performance of your mobile application will be like really depend on your code. And we are working with like 1 million of users, and our React Native applications are really fast and are looking really great. So I don't think there's like a really much like comparison between those two. I think the both React and React Native can build like a really fast app for you to use, like, and distribute to your users to try.
Absolutely, makes sense. What about comparing the performance of React Native versus actually natively writing for Android or iOS?
Yeah, that's interesting, because also like native application can work like really fast, but also React Native is like built really good that your application can like only depend on your code. It may take some time to build your application and distribute. As working as React Native performance, I don't think like there's something that is like really going to slow you down.
Okay, very good. Then move on to the second part of this question. Do you have full access to camera, GPS, power management, optimization, etc.?
Yes, you will need, for like example, the camera, you will need to make adjustment and like to try and for your users to give you permission. So that is like exactly the same for like using the native application. For the native, like you will also need the permission from the users to use those, and for React Native you will also need like to code that and like ask the permission from your user so you can access their camera or GPS or like anything.
Very good. We have a few different questions with regards style, how you manage the style. So we'll go with this one. How do you prefer to define common styles across components, like typographic styles?
Yeah, for the styling, I like I said, like I really recommend style components, like that work really great for me, because on React you can also use style components like to write the style to your components, and for React Native that really helps me because you can also use the CSS like to write in React Native, and that you cannot do without style components. Without style components, you will need like to use the style sheet and like to make adjustment like the CSS in JavaScript.
Okay, and then a kind of a follow-up question on that. Do you find it easier to maintain style components in the same file, or would you have a more modular approach like the web?
No, I always like separate those, because the components, I mean, ideally is not they're big, but they can be cases the components are big, and like just like so when you have the two separate files, you will have like much cleaner and much like you can like track what is everywhere going. So I will usually make the style.js separate, and in that file I will like write all the styles for the specific component, example like button, and the code for the button will be in the separate file like button.js.
Okay, very good. In regards to functional versus class components, you appear to have used both in the examples. Is there any pros or cons to using either way? Within the context, obviously, of React Native.
Yes. So in React Native, like when I started using React Native, like there's already like functional components and hooks and everything with that version. So like my advice is like to go with functional components. Like you can use exactly the same as in React. You can use like hooks. You can use your file state management library. Like there's like really great, and like I recommend you to like to try it, just like write some React Native code, like try a functional component, and like you will see that it's much easier for me than class components.
Okay, very good. Next question is TypeScript. Is your support, well, what is the TypeScript? I'm getting tongue-tied. What is the TypeScript support like?
Yeah, so React Native, you can use the TypeScript support for that, but like currently in my application user JavaScript, but like, yes, I'm like really great. I think the TypeScript application are like really great, and like I will recommend like everyone to use TypeScript as well.
Okay. What are the React Native advantages over Flutter and Dart?
Yeah, so I don't like to compare those like React Native, Flutter, and Dart. Like every library has our advantage for that library and like pros and cons for that. So for me, the React Native was like just the, as I say, like the easygoing way because I knew React before, but like Flutter is also a great, and if you're like considering between those library, I will advise you like just to think what is best for building your application. It can be like React Native, it can be Flutter, it can be Dart, like that is really specific. Those are like really great libraries, and just like think what is best to use in your application currently.
Very good. Okay, let's move on to issues, compatibility issues. So can developers run into compatibility issues with packages for OS and Android or debugging tools?
Yes. So there is like really issues with that because some packages like you can use on iOS, but they may not have support on Android, and that can be like really tricky. Like always when you're like using your and like thinking about which like package we will use and like which library you will use, like always think about that. It will need, if you're building the app for both iOS and Android, like does it like work for the both platforms? Like, and as I advise you, like always test your application, because it can be working on iOS, but there can be like some packages like not compatibility with Android, and your maybe feature is not working correctly on Android as well.
Okay, very good. What is the use case for React Router instead of React Native Router on mobile?
Sorry, can you repeat again? What is?
Sure. It should be written on the screen as well. What's the use case for using React Router instead of React Native Router on mobile? If it doesn't make sense, we can skip.
So when using on mobile, you will need like to use navigation like React navigation, because you will like need the screens. You can like go from one screen to another. You can implement the button tab navigation, like you will have like the stacks of screen, and on the web you will have like navigation, the URL, browser, and just like passing between one route to another. Switching between routes cannot be done on React Native because you will have like screens instead of routes. So you will need like to switch between the first screen, the second screen, or the last screen, like just to navigate the user from one screen to another. Like just it's a little bit different on React Native, but I'm sure like if you just check it and like try it, you can see that it's not like really too hard to like just get to know without and like use React Native navigation.
Okay, a quick question. Any suggestions for a library for Bluetooth, spelled wrong, devices?
Yeah, about that I will need like to check and like to write you in the Q&A section, like to answer you later maybe.
Okay, very good, no problem. Okay, when's it bad to use React Native? When should you be going native, like Swift or Kotlin?
Yeah. So about that, like as I said, it's really depending on your application and what you want to build. because maybe React Native is better choice because you want to develop, you have one team and you want to develop like application to work both on iOS and Android. And if you go native, you will like need separately to work on iOS and Android, like maybe to have like two separate teams that can work, and that can be in some views like maybe expensive much because you will need like two separate team. And if you just want to your application to work with Android, you can do that with natively, but you can also do it with React Native. Like with React Native, you really get the with one code you get the two application, and that I think like is really better choice for me because I come from the web, I know React, I want to build both iOS and Android, and like for me is like better choice in that situation, like just to go with React Native.
Okay. Now we'll go to this question. How do you upgrade React Native correctly when there's a lot of libraries? So any tips you'd have for a project you're about to do from scratch? How would you approach a big migration?
Oh yeah, that can be like real tricky. I know like React Native upgrades, even like you need like to follow them. Like my tip is like to use the React Native helper. It helps a lot because you can see all the changes, but it can be also tricky with libraries. Like if you're using the third-party libraries, you need always to check if that library is following with your React Native updates, because it might just not be, and like someone stops supporting that library and stop like following those, and that can break your code and like get the results that something is not working on your application. And like because of that library. So like my tip is like always follow the React Native upgrade helper, like follow the changes, but also check your third-party libraries that you're using that are following those like React Native versions.
Okay, and let's do one more question. Let's go for this one here. What do you recommend to automated pipeline to deploy in stores?
Yeah, so to
Does that make
automate
sense?
your what helped us like was also like I recommend like the code push. Like I recommend you to check the Firebase. Firebase has app distribution that could you easily like distribute your app and check your app, that you also have like the beta group that you can like really check. And for automated pipeline, like I don't know, maybe like just like try to make that process as easier as you could, because building the apps for both, you need to build both Android and iOS and to release them. So like yeah, definitely I will do the automated deployment stores.
Perfect. Excellent. Okay, I think we'll leave the questions there. So Milica, will you be able to hang around and chat afterwards if people have more questions?
Sure.
Fantastic. And if people want to get in contact with you, if people want to get in touch with you offline, is Twitter the best way to go?
Yeah, you can like contact me on Twitter as Milica or on Instagram. Like I will be open to answer all your questions. So please.
Lovely. Excellent. Milica, thank you very much for joining us. Take care.
Thank you. Bye.
Oh, right. And that's actually brought us to the end of the first quarter of today's sessions. So soon I'll be leaving. It's been a pleasure being the presenter for this part of the conference. You'll see me again tomorrow. I'll be moderating again. I think it's the first morning session, and then I'll be giving my talk later in the afternoon. So it's it's been fantastic. Anna, you're back. Thank you very much, Anna, for having me on. I'll hand back over to you.
Thank you so much for helping us with the first blog today. And I also have to mention that Milica will join us for like as moderator, like in 30 minutes. So yes, we'll see her again. And thank you for being with us, being so supportive, and see you tomorrow. Great. So since I came here, it means that I have what to say.
First of all, thank you for watching us and being with us. Secondly, remember from the beginning, we told you that we prepared giveaway 2 tickets for tomorrow or any other event, so you are willing to choose. So today or even now, we will do a randomizer and we will see who are the 10 winners, 10 lucky persons who will have free access for senior day. So I'll add it to the stream. So we added all names from the form that you sent us. Yeah, we checked also that it was not doubled one, only single one. So yeah, the same chance for everybody. This is an advantage to subscribe and to see what we're preparing for you. And that's why we're asking to register. So let's start and let's go who will get the 10 tickets. So first 10, yeah, also the 3 who submitted us. And now we can see first 10. Great, we will definitely get in touch with you like in 30 minutes and we'll figure out who can join tomorrow, who doesn't have ticket or who wants ticket for next events. Also, I have another kind of announcement for today. Since we're told that we have so many events, upcoming events that we're doing this season, next season, and yeah, we really have very schedule this month. So it's time to announce upcoming events. Next one that we will have really soon is Data Science Global Summit 22.2. You can find all detailed information on the website that you can see in the screen. Dates are 22nd, 23rd, and 21st of November. So we have 3 days of the event, 3 days of really amazing topics, great speakers, and I really saw a few of them. It's really great. So you can also use promo code REACH50 that will give you an opportunity to buy tickets with 50% discount. So please use it and get your ticket with promo 50%. Next event that they're really passionate about is Global Summit for Node.js 23. This event is also one that I'm preparing. So I'm telling you, I'm working very hard to get some great topics and great speakers who are not just contributors, OpenJS Foundation members, and so other great speakers. So please note the date. January 25th, 26th, 2 days. All detailed information you also can find on the website. And junior track is free as always. And senior track with promo code REACTFlash is $79 only. So please check website, check what we're looking for, or even if you have some ideas and you also want to join like a speaker, please reach me out. We can figure out it as well. Next event that we're also preparing for you is Angular Global Summit 23. That will be on February 14th and 15th, 2 days. So someone can spend 10 days watch Angular Global Summit. Again, all information you can find on the website, promo code REACTFlash, and you can get senior track, pro track just for $79. Please, you can scan the QR code or just check our website. And really great news. We started working on next React Global Summit. So React Global Online Summit will be our 6th event that we're working on. So it will be on 18th and 19th April 2023. Senior track just $49. So it's the earliest bird ticket that you can get. So please just register and it's really great opportunity for you. So now it's time for us to go for the break. Since Philippe, who has to speak with us, he got COVID and he really can't talk at all. So I took his time a little bit to do this announcement, and see you very soon for our next vlog and our great speakers. See you.
Hello everyone, my name is Milica. You already met me earlier. I was one of the speakers and I will be your moderator for the next few sessions, and I'm really excited to be here, and I hope you're also excited to hear our awesome speakers we have prepared for you. And I want you to introduce our first speaker for this session. It is Shedrack. Hi Shedrack.
Hi, Milica. Nice to meet you. Hi, everybody. I'm super excited to be here. I'm always happy to, share my knowledge with the JavaScript community.
Yes. So we're super excited to hear your topic. So I will add your sharing screen. So the stage is yours. You can start wherever you like.
Okay. Hold on. Let me just put my screen. Okay. See. Let's put this in full screen mode. Let's see if I remember how to do it. Hold on. Give me a second. Full screen. Okay. Hi everybody. My name is Shedrack Akintayo, and I'm excited to be here tonight, to share my knowledge with every single person here. Today's topic, what I'm going to be speaking about, is titled JavaScript tooling: the great battle of React build tools. So let's just get started. So who am I? My name is Shedrack Akintayo. Like I mentioned earlier, I am the developer relations manager at Wilco. Wilco is it's a platform that allows developer upskill while practicing in a real world environment. So you should check out Wilco. And I'm a software engineer and technical writer, and I am the founder of DevRel Community Africa, because of course I am in developer relations, and DevRel Community Africa is like an initiative for you to for African developers to get into developer relations. So that's about me. And let's just get started. Let's talk about what we're going to look at today. So today we're going to dive a bit into the world of modern build tools, not necessarily modern build tools, of React build tools generally, and JavaScript build tools in total. So we are going to look at what are build tools, right? I'm pretty sure you've heard build tools. If you've written code for a long time, you know what build tools are, but we're going to revisit that again. We're going to look at the evolution of front-end build tools, how we got to where we are at the moment in terms of build tools. Then we will also look at Webpack plus Babel and its drawback. So I'm pretty sure every single person had an experience with Webpack. If you've been in the front-end space, if you've written production code, at some point in your career, you must have either played with Webpack or had to learn Webpack to do something, or basically just to have the knowledge overall. So we're going to talk about, Webpack. Then we're not going to look at a couple of new generation build tools. The list is exhaustive, right? It's not exhaustive, rather. There's a lot of build tools coming up, but we're going to highlight some certain build tools, and I will leave the rest of the research up to you folks to check out the modern build tools. So let's just get right into it. So before we actually talk about build tools, right, we need to talk about why the web is built. Why is the web built? Why do we have to run build tools every single time we are pushing our development code into production? Why do we need those tools? Now, the first point is dependency management, right? Every single JavaScript application has a bunch of dependencies that they need in order to make the application work as expected, right? So these dependencies can take space. These dependencies are required during development or during production. So we build the web because we need these dependencies to be available when we need them, right? Not after, when we do need them. When we actually need them, we need it to be available to us. And the next thing is transpiling, having to change our code. So having to change our code, also having to transpile our code, we need a build tool for that. Also bundling, right? Having to bundle our code into smaller sizes, because if you write raw JavaScript from your development machine, it is heavy for the browser. The browser needs to be experiencing as little JavaScript as possible so that our HTML pages can load faster. Then minifying, of course, to minify our code, reduce the bundle size, and then module management isn't fully supported by browsers yet. So ESM modules are not entirely supported by all browsers yet. So irrespective of how far browsers has come, we still need a bit of module management in our application overall. Now, this is like a list of reasons why we have to build the web today, and even before, why the web has always been built before when it gets into production. Now, the next thing we talk about is what are build tools. Like, we cannot mention why the web is built without talking about the tools that actually encourage or help the web to be built. So the code used in production is different from the development code, right? So if I write code on my VS Code, right, and I run this web development server and it shows my application, right, that is not the code that will still run. That is not entirely the code that will still be used in production. It's going to be, go through a certain process called bundling, minifying, transpiling, to make sure that the code built faster in production, and the tool that helps you make your application, your development code built faster in production, helps it run fast, helps it manage dependency, automate certain tasks, load the external modules that you need, and more. That the tools that make it possible to turn development code into production level code based on best practices are known as build tools. So that's entirely what a build tool is, right? It's a code that helps take your development code, right, to production level code. And that's pretty much what build tools are. It's really, really important to understand that that's the entirety of what build tools are. Now, next up is to talk about the types of build tools. I'm pretty sure a good number of us are confusing build tools for specific build tools. Like, build tools is an umbrella name for package managers, for task runners, for module loaders, for module bundlers. So package managers like npm, yarn, pnnp are actually build tools, but are referred to as package managers. So build tools is an umbrella body, while package managers are types of build tools, right? They help take our production level code, our development level code into production. Now, the task runners. So task runners include gulp, grunt. If you've written things like SAS, if you've written things code, if you've written SAS, if you've written code like as far back as like when task runners were really, really popular, you'd have come across gulp and grunt. I'm pretty sure a good number of people still use gulp in production because it's like a very, very useful and effortless tool. Then we also have module loaders. Like, if you need to import external modules, module loaders are responsible for that. So Webpack, require JS, ASM loaders. Like, if you need to import external ASM modules into your code or into your browser, if your code uses ASM modules, so ASM module loader will help you import it in the right manner that the browser can actually make use of. Now, module bundlers. Now, module bundlers are like pretty much most of what we use today, right? But like the most popular build tools are module bundlers. So Rollup, Webpack, Parcel, Snowpack, Vite, which is pronounced as Vite, is also a module bundler. But that's pretty much like the umbrella, the subtopics under build tools, right? We have package managers, we have task runners, we have module bundlers, we have module loaders. Like, these are like really, really the most important part of build tools that we have today running in the front-end ecosystem. Now, the next thing we want to talk about is the evolution of build tools. So how have we gone from where we were before to where we are now in terms of building our JavaScript code? How far have we gone? What processes have we taken? And what processes have we taken? What are the highlights that we need to know? What are the issues we've accompanied across the years on when it comes to building the front end code, building the web? So what are those issues? That's what we are like. What are those improvements we've seen over the years? That's what we're going to highlight at the moment. And let's get right into it. So 2005 to 2010 was a very, very important era for build tools or for the web generally. This was when the era of the first bundlers. Like, if you've been writing code for as far back as 2005 and 2010, within 2005 and 2010, you would know that these bundlers ran the game. They ran the show as at that particular era, right? Those 5 years, the 5 years in between, was being run by these particular front-end bundlers. Like, every single company at that time wanted to be part of the pioneers of this era of web bundlers, right? So the major bundlers that were popular at the time where bundlers actually became a thing was Dojo and Google Closure Tools. Now, if you have been writing code as far back as 2005, you will know that Dojo was heavily dependent on Java, same as these two build tools were heavily dependent on Java. So it's just like how we are using Rust at the moment. We are having Rust-based build tools, like build tools that are built with Rust or Go to compile and execute JavaScript code. As at that time, Java, you know how Java was heavy and very, very large in terms of like, bundle size. Java at that time was being used as to create bundlers that was able to run JavaScript code. Now, the major issues encountered at that particular time was that it was heavy. Of course, Java is really, really heavy. It required Java. You have to install Java separately, and installing Java right from time has never been a very, very interesting exercise, right? So this was like a major issue for the first era of the bundlers. I mean, the bundling era was still very, very much new, and developers were trying to see or exploring different tools that was going to make their life easier. And for some reasons I do not really understand at the moment is why they settled for a build tool that was based on Java. It's just something. I mean, maybe I should speak to the developers that worked on it at that time. It's like, what was the idea behind using Java at that particular point in time? So it required Java. It had poor documentation. Like, at that time, documentation was not really considered to be a big deal, right? It's very, very recently, like in the new era or in the modern build tools that we had to, aside like having really fast builds, aside really having a great tool, one major part of developer experience is having a great documentation. Developers need to know how to use your tool. It's not just about okay, I have a very fast build tool. My build tool is awesome. It compiles in like 1 second, in like 2 nanoseconds. The question is, okay, you found out this benchmarking tool, right? You know that these benchmarks are real. But as a user, you want me to use your build tool. Why and how would I need to use your build tool? That's like one issue that was the first era of bundlers was facing. The documentation was really poor, so a lot of people were finding it difficult to utilize this build tool. Now, the next thing, another issue was it was incredibly slow. Like it took a really long time to bundle very, very tiny bits of code. So it was really, really slow, but developers had to put up with this because at that time, this was what was reigning, and it wasn't really considered as too slow as at that particular time. We call it slow now because, of course, we've seen faster things, like we've experienced faster build times. But at that time, it was slow. It was fast to them, but it was also slow. Like people that actually believed that front-end build tools could be faster believed that it was really, really slow. And that issue was, like I mentioned, poor developer experience, right? The developer experience, how a developer would use this tool was incredibly poor, and almost zero thought was put into the developer experience, right? Now, another issue especially with Google Closure tool is the fact that it was proprietary. Google had full rights over that particular tool. And if you've been in the software development world for very long, every single management or engineering team are scared of vendor locking. Right, vendor locking is something that people have had to switch to open source tools because they are scared of, okay, if this company decides to close down, or they are hacked, or this or that, what happens to my code? What happens to my information? Right, so people were skeptical on using Google Closure tools because of the fact that it was proprietary. Google had 100% rights over it because they made the tool. So this was like a really, really big issue. Now, this was like the era of 2005 to 2010 when the first bundlers were created. The first bundlers were Dojo and Google Closure tools. Now, let's see how far, in the next generation or coming years, how the build tool ecosystem improved. So in 2010, 2012, right, it took 5 years for some form of improvement to come to the front-end space, right, in terms of build tool. People saw that, okay, we need to increase how fast compile time takes. We need to reduce the amount of JavaScript going into the browser to have faster web pages. We need to make sure that the bundle size of whatever we are actually bundling is as small as possible, so that our browser can render it as fast as possible. So a lot of developers were now focused on, okay, let's make faster build tools. Now, Gulp and Grunt, if you've been in the ecosystem for long, you will know that Gulp and Grunt were like OGs in their time. They were the first to try and standardize and build reusable pipelines, right? They also supported plugins, so developers had the opportunity to create plugins and for whatever situation that they wanted to, simulate when their code is being built, right? It gave developers the freedom to write their own build scripts. Now, one thing at that time, the concept of, okay, if I want to run a build, I need to be able to write build scripts. And at the time of the first era of bundlers, there was nothing like that, right? A lot of people did not care about it. They just knew they wanted a build tool. And but as time advances, developers begin to see that, okay, here's how we can improve development experience for this particular product, right? For this particular issue, a build tool is as important as the web. It makes the web faster. It makes the web bearable, right? Have you ever tried pushing JavaScript to the web, a really, really large JavaScript app, without actually having some form of bundler or minifier? Just try it and come back with testimonies, and you would see how frustrating that particular situation is, because your page time would double increase, because the way code we run on our server, on our development server, it should be far slower than how it is in far faster than how it is in production environment. The production environment has to be faster, way faster than how it is in the development environment, which is why we needed build tools. Now let's talk about Gulp for a bit. Now, Gulp is like a really, really interesting tax runner. You could almost do anything in terms of simplifying your build process. You could write custom plugins. You could write custom build scripts. Okay, I need to be able to check my build size. I need to check my bundle size and run a particular script when it gets to this particular bundle size. Gulp was a game changer. The front-end ecosystem was happy, was excited that, okay, these are the possibilities when we pay so much attention into trying to make better code. These are the possibilities that can possibly come out of it. So Gulp and Grunt opened the eyes of developers and showed that, okay, we can have build tools that is fast, that shows great concern for developers in terms of improved developer experience, that can also work effortlessly and can allow us to configure and customize it however we feel like it. Now, these are like the era 2010 to 2012. This is the era of Gulp and Grunt. Now, it didn't take so long for people to, okay, let's introduce something that's faster, right? Let's introduce something that works better. So in the era of 2012, Babel, which is like the OG, which is like the top build tool we have today, was introduced. Babel was introduced to convert ES6 syntax to CommonJS, right? It helps us, every single build tool that you can possibly think of at the moment, or before, in the past few years, I've had Babel underneath it, helping to convert, ES6 syntax when ES6 was not really standardized across all browsers. Babel was there doing it, right? Babel was doing something differently. Everybody was trying to adopt Babel into their code base. It was perfect. It was solving a lot of issues. It also had support for older browser, which is something that the previous build tools did not have, right? Babel knew just how to, add in the right number of polyfill, convert, bundle and transpile your code in a form that every single old browser could actually use. So Internet Explorer at that particular point was supported, right? Internet Explorer was a big deal at that particular point. So a good number of people were using Internet Explorer. So you needed to write code that was working on Internet Explorer, unlike now where nobody really cares about Internet Explorer after the version 11. Now, it allows developers to also build custom plugins for their needs. This is why I mentioned that Gulp and Grunt, the era of Gulp and Grunt, really opened developers into the possibilities of what they can do in terms of like, creating custom scripts for how their build should run, or what should happen when a build is running or has run, or before a build runs, right? So Babel allowed developers to build these custom plugins for their needs. Next up is the 2012 to 2014 era, Browserify. So I would say that if you haven't really gone back to see how we were building code before the era of Webpack, Vite or Vite, on this really recent era, you would not know how much Browserify changed the game in terms of how good build tools could be. So Browserify brought the support for ES6 module syntax, so you could easily write ES6 module and it would find a way to transfer it to the point where the browser can read it. So it has support, so you don't need to write common JS, or you don't need to write basic vanilla JS. You could write ES6 syntax at that point. ES6 was still very new, and support has not been so much, unlike now. So it allowed you to write ES6 syntax, and it did the job in terms of transferring that code to something that the browser could understand. Now, another win for Browserify was that you could use Node.js syntax, right? Node.js developers loved Browserify because they did not need to learn anything special. They did not need to learn some other form of trying to configure their build tool. They could easily use the Node.js syntax they already knew to make their build process even faster. Now, another thing that came with Browserify was NPM power. So NPM was still had been recently, brought into the ecosystem, still very new. But Browserify were among the first build tool that basically added support for using NPM to create scripts, to create certain build scripts and execute them, install packages, install dependencies, etc. So it had faster support for NPM immediately it was launched. So Browserify really changed the game and was basically laid the foundation for how all of the current build tools were able to utilize NPM or Yarn or in some other form of package management, right? So let's see what happens in the coming years. What was that tool that changed the game? Now, the coming years is really interesting, because which is when 2015 to now was when Webpack became popular. Now, Webpack came and was mind-blowing, right? It came in with Tobias, which is the founder of Webpack, brought a very different tool, something that was faster than Browserify. I mean, at that time, Browserify was the most fast build tools that you could possibly find in the front-end ecosystem. But Webpack came with something entirely different, better, and faster. Webpack came with a Webpack server, which basically allowed you to do host module replacements. It brought the concept of code splitting, which every single framework and every single build tool we are currently using or doing currently. It also brought live reloading. I could change a particular code in my browser, in my terminal, and automatically Webpack could reload my page for me and show me that new feature. Before the time of Webpack, there was nothing like that. You had to click on refresh yourself to be able to actually see the changes you've made in terms of your code. But Webpack brought that live reloading feature, hot module replacement, when it was still very in alpha, and code splitting, where you could split your code in a way that it can improve performance and reduces the bundle size, right? It also had support for NPM scripts, of course, just like Browserify, it had support for NPM scripts, so you could easily write scripts that would run based on however you feel you want it to run, based on however build tasks you want to run. Then it also had support for plugins. Webpack currently has one of the largest user base of plugins, right? A lot of things you can be achieved with Webpack with just plugins, right? So plugins were available for every single thing you could probably want to do, right? You also had the power to have a preset, right? collection of plugins, right? Where you could okay, I need to create a preset for React. Okay, I want to run React code. I need all of these plugins available for my React code, and you could easily specify that, and voila, your code actually runs well. So Webpack brought that concept and changed the entire game, right? It had better developer experience than other build tools, right? But the problem is, as Webpack advances, just like the way it has happened across the years, people began to discover, how can we move on from Webpack? How can we make something even better? Webpack had its drawbacks, had its disadvantages. People had seen that, again, build tools can be faster than this. How fast can it possibly be? What can we do differently to improve the experience that Webpack already has, right? What's the different thing that we could possibly do? And that's what brings the future, right? What the future looks like. The future basically is trying to show, to me, the future is basically trying to show how fast can JavaScript code be built. That's the war that's happening in the future. How fast can JavaScript or React code be built, right? So we that in the future, which is where we are currently at. I like to call where we are currently at the future. Parcel, Vite, Rollup, SWC, ESBuild, and Notified Turbo Pack. There's a typo here. It should be a turbo pack, not turbo repo. And Vessel's turbo pack changing is basically the foundation for what the future looks like, right? Zero config build tools, extremely fast bundle time, hot module replacement even faster than what Webpack was able to achieve. Of course, out of the box live support for TypeScript, just making developer experience of what building the web could look like 10 times better. This is what the achievement of the future, what the future looks like, right? So this is basically, I've gone through with you the evolution of how front-end build tools have been existing or have grown across the years, right? If you can see, when the build tool era started in 2005, so you can see how far we've come in terms of building the web. You see how far we've come, how much work has been put in across the years to make sure that the next generation, the future, is as fast as possible. We need to run JavaScript code as fast as possible, which will improve developer productivity, improve our page load time, etc. So now let's look at one very particular build tool, which is Webpack, right? Webpack is, like I said, laid the foundation for the future, which is currently where we are at. Webpack was launched in 2014, 2015, and it is one of the most popular bundler around today. It's, if not the most popular, because it is still very, very much in use. Webpack is one of the most popular bundlers around today. A lot of people still use Webpack in production. Now, tons of production applications, frameworks such as Next.js and Create React App, and more, you use it for bundling and building, right? This Webpack come pre-built with React framework like Next.js. It also came pre-built with Create React App. So one thing I need to highlight is that, which is basically why we are talking about Webpack and its drawbacks, is Create React App was basically created to reduce the amount of stress that developers had to do in terms of configuring a development environment for React, right? Create React App changed the game in terms of, okay, I could just run npm, Create React App, the name of my app, and Webpack automatically bundles every single thing I need to do, and I actually have support for live reloading, etc., hot module replacements, every single thing Webpack could do, and more. And additionally, it had the largest library of plugins out of any bundler. This was like one of the major selling points of Webpack, was that there was a plugin that could do basically anything for you. Anything you could think of, is either you write it yourself or you search and pretty much someone has done it for you. Now, it also introduced concepts like, like I mentioned earlier, hot module replacements came from the Webpack era, live reloading, code splitting, presets, fun times, like really, really fun times. Now let's talk about, okay, what are the drawbacks of Webpack? Like, why are we moving on? Why are we trying to move on from Webpack at the moment? Now, despite being popular and widely used, right, it has some issues that make it less suitable for the modern developer experience. The feature I'm always talking about, right? The feature should not have a difficult configuration process, which is what Webpack is popular for. Every single developer at some point would have made a joke that, okay, Webpack is hard. Like, okay, let's just agree that configuring Webpack is really, really hard, right? Which is that is not what I foresee for the future of build tools, right? It has a really difficult configuration process. Webpack is you need to configure it to do even the most basic things that should be available out of the box, right? Which is what I believe the future needs to improve, right? The future needs to have zero configuration out of the box, right? Slow development speed. It has, Webpack has to bundle all modules when you start the development server at all times, right? Despite introducing caching in Webpack 5, which is one thing that the feature has, the feature of development build tools have is caching, it's even though it's introduced caching in Webpack 5, even though introduced caching in Webpack 5, you need to configure it. It still was not supported across all frameworks and plugins. Major issue. Now, larger bundle size than other modern bundlers. Like Webpack usually has, if you have a really, really big app, your Webpack bundle size is usually larger than modern, right? So because of the fact that it uses polyfills to load modules, Webpack bundle size can be larger than others. Now let's move on. Now let me show you a sample Webpack config file. Now, if this is a sample Webpack config, see how long you just need to do like the amount of processes you need to set in order to just do basic things like loading CSS, right? Setting preloaders for your code and setting the plugin preset. Just look at this is just to have a basic development environment that bundles your code, how it should bundle it, right? Webpack is really, really difficult in terms of bundling your code. Now, the next thing is, let's talk about the future, right? The new generation of build tools. Like, I'm currently running out of time and I need to, speed up, the whole process. Now, Parcel, you can check it out, parceljs.com is part of the next generation. I like to call this generation of build tools the future, right? Parcel is a lightning fast, zero configuration build tool that has great out-of-the-box development environment, which is one thing I'm really, really certain about, with a scalable architecture that can take your project from just getting started to a massive production application, right? One of the major selling points of Parcel is that you basically need zero configuration. Just install Parcel and you're good to go. You can try it out. You can check out parcel.js or org for documentation. Some of the features are zero configuration. You could just install, faster bundle time, multi-core processing, plugins are not necessarily needed, unlike Webpack. The reason why Webpack has a large ecosystem of plugins is that there's some things that was not being done by Webpack out of the box. Plugins are not necessarily needed in Parcel because a lot of things are being done out of the box. So you have to pick what works for you, right? I still believe that the future is more moving towards having lesser plugins, because it uses the amount of things, configuration you need to do to be able to do very simple things. The developer experience is awesome, right? It's really, really awesome. And another thing is the drawbacks. Some issues when trying to use ES7 construct. Like there's some issues at the moment when you're trying to use ES7 construct. I found that I think 2 people were complaining about something like this in the GitHub repo of the official code for Parcel. I saw like a bunch of issues like this. Then changing config to include extra Babel plugins apparently results in more complex config than Webpack. Since Parcel is built for everything to be done out of the box, there's a bit of bias in terms of trying to do extra configuration, and that could lead into a config process that is even much more difficult than Webpack, right? But ideally, Parcel has solved the majority of your problems that you would need as a developer by having all of these things out of the box. Now, first-time bundling can be slower than other tools. Like when you bundle for the first time, Parcel can be a bit slower. But if you try to rebuild your code after bundling for the first time, it is faster than Webpack. It is way faster than Webpack. Then another issue I've noticed is that the bundled folder is usually a mess. Since you could not define like a lot of things that like built like since Webpack parcel is zero config, bundle folder is usually a mess. Like everything is literally in the same place, no form of demarcation compared to Webpack, where you could specify where what should be, and you could see it properly and very, very well labeled, names of files, etc. Let's move on to the next build too. Vite. Now Vite, you can check it out at vitejs.vitejs.org. It is a build tool that provides a fast and lean development experience for modern web projects. It has two major parts: a dev server and a build command that bundles your code. That's pretty much it. It has a faster build than Webpack, TurboPack, should be a TurboPack, and Parcel. It is faster than Webpack, TurboPack, and Parcel, and this has been proven across various boards that Vite is faster. Now, it was created by Evan Yu, who is the creator of Vue.js. But the beautiful thing about Vite is that it is framework agnostic, right? You could use any React framework on Vite and it will actually work. You could use any JavaScript application on Vite to actually work. It also has support for SSR, which is currently experimental, but I see it improving in a couple of years. But it also has a great plugin system. Another beautiful thing about Vite is that you could use Rollup, which is also a JavaScript module bundler. You can use its plugins in Vite, so you can merge both Vite and Rollup together to actually have the ultimate developer experience, right? It also has a very awesome DX. Now, some of the issues, it doesn't have a lot of issues, but some of the issues are it lacks first class for Jest. If you are used to testing, you know that Jest is one of the most popular JavaScript testing frameworks, so it lacks first class support for that. And another issue is that different tools are used for bundling development and production code. For bundling development and production code, another issue is, so for example, ESBuild is used for development, which makes it extremely fast, while production code is built using Rollup, right? It's kind of tricky, and which I like to classify these as drawbacks, because these tools have certain specifications, and the production code, your code can be working on development. When you change it to production, it could fail because of some issue with the bundler that is being used in production. I see this as a drawback. Now, Rollup, which is what I mentioned previously. Rollup is a module bundler for JavaScript, which compiles small pieces of code into something larger and more complex, such as a library or an application. Rollup is perfect for building JavaScript libraries. So if you want to build JavaScript libraries, I would definitely say you consider Rollup. It is a lot easier to learn than Webpack. It has a faster build. It has a very fast build. It encourages code splitting, perfect for libraries, and less and easier config compared to Webpack. The drawback is that the biggest issue with Rollup is that it only provides one feature: creating production bundles. There's not really any developer experience apart from a couple of options like file watching and caching. It can produce development bundles and doesn't provide a web server, and only reads relative ES module by default. Now, this is also like some of the drawbacks of Rollup, and this is something you should consider if you're trying to use Rollup in whatever project or app you're trying to build. And that very, very recent ESBuild build tool is ESBuild. You can check it out at esbuild.github.io. It's an extremely fast JavaScript bundler. It has issues like extreme speed without needing to catch. You don't even need to implement caching in this because of how fast it is. It has support for ES6 and CommonJS module. It supports tree shaking of ES6 module and has an API for JavaScript and Go. So you could decide to run Go code with ESBuild, or you could decide to run it with JavaScript. So it has an API supporting both Go and JavaScript. Now, it is faster than benchmarking, as mentioned that. And also, if you go to their websites, ESBuild is faster than any other build tool, because the main aim of the project is to prove how fast JavaScript build tools can be. Right? It is perfect for any application. It is also written in Go, which makes it extremely fast. The drawbacks is if you are not used to zero config, if you are used to like zero config tools like Parcel, migrating to ES Build can be difficult for you because you need to do certain things yourself, right? It lacks support of roll-up, so you cannot use roll-up and ES Build together because it lacks support for it. So you have to probably write custom support for yourself. Then it lacks hot module replacement development server. It also lacks hot module replacement development. I feel like this particular build tool is still very much experimental. It's still being built a lot, and it would definitely in the next versions solve a lot of these problems. But the major thing is that this particular project or bundler proves that building JavaScript can be extremely fast, and this is what the future looks like. Other build tools that I would advise to look at for you guys, like, to look at in your free time, SWC by Next.js. I did not want this, this particular project, this particular presentation to be so long, which is why I did not cover it. But SWC by Next.js is another Rust-based JavaScript build tool. It is built in Rust and is being used by Next.js at a particular point. It's being used by Next.js and it's incredibly fast because it's Rust-based. You should also check TurboPack by Vessel, which was like released when Next.js 13 was introduced. It's extremely fast. It's said to be faster than Vite. It is said to be faster than Vite, which is like you can run benchmarking for yourself to compare in terms of like your own use case. And in conclusion, soon we'll be seeing more tools with no configuration at all, better customizability, even much more improved extensibility and faster speeds. I still believe that build tools can be faster than what we are currently experiencing, which is what the future looks like. Thank you so much for listening to my talk and for giving me the opportunity to share my knowledge with you all. You can find me on Twitter at @Skoda_Black, BLVCK rather. So that's what BLVCK, which is pronounced as Black. And thank you so much everybody for coming to my call, my talk. This is really, really a big deal for me, and I appreciate every single person.
Thank you so much for your presentation. We have questions for you. So the first one is, what about plugins like Module Federation in Webpack for other bundlers?
Yeah, so I'm not sure about the support of Module Federation because Webpack is actually the pioneer of Module Federation. So I'm not entirely sure about how Module Federation work in other bundlers, but I think that the new generation of bundlers that are coming out are going to have support for Module Federation. So I think Vite should have support for Module Federation. I think TurboPack by Vessel should also have support for Module Federation, but Module Federation would not be the developer experience you get in terms of Module Federation in Webpack would be much more better than probably anywhere you could possibly find because it pioneered the idea.
Thank you. And the next one is, what is your opinion on using Create React app for production codes? Are there big advantages or using other build tools?
So one thing I've noticed about Create React app is actually it's extremely slow, right? I've seen people call for the retirement of Create React app in the JavaScript ecosystem. So I can advise you that in terms of advantages, using Vite for your React code is like way faster than what Create React app will give you, or using Parcel or something, any of these new generation build tools, because Create React app at the moment uses Webpack, and Webpack has its drawbacks, but these drawbacks are being solved in the new generation of build tools. But one build tool that I would recommend for you in terms of advantage is Vite. Vite is like really, really fast, solves a lot of problems, and has like almost all the features that you possibly think of in terms of what a build tool should have.
Thank you. The next one is, do you have any comments on Bun and its developer experience?
Yeah, I've seen Bun a lot. I've seen Bun, and I've seen a lot of what Bun can possibly do, but I've not taken my time to go deep into it. But I know Bun is extremely fast, but I doubt it's as fast as ES Build. But I know that Bun is really, really fast based on the benchmarking I've seen being done online by the creator and some other people. So yeah, that's my opinion on it. Is like very, very, very limited because I've not really taken my time to look at it, which is probably something I would do maybe in an improved version of this particular talk, maybe in an improved version. But for now, I have like zero to no knowledge about what the possibilities that can be achieved with Bun.
Thank you. And the last one is, what would you recommend to use with React besides Webpack?
Yeah, try out Vite. Someone in the comment just mentioned they are using Vite to build their library and React app, and it is really, really fast and easy. So you should check it out. It really, really works, and it's something I would always recommend to React developers.
Thank you. And we have one more. So for Microfrontends implementation, while having multi-framework frontend, what future we expect for it and tool you want to mention?
Yeah, so I think having multi-framework, having a multi-framework front end in terms of like micro front ends, it would improve, right? A lot of build tools are being built to have support that to be framework agnostic. Again, Vite would solve. If you have a micro front end, you're doing micro front end, you have a multi-framework implementation. Vite is framework agnostic, and it would help. It would give you the same experience it would give someone that has just a React-based front end, right? So you should check out Vite, like I mentioned, and the future of Vite is that I see a lot of people moving into micro front ends because of the fact that it gives you flexibility to get the best of any front-end framework that you possibly think of. And it gives you the flexibility, gives you the developer experience. And in the future, I would see much more adaptation compared to now. And I myself too will also try to adapt it.
Thank you. Thank you very much for answering all the questions. And thank you really for your presentation. It was lovely having you on the stage. So now, okay, yeah, and now we will go to our next speaker. Our next speaker is Mateus. Welcome, Mateus.
Hello, Melissa. Hello, everyone.
How are you doing?
Yeah, I'm pretty good. Really glad to be here again.
Yeah, and we're super excited to have you on the stage. So I will ask you to share your screen.
Yeah.
And Mateus have for us a really interesting topic, and I know you're all excited to hear all about it. So let me just.
Yeah, can you see now my screen?
Yeah, sure. So Mateus, stage is yours. When you're ready, you can go.
Amazing. Thank you. So hello, everyone. Thank you for having me here again. It's my second time here. Exactly 1 year ago, I was giving a speak here about React with machine learning for real-time video. This time I will be talking about another exciting topic. It's not that usual to see React mixed with 3D and with augmented reality and virtual reality. All of that is very experimental. Currently, we have some solid and strong libraries and frameworks to work with, but they are still on development. So most of the things should be changing with the time going on. But we can already do some very fast stuff with React and all these exciting topics. So let's get going to that. So beforehand, I am Mateus Bueno. I am a software engineer, and I'm working at Barisdev. And Barisdev is an offshore company, so it essentially outsources developers to companies all around the world. I am currently working social media ads platform. We do automation for ads in all of the most famous social media, such as Facebook, Instagram, TikTok, also Pinterest. And we work very closely with also machine learning and data science to do the ads automation. I have some kind of experience with AI, 3D, VR, and AR for the web. I've worked as a researcher for about 1.5 years, and I did have the opportunity to do a lot of not so usual stuff with React and with web technologies. And currently I do some side projects and also some paid projects to any company or any customer that needs some of these things to their product or application. So I do like to mix React with this stuff, and it's very nice. It's kind of hard, and there's a lot of effort involved, but the payoff is really nice in the end. So I've been developing with React professionally for the past 4.5 years, almost 5 years. So I have some experience with that also. Of course, I do the usual React work, dealing with state management, and also with also Webpack, as we saw in the last talk. So I do work with, let's say, with the more boring stuff, if you may, but I do like to also get some spice stuff, going on with React.js. So for this talk, I will be first talking about the web UI and what is the state of the art in the 2D, and also what is the difference from 3D elements for web interface. And after that, I will be just going straight ahead with the examples of my talk. I will be talking about 5 examples of React applications with very nice stuff going around. The first example will be a 3D eShop. It's just a concept, it's not a complete 3D eShop. It's just a concept of e-commerce using 3D elements, just to give you some idea of how that should be working. My second example will be augmented reality business card. I will not go in too deep in the conceptualization between augmented reality and virtual reality. I think like right now, everyone should have some intuition, or at least some idea of what is it differentiate between augmented reality and virtual reality. But I will be talking about some of the most strong different parts between them. But yeah, I will also show you an example of another application with augmented reality, but that one will be for face. So it will be like a face filter that you can see on Instagram or TikTok or maybe Snapchat. But this one will be a glasses eShop where you can try them virtually, so you can see how the glass fits you in real time. And the fourth example will be a real estate tour, so a tour on a virtual house or virtual apartment, using virtual reality. And the last example will be a React Native application. All of the other 4 examples are made with React, so they are running in the web browser. And in the example 5 will be strictly application, so it will be mobile, running on Android, and will be an example of a furniture try-on with augmented reality, very similar to the IKEA app, if you know it. But essentially, I will be showing you how we can place some virtual elements in the camera, in real time. So, and for the last, I will be talking about the final considerations. So, what you should considering when you are trying to develop something with 3D or AR or VR, so you can have a very nice experience with it. And let's get going to the first topic. It's about the web user interface. So we are mostly used to work with interface with that kind of fashion. I got this screen from Dribble. It's a site where you can have some sites and application templates. But this one exemplifies what you would be seeing when you get into a site. This site over here is very fancy, if you will. There is a lot of transparency and very nice elements going on in the screen. But essentially, when we are working with the most usual web user interface, which should be in 2 dimensions, you will be dealing with text and images, essentially. So at the end of the day, all of these complexities that we have with React by passing some props and dealing with state, we are just essentially dealing with some strings, passing strings going from out of the flow of the application. And we also deal with some assets in the form of image to also express visually what we want in our website. And we can do some more fancy stuff with these elements by applying some kind of effects to them, like transparency and alpha channels. And we can play out with opacity also. We can apply shadows and do some overlay effects. We have the ability to do some animations also into the dimensions. And of course, you will be dealing with a lot of CSS for that, some JavaScript to do some more complex stuff. And you also will have to deal with some a very broad type of data. So for 2D, you will be essentially working with JPEG or PNG most of the time. The JPEG format is a very lightweight format for image. So it has a very nice compression without compromising quality. And you can't have some more advanced features like transparency or alpha channel, which should be the same thing. And PNG is also a very portable type of file to images, but you can have transparency to that, and also you have some features that can enhance image in PNG. So essentially, with PNG, you can have something like this checkerboard pattern that you can see here behind the dog. And this checkerboard is rendered as a transparent element, so you won't be seeing that. Just a fun fact, this image of the dog here is not actually a PNG, it's a JPEG, but it's just for illustration purpose. And another type of image that you can have is the SVG, which is the scalable vector graphics format. This format is very similar in function to PNG, but the difference is that it's in the vector format. So instead of the image being pixels that are being drawn and colored, in the screen, the SVG is actually built by a set of mathematical and geometrical functions like shapes and curves and lines and points, and this generates the image. It's a very lightweight format also, and it's very good to also transmit over the web. And if you open up an SVG on an editor program, you will see something like XML. It's in an XML format, and you can see all information about the transformations and the strokes and the lines that are being drawn to the SVG. So all of these formats are essentially what we'll be dealing when you are doing 2D visuals for your web application. Now for 3D, you have a new dimension, So now you are not just limited to the X and Y in your dimensions, You have also the depthness, so you have the Z or Z dimension also. So you can have rotation, and you can pan in and pan out over the elements. You can do a zoom in and zoom out, So even if you are still seeing your website through a 2D display, like a normal monitor display, you know, or maybe the phone screen, you have some deafness simulation, you know, to try to convey this feeling of things being very solid, you know, and have this deafness to them, like you would see in a video game, you know. So you can have that for the web also. The most common library to deal with 3D in the web is Three.js. So I'll be talking about that a little bit, but just on the surface. And Three.js actually does not helps you to create those 3D models, you know. You have to do that on a separate software, maybe a 3D editor or 3D render like Blender or Maya. And likewise, the 2D assets that you have some artist or designer that is responsible to create those images in Photoshop or something like that, or Adobe Illustrator. You still will need to have some 3D artists that will create those assets for you in Blender or Maya or something else. And Three.js or any other library that you will be using to render those images is just responsible to render the image. And you can also set up the camera, some stuff about illumination, you know, the lighting. But that's what you need. You still need some 3D asset, even that should be made by someone else or maybe by you, if you know how to do 3D models. And for that, you will be using these 3D assets that will be created in some kind of editor like the one that I'm showing up in the slides. So they are a little bit more complex because you need to deal with the mesh, with modeling, you need to deal with also texturing and with the materials. So you have to set up all of that, and that should be a little bit more heavy effort, you know, than comparing with 2D images. And also in 3D, we have a lot of different types of file. The first one that you will most see in the web is the GLTF format. It stands for Graphics Language Transmission Format. It's kept and developed by the Kronos Group. Kronos Group also develops the OpenGL, which is a very famous API for 3D graphics in desktop applications. And we have some versions for this type of format. The most used now is the 2.0, which you have some more extra features. There is also the GLB format, which is a binary format for GLTF, but they all work essentially almost the same, you know. And if you open up the GLTF in a text editor, you will see that it has a very similar structure to JSON. So it has some kind of hierarchy, you know. And this represents the scene and the nodes and the materials that you have in your asset. So you can have some customization by accessing these nodes also. So you can change materials and also change animations. You can also have animations embedded in this type of file. So if you compare with the 2D world, if you want to have animation running into an image file, you need to deal with GIF formats. But GLTF, you can have static and also animated assets. So it's very nice to use. It's very lightweight, so you can use that for the web very nicely, you know. But you can have the con that it would be not having so much details, you know. So the models that are exported to GLTF are not very like real, you know. You still have some kind of cartoonish look. Essentially, you can have GLTF assets that are very close to the physical based render stuff, you know, like you see in the most modern video game consoles, but it's not ideal to use this format to this kind of asset. And it's very widely used for Android augmented reality applications. It's the preferred format for them. You also have the USDZ type of file. It's more common on Apple, and this stands for Universal Scene Descriptors, but zipped. The Z is for zipped. And Pixar, it's the one that actually developed this format. It's an open format, and they developed that to essentially interoperate between many 3D editors and renders. So it's very useful for the people that do 3D modeling and 3D rendering. But it's also used for the Apple's AR ecosystem. So if you do something around the Apple AR kit, which is very nice to use and very strong and very solid, you will be using a lot of USDZ files also. They are heavier than GLTF, but they can have more complex stuff going on. So they look more real, you know, but they are heavier. So you have to consider that. There are a lot of other types of file. From this table here, the ones that you could be seeing going around should be the FBX format and also the OBJ format. The OBJ format is a very lightweight type of file also, but they do not embed the textures. So along with the OBJ, you should have also the files for the texture, which should be PNG or maybe a JPEG, you know. And the FBX are most common in the game development environment, but you should be seeing that also for 3D and AR and VR for the web. Okay, let's get to the showcase. These are all very simple and samples, you know, with 3D, AR, and VR libraries. Most of the samples you can get on the README of the libraries, or you can do with very small modifications. The ones that I will be showing here are very similar to the ones that are in the READMEs. So I just did some small modifications for illustration and education purpose. And they are all open source libraries, but some of these libraries have some portions that are copyrighted protected. So you have to consider that when using those libraries as well. And like I said, some of these examples are provided by the own libraries documentation with small modifications. And let's get going to our first one. Just let me set up here and I will share to you. So the first one should be a 3D eShop. It's just a concept of a very simple 3D product showcase, you know, where you can customize the product. This was made with React 3 Fiber. It's the most common library to deal with 3D and with React. So if you want to get do some notes on that, do note the name React 3 Fiber. So if you want to work with 3D, you can get that library. So let me just show you up here. I hope you are seeing my screen here. Okay, so as you can see, this is some kind of very usual web interface for any products that you should be seeing on the web, but this one has a difference here that you can just rotate the object because it's a 3D object. You can see all of the parts of this show here, this sneaker. And as I said to you, that we have access to some nodes in the GLTF format, and this sneaker here is in GLTF. We can have some customization going on here. If you can see here, when I click in a different part of the sneaker, you can see that a different part is being shown here. So if I want to change the color of the mesh, which is the principal part of the sneaker here, you can just select that and just do some customization in the color. I can change the stripes colors as well. I'm not that good with color combining, so this sneaker here will be a mess. I think you can change the band as well. So let's get some very ugly yellow here. And also you can change the lace. You can also have access to the cap. So you can see here that I have a very nice zone here, and just select the caps here. Let's get a nice blue here. And also I can do some customization to the inner of the sneaker, so maybe a black here to the sole. So I think you get the idea here. You can have access to a lot of nice things here. So yeah, that's an example of product customization. It's something that you don't have in 2D. You can have a very nice customization also in 2D assets, of course, but you have another dimension here. You can see it with more details also. So yeah, that's it for this example. And the part of the code, you will be using the React Free Fiber for that. So you need to install that. You can install that with npm. There are two types of installing. The preferred way is the bottom one with the @react free/fiber, and essentially you install that, import what you need. So you need a canvas, which is the part where you will be drawing your 3D elements, and you can also import a lot of other useful utilities, from this library called Dray, which is inside the React Free Fiber. So the controls, the shadows, the illumination you can get from this Dray library. And the important part here is the one that represents the GLTF. So you can extract the nodes in a React format here. So you can have access to each of one of these parts of the sneaker. So you can have access to the lace, to the mesh, to the caps, and then you can pass props to that and change what's going on with that props. So you will draw this show inside a canvas. So you can see here that the upmost element is a canvas, and it's parenting all of the ones that are inside here. So inside of the canvas, you have an ambient light because you need light to light the elements. I have also a spotlight to give some nice shadows to the show. I have the on show element here that is represented by all of that nodes that I show you before. And also you can have orbit controls, which controls the camera. So you can enable or disable the zoom, the pan, so you can have a lot of access to that. It's just very surface things here. There are some more inner stuff here, but this is what you will need to just do a setup of that object, And the next example is an AR business card. So this was made with Mind.AR.js. It's also an open source library. I'll be showing you up here. It's very simple also. So this one use your camera. So I think I'm having my camera here also. And what you need here is a image for reference. So I will be scanning an image here, and you will be seeing some elements being shown in the screen. So there is it. I can have like some kind of business card, with very nice elements jumping the screen. So I can have this movement. and it's still tracking. And you can have some controls here also, so you can pass here, like if you have in a normal web element, you know. And yeah, you can have a lot of nice things going on here. So for this example here, you'll be dealing with the camera also, and this library deals with all of that. So you need to install the MyGAR library, and also you have to install the A-frame and the A-frame extras. It's a utility library for that also, so you can have access to 3D stuff. And essentially, after importing it, you need to do some initialization. So I'm doing that in the use effect hook here. I need to have some reference to some elements in your web application. And essentially, you need to add an event listener, which is this render start here, and then you can start the system, and you are good to start doing stuff with AR. You just need to deal with this initialization here, but it's very straightforward. The part of rendering stuff, you need a scene element, and you can set up like that. You need a reference to the a scene, you know. You need to pass a props called myDAR image, which is the image to be tracked. So I saw you, I show you in the camera an image that was being tracked to overlay the 3D elements. And just some more small parameterization that you can toy with and see what are the best results that you can get. For displaying, let me just see here. To displaying the elements, you need first to have the reference to the camera. So it's just a camera element, and then you can do the display of your GLTF model inside the A entity HTML element. So you can have an animation mixer going on. So to animate your GLTF, first you have to have an animation embedded, and then you just need to pass this parameter here, animation mixer, and this will play your animation in a loop, you know. So it's a very nice way to deal with that also. And of course, you can do some rotation position setup for that, and also the scale. So you can toy with that to see what works best to your screen or to your application. And that's pretty much about it, you know. And you can also embed some behavior, so you can have some handle to button clicking, you know, to some actions. So you can have a lot of actions going on with that. So the next example is very similar to this one that I show you here right now, but now we'll be doing some facing tracking. Let me just load that up. Okay, here it is. So you can see here that I'm using some glasses by now. So this is kind of a glass shop where you can buy some glasses, but you can see if they fit well you. So you can, you know, go around over the examples here. You have some nice reflection going on also. And yeah, you can see that there is some reflection being simulated there. Yeah, that is pretty fancy also. So it's something that is very useful for an e-commerce like that, you know, so you can have your customers trying your products before they are buying, you know. And yeah, so that one was made with a library called Gillis VTO. Now this library is actually called WebAR Rocks, but you will still be seeing in the web a lot of reference to Gillis VTO. This library is open source, but it has some copyrighted formats. So you will be not using GLTFs directly. So you need to convert your 3D assets to a JSON format that is used by this library. So they have a website to convert them. So it's very straightforward to use also, but you need to have this in mind when using that. And with this library, you need to have a reference to the canvas as well. So it's very similar to what we are doing with the 3D React 3 Fiber and also with MindAR. All of them have a canvas where you are rendering stuff. And this one, you have some initialization going on in the use effect hook also. You need to call the VTO initializations and constructors to build your canvas. And you also have to do some cleanup. So in the return part of your use effect, you need to destroy the widget to not consume your resource, because this is very resource heavy on the browser, you know. And essentially, we can have a function to deal with the glasses setup. So we will be passing a JSON file to that. Like I said, it has support only for a JSON file. And you need to call the dealers VTO widget.load model standalone to load your glasses. And that's it. That's most of it. And they have a very nice documentation also, so you can read that and do a very nice setup for your project. So the next example is with VR, but I will not be showing the VR headset. So this website here is kind of a guide, you know, a tour into a classic house here. So this classic house was made with GLTF, and it's not a 360 image because I can go forward, you know, I can navigate here like if I was in this room. So it's a very heavy file that is running in the web browser, and the library is dealing with the performance stuff and to load this stuff here. So yeah, that's very nice also to have. You could have some callbacks to when you go to a door, you enter another place. You know, I did not set up this here just to simplify that. But yeah, and that was made with A-Frame. It's a very nice library for VR stuff. You just need to install A-Frame and import that on your application. And all of your stuff will be inside of a scene element. So it's not a canvas element, but an a scene. And yes, like that's pretty much about it. You inside your a scene, you need to set up your elements. So you have a GLTF model again, similar to all of the other ones that I showed you. You have the light as well, where you have to set up this, and you also have to toy around to get the best results. You can have a lot of types of lighting, also to enhance the quality of your render. And you also can have a sky color to have some environment lighting as well, so you can have the most of like rendering in like if it was real. So yeah, this one is very straightforward to use. I do not recommend using the React A-Frame library. I recommend using the straight A-Frame library, just A-Frame, and you will be just using the HTML elements of that, and you can do some more stuff with the hooks of React and stuff like that. So the last one is a mobile application with React Native using viral media. This one is very similar to the IKEA app. So I'll be showing you my mobile screen right now. Let me just drag it here. Wait, I need to minimize first. Yeah, that's it. I hope that you are all seeing my my mobile screen. So this one here, I need to scan my area here. Okay, so it's scanned very close to my door. And I can place here like a really nice chair, let's say. Let me just see here. Okay. Yeah, okay. So there it is, a very big chair actually. So you can have that in your, I don't know, your apartment, your room, you know, so you can see if it fits really well. Okay. And let's get back here. So, like I said, this one was made for React Native, and you need to install some utilities to do that. You can install the React Viral CLI to start a project in the format of the React Viral Media. And you just need to npm start that to start seeing stuff going on. The Viral Media library uses some elements very similar to all of the other libraries as well. You need to import the scene navigator, some materials. You can have animations. You can have also some other elements. For doing that thing that I showed to you, where you scan your area and position an object, you need to have a Viral AR plane selector. This is the selector that do that scanning, and it does a hit test to identifies and detects like a plane to know where is a floor, you know, or some table. And you need to have a viral node, and the viral node is an element which sets every element inside of it to be draggable, you know, so you can drag the elements to place in your house or your your home. And then you have the Viral 3D object, which is the object by itself. You need to pass the path to the file. So you need to pass the path to the OBJ file. In this example, I'm using OBJ files, but you could have also FBX and also GLTF, but the GLTF is not very well supported by this library. But yeah, that's very straightforward as well. And for the last year, some things to consider when you are doing this stuff. So most of these open source libraries are very unstable yet. You know, you can do very nice stuff with them, but you need to have some effort going on. You know, sometimes stuff just doesn't work really well, so you need to do some work on that. But the paid libraries are very stable. So you have paid libraries like AFWall or Zappar. They are very solid, you know, so you can use something like that. But if you don't want to pay, you need to have in mind that you need to do some work to set up all these open source libraries. But when you get the setup of them right, using them is very straightforward. You know, it's just the matter of fact of using the elements and displaying your stuff. You know, most of 3D stuff works really well on browser right now, so you have very nice performance going on with 3D for the web. You still need some work to display some more complex assets, but for most of the assets that you will be finding in the web to use on your website, they are very nicely has a very nice performance. You need to work very close to the artists as well to pass to them the limitations of the web platform. So they should be modeling some models that should be very lightweight, you know. So you have to do some you need to do some like small modifications sometimes to your model to then run in the web really well. And the debugging part is not as complete as debugging regular 2D interface, so you do not have a lot of stuff to inspect those elements, you know. And for AR and VR, you need to consider engine first mindset when I say that, for AR and VR, it's more usual to work with game engines for that, like Unity or Unreal Engine. So if you want to use AR, I recommend you to first try that engine, even if it's a little bit more complex. It's more easy to deal with that. But if you need to integrate AR and VR to an existing application that you have made with React or React Native, maybe you still should consider using the Unity integration. You can integrate Unity stuff with React Native stuff. You can use a library for that as well. It still needs some kind of setup, but I think it's easier than to use a straight library for that, like Viral Media. You know, I show you an example with Viral Media, but right now this library is not very well supported and maintained, so it has a lot of drawbacks going on with this library, and that's because Unity and Unreal are the ones to use for mobile augmented reality and virtual reality. There's a lot of ongoing development going on for doing some more high performance stuff with 3D. And so there's a lot of work going on with WebAssembly, Web GPU, and mobile device sensors. So the React part is actually very passive in this matter. So the most of the heavy work is going on with WebAssembly, Web GPU. So if you want to contribute with advancing this area, you should be like studying WebAssembly and Web GPU, so you can have more things going on that side. But we have very high expectations on AI for video and image. We are advancing very well on that matter, so we can integrate that with 3D also, so you can have more fancy stuff, going on, like doing some gestures, like I presented you last year, and doing some more face tracking, more precise. And yeah, it's something that is just going on, and we should see more stuff being made with that. So yeah, that's that for me. I don't know if you have some questions.
Yes, so first I want to thank you. Thank you for showing us these really great and cool examples, and thank you for your presentation. We have a few questions for you, so we can start. The first one is, what are your thoughts about spline tool design? Do you think it will replace Blender in future?
I'm not very familiar with spline design. I think it's a web editor. I don't know exactly, but I think Blender is having some space in the industry, because before it was very limited to the open source people, and Maya was more industry standard. But with Blender 2.8, I think we started to see Blender being more used in all of the industries. So there's a lot of big players using Blender. There is a lot of nice things going on in the Blender development. So I think Blender will still be used like very broadly for the next 10 years or so. And that's also because the artists, are the ones that use just those kind of softwares, are still very used to work with desktop-based software. So if you get a 2D artist, they are very used to work with Photoshop or Adobe Illustrator. Even though you have some web-based editors, they are still used to use desktop-based applications. So that's also happens with 3D artists as well. So I think Blender will still be going around for a very long time.
Thanks. And the next one is how to start the path for front-end development into the AR and VR apps.
Yeah, so I would recommend that you first study some concepts around 3D stuff, because it's different from 2D. You need to have some more stuff in consideration. You need to understand how 3D is oriented, how is rendering works on. You need to know how assets works also with texture, with lighting, with materials, what is a mesh, So we start with that. And then I would recommend really strongly to use some game engine for that, like Unity, because in Unity you have a very nice 3D editor where you can have more of a sensation, a feeling of how of that works in the real world, And then I recommend you to try some of these AR libraries like MindJR, which is a very simple library where you can have also, you can see the source code and it's very simple and you can understand that. But I still think that you should have some more strong and more nice results with a game engine, So this is something that is kind of far from what we are used to do in front-end development. You just open up your code editor like Visual Studio Code and start coding. And Unity, you have a lot of other things going on. You need to do some coding in C# as well. But I think it's more reliable to use that. You can delve into this AR and VR libraries for React and JavaScript, but they are like very experimental still. So you have to have the experimental mindset when you are using that. But yeah.
Yeah, understand. And do all browsers support AR API?
Yeah, so there is a standard to AR in the web, which is called WebXR. It's kept by the W3C consortium. But the WebXR is not very well supported in Apple browsers. So Safari and also Chrome for Apple is built with the Safari WebKit, so it's not well supported in this browser. We are hoping that this next year we have some support for that, as Apple is investing a lot on the AR side of things. But without WebXR, you can have WebAR running in this kind of browsers, but they will not have the same quality, along all of them. They will have different qualities going on. So yeah, you have to consider that. They are kind of supported, but this is not very well for all of them.
Yeah. And what is the major difficulty to start working with 3D?
Yeah, so you can't run away of some mathematical stuff, You need to have some surface understanding on matrices, and transformations. It's not that you need to be like a mathematician, or a very expert in geometry or something like that, but you have to have a sense of that. You need to at least understand when people talk about rotation and translation and also scaling in 3D. You need to have a sense of the Euler angles, which is all the movements that you can do in 3D. And also it's harder to have a final result in 3D than with 2D. With 2D, you can draw in any software something, and you have something going on, You can have a very nice collation of stuff to build some image. And with 3D, you need to have some modeling skills, have to do some more effort to that. But I must say that it really pays off if you start to delve into this stuff, because when you have something built in 3D, it's very nice, the end result, for you and for the people that you show up, all of them, just you have the wow factor on your side. So it really pays off in that.
Thank you. Thank you so much for being here. Thank you for sharing all your knowledge. And we're so happy to have you.
Okay.
So it's time to introduce our next speaker. Our next speaker is Akshat. He's founder and CTO at Company 360, and he's going to talk about building serverless apps with React and AWS Amplify. So welcome, Akshat.
Yeah. Hi, Milica. How are you? I think it's been a busy day.
Yeah, I'm doing great. How are you doing?
I'm doing good. It's pretty much end of the day here in India. So right time to give a talk. And I was also listening to the previous one last 15, 20 minutes and pretty interesting stuff. And I think it was a great lineup today.
Yeah. So I'm sure everyone is excited to hear your talk. So when you're ready, you can share your screen and stage is yours. You can start.
Absolutely. Just a second.
Yeah. As soon as you're sharing your screen, I just want to remind everyone to ask their questions in the Q&A section. And after the talk, I will read them to the action. So.
All right. Just 1 minute.
Sure.
Cool. Let me open my deck and start presenting. Please let me know if you can see my screen.
Yes, we can see it. So please just share your presentation. Yeah, that's right. Yeah. So the stage is yours.
Oh. All right, cool. Thanks, Milica. Hey, everyone. I think I'm on the wrong slide. Let me go on the first one. So the topic for this presentation is building serverless apps with React and AWS Amplify. And before I go into the details of this talk, let me quickly introduce myself. I am Akshat Paul. I'm founder and CTO of Company 360. And at Company 360, we are changing the way how legal and intellectual property business works in India and beyond, backed up with solid technology to give our clients, direct customers and enterprise client, access to cutting edge technology to help them with their intellectual property needs, whether it is patents, design patents, trademarks, copyrights, everything. And without these intellectual property instruments, nobody can work these days in any market. Beside working at my day job, I'm also author of few books. Some of them are as author, a few of them as technical reviewer in the technologies like React, Ruby, microservices, architecture, and a lot on React for last few years. You can find me on www.akshatpaul.com to see what I'm doing, or what's my next talk, or whatever I'm doing these days, something exciting I'm doing. And you can always buzz me on Twitter. My DMs are open. If you want to discuss any problem or you're stuck with something, you can always connect with you. And this is not the first time I'm giving a talk with Geekle. I think this is my third time in various conferences in last few years. Besides this, here are some of the other events like React Native Conference, EU, Dev Days, Amsterdam, React Conference India. From last few years, I think most of them are pre-COVID because live events have just started up. So let's come back to our talk now and discuss the agenda for this talk. It's very simple. We'll learn what is Amplify, how it works, what are the key features of this technology and tool chain, and of course a demo.
Just 1 second, it's Anna. Yeah. Can you please present mode, not with your presentation was down, so just present mode.
Oh, okay. All right. Is it?
It's much better. It's perfect. Thank you so much.
Okay. All right. Cool. Just 1 minute then. Just a second. Actually, it's moving on my second screen somehow, so I would have to just set it up again. Yeah. Millie, the problem is that it's somehow moving to my other screen. Is this does this work fine?
So we can't do like full screen now?
Okay. Is this better?
Much better. Let's try like this.
All right, cool. Okay. All right, cool. Just 1 minute. All right, cool. Yeah, so the agenda for this talk is very simple. As I mentioned, what is Amplify, how it works, key features, and demo. Of course, in demo, we'll have 4 parts to it: the front end side, the back end side, how we can connect the both, and then hosting the same. So let's get started. So what is Amplify? This no application, every application has few parts to it. There is always a front end, there's a back end, and then we host it. Essentially, any full stack application always runs around these 3 parts. Most of us, especially I believe in this on this conference, are front end developers, mobile developers, and something we always get stuck is the back end part. With AWS Amplify, we get feature set of tools which helps us build a backend in no time, essentially building a serverless application, but leveraging all the existing and most of the 100 plus services of AWS, hence helping us creating a full stack application in no time. If we go to the by the definition, Amplify is set of purpose built tools and feature that let front end web and mobile developers quickly and easily build full stack application using AWS and help it scale as the application and its use cases evolve. At present, it supports pretty much all popular front-end frameworks: React, Vue, React Native, Flutter, which of course includes iOS and Android as a platform. It comes up with various tools, Studio platform, CLI, in order to help us build the application very quickly with simple, quick click-through workflows. So how it works, as I mentioned, there are 3 parts to every application, and the architecture of Amplify is similar to that. Before going to the next part, if the closest competitor or the closest other option to Amplify, I would suggest is Firebase, which many of us might have used. With Firebase, we used Google's infrastructure, and with the Amplify, we use Amazon infrastructure. That is pretty much the difference. If you have used Firebase anytime, it's quite similar. Its workflow is quite similar to that. So the first part of Amplify in the Amplify Studio is the application backend. That is creating the whole application backend, structuring the model, creating the relationship between different models, which can then help us set up authorization and accesses for various parts of the backend model of our application very quickly through simple wizard kind of a structure, and quickly go live with it. So that is the part which manages all our app backend. We can also link to different AWS services if you want to connect to like simple email service or Pinpoint or S3. It all we have access to all these 175 plus AWS services which we can connect to and make use with our application. Hence, it's not just limited to building some static app and they're just hosting it on S3, but a full-fledged workable application in which the backend is basically not exactly drag and drop, but simply connecting to various services through simple commands. The second part is in the Amplify architecture is the front-end UI, where Amplify Studio provides us pre-built UI component which we can use. We'll be using them in the demo application we are going to build. There is also option to use Figma, which is essentially based on the principle of design to code, and we do get high quality React code which we can then of course use it in our application. bind it up, and of course use it. That is the second part of the Amplify architecture. The third part is the hosting, and this is the best part, and which is really powerful feature of Amplify, that you can go complete production grade or enterprise grade infrastructure in no minutes, as you will also see in our example. I'll give you an example here. Like whenever we create applications, especially if it is just kind of a simple tool which is going to be used by a handful of users, and it might explode some point in time, but we simply write some script and host it on some server or anywhere, even if it's a static website, but we don't create separate environments. We just want to go rush to the production we have. But with Amplify, we can create separate environments very, very quickly. Of course, I know that there are other methods to do it with commissioned instances, but with Amplify it makes things very easy, and we can also have our CI/CD setup that is plugging in with our GitHub repo or our any Git source code versioning manager, and simply plug into it, and every time we commit our code, our application gets deployed. That is also a piece of cake with Amplify with just few clicks. This makes our application infrastructure extremely robust and very easy to go live and make all kind of changes. We can, of course, it's not just limited to making staging environment and production environment. We can have different environments for our A/B testing, etc. of everything. So these are the three parts to Amplify architecture. Just to play back, there is the backend part, there is the front end part, and then there is hosting. So this is in a nutshell how Amplify works and with any React application. Now let's look into some of the key features, like what all you can do. Like with this quick introduction, you can now understand that we can easily host a application with a backend. You all can envision some to-do application with it. But of course, in real world applications, it's much more than just to-do or a blog application. We require some key features which are ingrained into the DNA of Amplify whenever it was designed. That is creating authentication. Authentication is kind of a go-to type of a feature for almost every application. With the Amplify, authentication is built in. On the left side, you can see there are options to plug social media authentication using Google or Amazon, and even now recently even Apple sign-in is also available. You can have multi-factor authentication. You can have your password policies set up for your application, like what kind of a password has to be there if your organization has certain policies. You can have complete workflow. On the right side, as you can see, you also get pre-built UI component, but they are not just limited to the look and feel, but you essentially get a complete workflow for your sign in and sign up, which means that the first you can set up properties that first time login, there should be a code which has to be entered, and then you need to change the password. All those things you can simply process it with the help of your backend. Next is authorization. Of course, authentication in most of the cases is not complete without proper authorization. We can easily create, read, write, update, delete authorization for specific users or group of users. We can create user personas and profiles based on which they can access various pages of the application, data of the application, routes of the application, in order to make authorization work for any application. And even in our demo, we'll see that we'll have certain users who will be permitted certain rights in the application, while some won't. Next is the data stores. Amplify Studio offers various backend interfaces in order to create your data models, and then save it in the database. You can also create multiple models easily in the studio, and you can also create relationships between them, and also see it graphically with the help of ER diagrams. What is the connection between them? All this data of database is not just available that you have to be online every time. You can always access it offline through your front end application in your local data store, and whenever you're back on network, it gets synced. That is especially during the development mode. Some other key features, these were the few key features which we'll also discuss during our demo, but some of the other key features which are very commonly used, and there are common services which you might have used in your other applications attached to these features. Like if you look at storage to store our photos, videos, or anything related to file system. It is provided, it is powered by S3, which is available at day one for all Amplify applications. Then you have push notification, which is available, which is using Amazon Pinpoint in order to provide push notifications for your mobile application. Then with functions, there is complete access of AWS Lambda, and of course for any serverless application, you won't be able to do much without creating few Lambda functions based on various events of your application. And then there is API support. The HTTP requests are provided with REST endpoints, GraphQL endpoints to help you manipulate your data, store it into DynamoDB, which comes by default, or even if you want to use other databases like Aurora. And also access to API gateway, AppSync. That is actually the first two services. Whenever you create an Amplify project, those are the first two services which you will be actually using. Then of course there is PubSub, which I have not used much, but in case you plan to build IoT applications, you can make use of it. Then there are command hooks. There are a lot of scripts. For any production grade application, you might require a lot of scripts that have to be run post common hooks which run like Amplify, push, etc. They are also permitted, and you can chain them together if you want to clean some data, purge some data, or maybe just push something extra, or do some sanity check in your application post every deployment. Then using Amazon location services, you can use geolocation properties for your application from day one. Then there is analytics with Amazon Kinesis, and with Amazon Pinpoint and Kinesis, you can make use of analytics for all your application. Then, of course, last part is AI/ML, because there are no presentations which can complete without AI and ML. Of course, I've not used it with Amplify or any React application, but you do have access to SageMaker, which is a very, very advanced service in AWS stack if you want to use AI and ML features for your application. Cool. So that's a lot of stuff and very quick rundown of Amplify as a platform. But I think nothing is clear without a demo. And our next step is the demo for this presentation. So I will quickly move to my Amplify Studio and give a quick demo. And just to give you a rundown of what will happen in this demo is that we'll create a simple application. We'll add models to it. We'll also add authentication, authorization to it. We'll create a simple Next.js application, which will of course consume this data, and then of course we'll connect both backend and frontend, and we'll also host it. So quite a lot of stuff, but you will see how quickly we can achieve this. So let me now take you to my Amazon Amplify Studio, and here it is. So I've already created few applications, but let me create a new one. and let me name it as demo 4 and confirm deployment. This might take a little bit of time. But essentially what is happening is that this is setting up all our environment. It is commissioning databases for us and various primary services which are required, which we can then use through the Amplify Studio. So let's just hold on for some time. Also, you must have your AWS account in order to set up this whole system. There is, of course, a sandbox provided to check out a few of the applications, but of course, you can use it on the free tier also for 1 year. Cool, done. So now we are done. So let's launch the studio. Cool. And so this is where you will be basically working all the time. And let's now create a data model. Okay. Let's add 2 models. So the app we are building here is a standard blog application. So let's name our first model as blog and add a field. The name of the blog. Let's now add post. Every post will have a title and then of course post content. Then add a relationship and select post model, because every blog can have multiple posts and content, and save it. And this is how easy it is to build a relationship between various entities. And then there are also these options for authorization. But before I deploy, maybe I'll add these because it will again take some time. The thing is that for authorization rules, we don't want for any blog application that everyone can, anyone who's authenticated can create, update, or delete someone else's blog, but they should be able to read it. So anyone authenticated with API can read it, but they cannot delete it or remove it or anything like that. So this is the CRUD authorization. You can provide it here. We can, okay. So I think we need to first save and deploy this. Yes, deploy it. Again, this will take some time. Meanwhile, let me quickly take you to the existing application which I was creating just some time back. And I can show you the authorization part here. So as you can see here, we have the 2 blogs, two models of ours, having two table model and blog and post. And there is actually another thing which you can do is that this is data which is a standard seed data which you can easily auto generate using using this option and have as many data you want. I've already done it. The same thing I have done with the post one, and also connected it. Like if I create I add some data here like post 3 and it has content. You can link it to some blog post. Let's do it 3 and then save it. So this way you have feeded your data. So essentially you can always create any data from your backend side, and that would be served to your front-end application later on. And then we have the authentication part here, which I had mentioned. For this application, it's already set up, but I can show you the options here, like various login mechanisms you can integrate. Of course, for this application, I have kept it as a simple strategy of login, but you always have options of Facebook, Google, Amazon, sign in with Apple option. There is also a verification method later on, which you can provide. All these emails are run through SES. Then, of course, password protection policy, which can be your policy of your organization if you need anything like that. And then, of course, you deploy it. And of course, the deployment cycle takes some time, but a basic authentication you can deploy from here. Now, let's go back and check the authorization part. So for every model we can set up authorization. Like we select blog model here, and as you had seen, I had removed anyone who's authenticated through API cannot create, update, or delete any blog post. They can just read it, but the admin can do everything. They can create, read, update. They have all the CRUD authorization for the application. And of course, same goes for the post part, because anybody with the authenticated API can read it but not create and update it. And anybody who is signed in can create and read but cannot update. Like example, if we take the comment part, we can create it, we can read it, but we cannot update or delete someone else's command. But of course, if whatever works in your case, you can always modify these authorization, and you can always enable owner's authorization. The owner of that specific record will have all the options. So this is the authorization part which I was mentioning. Yeah. Next, let's see if this is okay. It's still deploying. It does take a little bit of time, but to respect our time, let's now look at the front end application. So for front end application, so I have created this simple next JS application, which you can also do using. I'll just share the commands. So you can create some demo application with the npx create next step demo. This create a raw Next.js React application for you. Then you have to install AWS Amplify. The next command has to be installing this package, AWS Amplify. And then you need to include because we will be using some of the pre-built components, which really saves a lot of time. So we'll be using Amplify UI React. You can also include it. And lastly, you have to link your backend to your front end. And how you can do that is simply go to your respective project, and only after deployment you tend to see this local setup instruction. I still see it's getting deployed. So you have to simply copy this this command, and this will link your application. This will link to your backend application. So this is the one. Of course, this application will get destroyed after this after this presentation. And of course, your environment is, you can name it as staging or whatever. So this is how you can link your backend with your front end. Now let's look at the code we have here. So we first generated the boilerplate here. Let me close this. So this is the part which is generated by Next.js package, and when we included and we set up our Amplify, this is a lot more code which is included here, and that is what Amplify does. This helps us connect with our backend system and also help us with our also help us to work locally later on when we want to, in case we don't have in case we want to debug the application or we don't have access to the internet. So now let's look at another place, which is AWS export.js. Yes, so this is where all your properties of your application are relying, all the settings. Mostly we don't need to change them very often, but it is, in case you have to, this is where all the configuration lies. Now let's look into our application. Just 1 minute. Yes. So what we have included, as I mentioned, so this was your raw file, but we have included our Amplify UI React in order to use the styles from the application. We've also added a data store which we're supporting multi-authentication, because that is the type of authentication we have chosen. This is pretty standard. And then we have our component, my app component. That is where we are going to publish our data, which we are going to pull from our backend application. We also have this sign-in page where we are using Amplify UI React, and you will see that automatically that with Authenticator, we are able to load our authentication, our signing up workflow, and the sign up page essentially. Next, let's look at index.js, and this is where majorly all our code is residing. First, we want to render all our blocks on the homepage. We need a few imports for that. As you can see, there is with SSR context. The purpose of this is server-side rendering. This helps in server-side rendering. Essentially, that which helps us to get our data from the backend. This is the one piece of connection which connects with our backend system of Amplify. This will allow us to perform data fetching on our server side, and we don't need to rebuild the application again and again. So in case, as I had shown you, that we can add more posts on our backend system, whenever we do it, it will be immediately be seen on our application. Also, the front end will be more performant because we don't need to fetch the data again and again. Then we have added the block data and also added the try and catch block just for querying all the data. And we'll use the data store to interact with our data. Next, we have also using a serialized model here, which is the model function to convert the block data into true JSON, so we can pass it as the prop to the home component. We'll destructure the blocks from the props object, and eventually we will. This is the part where we will map it and show all the blog posts one after another. Let us now run this application to see if we can see the data from our backend. So I had already signed in. So, but when you signed out, this is the page you will get. As you can see, you get both the options of signing in if you're an existing user and if you want to create a new user. So like if I create a new user, and I create a password. All those by default features come in place. So now I will get a code on my other email. Let me quickly get it. So this was the workflow which I was talking about, which comes out of box for you. Let me find that pin. Yeah. Info. And now we are able to get into the application. We are able to see all the blog posts, and we can create our post if you want. If you make any change on the back end, we can also see it here on the front end. So that's about it. Now let's try to deploy this application on our on using GitHub. Okay, now this one is also done. This is great. Yeah. So we can simply use our GitHub. I've already pushed my code on GitHub, and I can connect the repo. GitHub authorization is done. If you're doing it for the first time, then of course you have to authorize your GitHub, and then you can choose your application. My application is RGS Amplify, and the branch you can keep whatever branch you want. You can click on next. All right. Now you can choose the environment. We can either create a new environment or we can choose it as staging, because that is what we had planned. We can select a role. In case you don't have a role, you can create it right from here. Click on next. Save and deploy. All right, cool. So now it's building, and we also have, if you see here, we have this enabled full stack CI/CD, which is already enabled for this application, which means every time our code is getting committed, it will get deployed automatically. So that's about it. Of course, this build does take a lot of time, but essentially it creates a sandbox for you, a staging environment for you to try out your application, what we were doing locally while we were debugging. Let me now go back to our presentation. Now that we are done with the hosting, that's a wrap. And I'm really looking forward for more questions. And in case you want to try Amplify, and if you have any questions, I'm always available. And these are my places to find me, whether it's Twitter or www.akshatpaul.com. If you have any questions, if you're getting stuck with Amplify, do let me know. There are a few gotchas here and there where you can get stuck while deploying the application, or while including any other service, or if you want to switch from the regular data stores which are provided upfront during the initial setup. So that's all.
Thank you, Akshat. Thank you so much for your presentation. It was really lovely. And we have a few questions for you. The first one is, for Auth, Amplify using AWS Cognito by default, does Amplify have similar vision as Amazon Lifestyle, with a different Amplify for mobile and Lifestyle for web?
So that's a good question. So yes, you're correct that by default it is Cognito, and what you can do is that you can either clone separate projects for your mobile and web, but that becomes slightly tough in order to identify what is from where the user is coming to make it omni-channel. What I would suggest is that I've not used Lightsail, but I have used Cognito for both web and mobile application, and it works pretty fine. So far, I've not used it, but I believe that since almost 170 services are permitted with Amplify, so Lightsail would be there for sure.
Thank you. And can we have a different environments like QA, staging?
Yes, absolutely. That's I think that's the benefit of using this such type of an environment and going enterprise grade from day one. That you can have multiple environments, and even for testing out certain things, as you mentioned, having a separate QA environment, you can definitely create it.
Thank you. And is it possible to change styles for login create account page?
Yes, absolutely. You can actually create your own login page if it's required, and you can always do those modification. You can even use Figma for this, which is designed to code. Especially, I think most 90% of the problems can be solved with these tools. It is only those edge cases where you have to really write down everything from scratch. But yes, this is very much possible.
Thanks. And is it safe to say that having Amplify together with recent integration of Figma, the deployment speed can be cut down to 50%?
So the deployment speed is pretty good if you look at any other platform which we use regularly. It's very slow, especially during the demos. But I've not seen this change that it cuts down to 50% or something like that. I find it's already pretty good, and I've not personally observed it. If Amazon claims it, then we can reduce it to plus 20-30% here and there. There might be slight improvement, but I've not tried it out.
Okay. And what are the other services we can use in AWS for serverless computing?
The most common which I have used are Lambda functions, because without them, it's pretty much impossible for running some specific features in a serverless environment, because we need to write our code somewhere. There will be some unique feature, on the back end also. And basically all these services which we are using are serverless, right? Like if we use Pinpoint and we connect it to our Amplify application backend, that is serverless. So it is basically orchestrating all these Amazon services together in creating the serverless architecture. And if you want to write some specific event-based code, that you can put it in Lambda and get stuff done.
Thank you. And how pricing works in Amplify? Is it self-managed for serverless allocation?
That's a good question. And the Amplify pricing is very it's quite less if you compare it to anything else. And if you even compare it, like when we opted for Amplify, we did our research of comparing it with Firebase. And even there, Amplify has a slight edge. And all these serverless options which we have, whether it is Lambda functions or whether it is Amplify, they are really cheap because they are kind of a per request basis, and there are a lot of requests which are free initially, and even after that it is really less. So you can try it out on the Amazon calculator, but it is very cheap than any managed service which we use, or any commissioned EC2 server we take. It is way cheaper. And I would suggest to try it out for any proof of concept type of application you want to try it out. Then you can take it for your all full-blown production application. If pricing is something which matters, and it matters a lot, especially in all these cloud providers, if you're directly using them, then Amplify and even Firebase on Google side, it really saves a lot.
And can you access features like Lambda through the Amplify interface?
Yes, you can.
Oh, okay. Thank you. That's all. Thank you for being on stage. Thank you for sharing your knowledge. I am now really excited to introduce our next speaker. Our next speaker is Deepa. Are you here with us?
Hello, good morning. I am just here. Okay.
Good morning. Where from you're joining us?
Good morning. I'm joining from California, San Jose. It's 7 o'clock in the morning. I just woke up, so I can go get started.
Sure.
Just
share your screen.
I'm going to be sharing my screen. Okay, cool.
And while you do that, I will just remind the viewers to ask the Q&A and Q&A sections, and I will read into Deepa after her talk. So, stage is yours.
Just give me 1 minute.
Okay.
Oh, I have to.
Okay, it looks like we have some technical issues. Just to see where Deepa. She might need to reconnect. And while we're waiting for her, you guys can write in the chat where from you're joining us. Okay, so here's hi. Okay.
Yeah, sorry about that. I just got the call, just got dropped. I'm going to be sharing my entire screen. I had a lot of tabs open, but now it's all closed.
You can see it. Yes, just share your presentation.
Yeah, just give me a minute. I'm trying to do that. Hang on.
Yep.
Cool. Okay. Well, there we go. Good morning, everybody. Today we'll be talking about how to animate your React application. And my name is Deepa. I am a developer at Adobe, and I'm also an organizer at the Google Developer Group San Jose. I'm an ambassador for Women Tech Makers and an evangelist for Women Who Code Frontend. Time to time, I do write blogs, and here's a Linktree QR code if you want to scan and connect with me. And every top right slide would have my Twitter handle. So for this talk, I would expect you to know these things before on hand. So you should know the basics of web development and React. How do you use React library? You should know how to you should have created an application before. You're comfortable with all these props, components, hooks, etc. So today the agenda would be, we'll talk about what is animation, why do we need it, right? And what are the technologies involved in animation? Basics of CSS, animations, and transitions. We'll talk about other libraries, and we'll, at the end, we'll demo with Framer Motion. Okay, so animations offers as a medium for storytelling and visual entertainment, which can bring pleasure and information to people of all ages everywhere in the world. Who said this? It was by none other than Walt Disney. So Disney said that animation is a way of storytelling to people, right? So that's what we are going to be doing in our websites too. So why do we animate websites, right? Websites attract, it attracts attention to your website when you animate them, and it acts as a guide, and it also keeps visitors engaged for a longer time. It connects with your viewers, and it also improves the overall experience of the user when they visit your website, right? Here are a couple of examples that I would like to show. For example, this is a website called Madbell. If you go here, you can see all these balls moving here. And then you have, when you hover over the email address, it's showing something. And if I go click on this, you see here, there's all these moving parts are moving, right? And if you go here, and if I try to move around my cursor, it's just, you can see all these small colored boxes pixelated too, right? This is one kind of an animation. And the second one is none other than our Apple page, right? If you go to any Apple products page, I love their animations. It's so beautiful. It's so clean. It just flows. And it keeps anybody engaged, right? So if you see here, it just wants you to basically attract people to come and visit their pages, right? If you see here, see, the iPad opens. So these are some of the examples of great animations. So there are some technologies to create animations. These are the ones. One, we know CSS, through which we can do transitions and animations, and we can also use JavaScript to animate certain complex actions, such as bouncing effect or stopping, playing, something around that. And SVGs are nothing but scalable vector graphics. These are, you can animate logos, icons, and diagrams, etc. You can, why people use SVGs because of its smaller file size. You can also use Canvas for great performance. And WebGL is mainly used for VR applications and 3D. So these are the technologies used for creating animations in a web page. So now let's look into the basics of CSS. So it is transitions, which are nothing but simple movement, and animations are used for complex moments. For example, here is an example of a div which contains a square with a width and height of 100 pixels, right? The background of this box is red. On hover, right, what happens? The box gets the box width gets extended to 300 pixels, and it does it over a period of 2 seconds. So this is the main. This is as of with CSS transitions. And CSS animations are very similar. Here, what we do is we are using something called as keyframes, right? So keyframes are nothing but what it holds the style, and that'll hold it for certain times. For example, here I have the same red box, and when I load this box in a browser, it'll go first off, and it'll change to red. And finally, it'll change to red back again. And the whole animation would take a duration of 4 seconds here, right? Now, moving on to what are the kinds of animation that you would see normally in any websites. I just gave you a few examples too, like loading, scrolling, and then hover over effects, image gallery, animated background. That's what we kind of saw in one of those examples too, right? And moving on to what are the popular animation libraries that are present, in the market. We have something called the Framer motion. The Superman with the cape, green cape, is green sock. As you can see, he is wearing only one green sock. And then this one is a React Spring. And we talked about CSS. And there's something called as React Transitions and React Motion. There are also other libraries. These are also popular, but we will just quickly skim through the first 3 on this slide. We're going to be talking about these, right? So there's something called this React Awesome Reveal, React Anime, React Move, and Remotion. So, okay, here is a trend of these libraries. As you can see very clearly, the blue line here is the recent one. I picked this up last night. So it's as of October 30th of 2022. And the past 1 year, the downloads the downloads for Framer Motion is over 1.7 million. And as whereas when you see where you can see that GSAP or the green sock animated platform, that's what it's called as. It's only 350 downloads, and you can see the rest of the numbers. So you can clearly see that Framer Motion is on the lead for the past 1 year. So moving on to React Spring, because this is something that I will be talking about. Hang on, if I can make this work. So the animation moves like, this is, if you can see the animations, just watch this for a second. Okay, now this library is Spring-based library. And from this picture here, you can see that React Spring bridges, it is a bridge between React Motion and React Animated. So these are other libraries. It takes the good parts of this and good parts of that, and then it's combined together as a new library. So we'll talk about all the comparisons of all three when we do it at the end, but understand that this is how React Spring works. And React Spring, you can also install TypeScript. It does not come with it, but you can install TypeScript along with it. It is basically, it's a hook-based API, hooks-based library. So you would use all these fancy hooks here. If you know how to use hooks in React, this shouldn't be a problem. So the uSpring would be the basic one. So how do you install this, right? You basically do the npm install React Spring, and the same Yarn version, you can do that as well. So here is an example of how React Spring is being used. First off, you would import using uSpring and Animated, right? And then you are using uSpring as an object to accept all these properties, right? And it has from and to, if you can see. So from indicates the values of properties from which animation starts. So it starts with the opacity of 0, which is you will not be able to see it, and opacity of 1 being visible. We'll just see that in a moment. So finally, you return the animated div. Right? So here is the whole thing. So here I'm using same uSpring. Here we have, if you see, uSpring has, it's an object. It has got all these key value pairs. And if you see the animation here, first it starts off with red, and then it goes opacity of 0. Then it becomes some other color. And try to understand this is how it works. Most of these libraries work in a similar way. It's just that the syntax is a little bit different, and some of them are capable of more, and some of them are, they need some love from you. So I have to open up VS Code. Just give me a minute because it got closed. Okay, here is an example of Spring. Cool. Okay, this running on. Sorry about that. Can you see my screen? Can somebody give me a thumbs up? Okay, here's an example of Spring animation. So as you can see, when I reload this thing, it is the bars are moving, and then here this is on a loop, which will disappear and appear on the screen for this text. So let's see the code pretty quickly here, if this allows me to move. Okay. Can somebody let me know if they are seeing the screen? I'm not too sure. Okay. Sorry about that. Cool. So here is my project structure. I have 2 of JavaScript files, which one is the progress bar that we saw. If you see, I've defined the bars as an array, and it has got objects inside it. And each of them have a key and value pair, and what is the color, what is this width, and etc. And here we are animating. If you see here, we are using uSpring here, and then we are using map function from JavaScript. We are configuring it, and then if you see it can, we are using the animated.div here, right? Understand that this is, if you know CSS, this should be very easy to catch up to. So this is all about, where is where's my thing? Okay, this is all about React Spring, right? So now moving on to Green Sock animation platform. If I can make this work. So Green Sock it's got over 50, like, if I can play this, it's got over 50 features. It's bundle size. The size of this package is very small, and it's got two concepts called as tweens and timelines. We'll be talking about it in a moment. And it's got also a lot of plugins to go with. And it supports inheritance, and it's got a bunch of utility methods, and it also uses it has also got something called as advanced takers. So one thing about Green Sock is very powerful. A lot of people use it. However, there's some of them are free, and some of the basic bundle is free. However, if you want to use plugins, there are some paid versions of it. So that's one of the things about Green Sock. So like I said, it's a suite of tools. It's used by over 11 million websites. So half of the, the award-winning websites come from GSock. And it's got core library and plugins. You can animate anything, be it SVGs, Canvas, HTML, anything that you can animate with Green's GSAP. Okay. So how do you set up? Again, you first install. If you just say npm install GSAP, it'll give you only the GSAP version. But if you want the free version of all the plugins, then you have to use this command or the similar version in Yarn too. So finally, you import a GSAP using the import statement. Here, I was telling you about two concepts in GSAP, which are very important. One is tween, which tween is nothing but, one tween is a single animation like this one. For example, I have GSAP to, here we are using two method where box is your target, and these are your variables, right? You use this for a single animation. You can use it, if you use it for multiple ones, it's called as tweens. So we'll see this demo here quickly. If I can share the screen here. So this is an example of, you see the circle, right? So if, I'm not too sure if people can see my screen, but I can share this for later so that you guys can take a look at it. So here we are creating a context, and we are using this plugin. Note that we are using this plugin from GSAP, and it says trial, right? There are paid versions. So understand that we are using this morphing SVG, and when I refresh this page, it's changing. It's basically using the morphing plugin to change it from a circle to all those shapes, and finally it comes back to circle. So this is how GSAP works. And we'll also talk about timelines. This is another core thing that you need to understand about GSAP. It can create adjustable and resilient sequence of animation. If you see the code snippet here we have on this line, we are creating a GSAP timeline. And here we are using the variable T1 in here instead of GSAP. So adding the tween to the timeline, we are now using T1.2 and not GSAP.2, right? If I try to play this thing here, see now you see everything goes one by one. So first the green went, then the purple, and then the orange one. So this is how you can create sequences of animation using GSAP. And framer motion. Moving on to the next library. This is the most popular one, right? Like I talked about. And this is a production, if I can play this. Oh, sorry about that. This is supposed to animate. Okay, there you go. Framer motion is a production-ready motion library for React. It utilizes the power of Framer prototyping tool and it is fully open source. It's free. That's one of the main things that there are a lot of people who use Framer Motion. With Framer Motion, you can use it for server-side rendering, and then you can use it for simple, complex, and for transitions and animations, and you can apply directly on the DOM elements. It has got great options for accessibility. So once you hand off prototyping from Framer, you can use them in Framer Motion. How do you set this up, right? As usual, we use npm install Framer -motion. That's something that I wanted to mention here. So here is an example of how we use Framer Motion. If you can see, you have the import statement, and then you also have something called as a motion tag. If you see anything with a tag that start with motion, then understand that it's using Framer Motion, right? And you have to, anything that you want to animate, you would start off with motion. Sorry about that. Let me turn off my notification. Okay, so you will also use animate property here. We'll see how we can animate. Inside this animate property, there's an attribute. You can use a lot of key value objects too inside this. I'll just show you in a moment. So what are the attributes that you can use? Like we saw animate. Animate, you can also have an initial value, like how we added to and from, right? In GSAP and in React Spring, you can use initial and transition here. And you can also use gestures such as while hovering, while tapping. And there is also something called as variance, which we'll not be talking too much today, but I'll show you a code snippet. There are also other attributes such as drag, scroll, etc. Right? And here is, if I can get my VS Code again back. Here is an example. We'll just show this in a bit. So it runs in here. So let's see this in action. First, I have put in all the here is an example of how we want to order a pizza, not a pizza, a pie. It looks like this. Let me turn this thing off. Sorry about that. So here is this one. So I don't know whether you saw it when we loaded this page, the header kind of swirled it around and it came back. So I'm just going to refresh this. See, it just got that animation. And if I hover over this, it's going to change the color of this header, H1 tag. And here the button, when I go back and hover, it's going to be, throbbing for a few times, and then the color changes. If I click on this, you can select what is the base of your pie. I'm just going to do Breezy. And I was not too sure if you saw the other one. Let's go back here. I want to make sure that the did this. And note that when I hover over this, the color changes. Not only the color changes, if I select this, the next button came zooming from the left, right? So on hovering, the color again changes. It again beats. So it basically bounces. That's the effect that I added. So if you see here, and again, I'm using apple. I like, let's do apple pie, right? So here I change the button color to yellow. So now we have this, it says that, hey, you have ordered this flaky pie with apple filling. So that's about it. So there are some code snippets here. This is the code. And these are all in my GitHub if you want to take a look at it. So here's the home page where we had that header kind of, swirled around. As you can see, we have the attributes initial, which is starting with 0, and then it animates, and then it is fully visible here, and then the transition takes. And note that whenever you're using duration, it is already here, the type is called tween. So don't get confused with all these terms, but there are beautiful documentation of all these libraries. You don't need to know every single thing, but if you're adding a duration, then understand that it's type tween, right? So here, when we, when we did the hover over on that button, say, welcome to the world of Pi, it changed this color when while on hover. And the one common mistake that I was doing whenever I tried to use motion was, you see this motion tag added before every element. Make sure you also add it in the closing tag. So that's something that I wanted to say. And if there's also something called this type of Spring, which is very similar to how we used it in React Spring library. So here, when we have, by default, Framer will use only Spring type. So when you don't have to mention it here, but if you are mentioning it about stiffness or damping, then it'll it'll automatically know that it's a Spring type. So let's see, we did this. So now we talked about all these beautiful libraries. I wanted to just give you a comparison as what are these. This is just scrapping these libraries, but just giving the basic overview of most of these. So what are the approach? Framer takes a declarative approach. React Spring, it uses both because it's a bridge between animated and React motion, right? So it uses both, whereas GSAP uses imperative programming. So what can be animated? Using Framer, you can animate, there's something called as, you can create motion, like I showed you the motion tag, right? You can use motion component, or there's something called as motion canvas, but that's only used for 3D animations. So it is capable of 3D animations too. If you go to Framer's homepage, you can see all those cool examples. And React Spring uses SVGs and HTML. And GSAP, like I said, it can animate anything, right? So what is the support for TypeScript? Framer supports TypeScript off the bat. When you install Framer, it already has the support, so you don't have to worry about installing it, like in React Spring. And in GSAP, you can use TypeScript definition, but it mainly uses only JavaScript, right? Yeah, and the animations, like I said, you can use simple and complex for Framer and GSAP, whereas you can use it for React. You can use it only for UI animations, because under the hood, if you see, it uses only a hooks API. It uses hooks under the hood. Also, GSAP, there's a paid version of it. To begin with, it's easy, but the plugins are, if you're a developer, you're an individual developer, it's $99. But if you are a person, if you're a developer who wants a lot of plugins, it's $199. And if you are with a team, I think it goes up to $1,000. So although it is an amazing framework for amazing animation library, it is not free. Whereas the same capabilities are there with the framework, right? But it's not as popular as it's being used by a lot of startups. So that said, to give you a summary of animations generate interest in viewers. It increases the time people spend on your websites, and it improves your conversion rate. So there are so many different ways to do this, and there's no one right way to do this as well. So if you are asking me, hey Deepa, then what should I do? It depends on what is the purpose, right? What your users, what do you want to guide your users, right? And how do you guide your users in the right direction? What are the messages that you want to tell your users? whether it would be a distraction or it's going to be benefiting usability. So how well you can do it, and making sure that animation takes time. How do you care about loading speeds as well? So to create stunning web animations, you can use CSS, you can use the web animation APIs already, and one of these libraries that I mentioned. However, based on the tools you choose, the process of creating an animation will be either easier or harder. So that's why it's very important. Picking the right tool is important, right? So what are the next steps? I just briefly gave you an overview of all these 3 libraries, but you can explore some of the GSAP plugins. They are beautiful. They are amazing. If you go to their websites, they have a lot of code sandbox samples that you can take a look at. And you can also check out Advanced React Spring. There is also documentation and other libraries, like I mentioned, some of them. And you can also try it with the React Native. And see, I think one of these libraries support both websites and native application. I think it's Framer does it too. You can also try out with other techniques, right? I just skimmed through how do you combine TweenMax and GSAP. So there are a lot of things in each of these frameworks, but there are beautiful documentation, the community support for you, and you can go from there and learn more. With that said, thank you so much. My name is Deepa again. Hope you can connect with me either on LinkedIn, Twitter, or on any, or you can also check out my event page in GDG San Jose. And these are my references. If you have any questions, I'll attend during the question time.
Thank you, Deepa, so much. We have a few questions, so let's just start with the first one. Do you know if some of these tools works in React Native?
Yes, that's what I was trying to tell you, that framework works, and you can use React Spring too, but I'm not too sure of GSAP.
Thank you. And we have the one that thank you for the good presentation, and they guess that animation could be considered accessibility, right? And how can you make sure that animation not to affect the user?
So, like I said, Framer has a lot of good options. That's why people choose it. It's open source and free, and there is support for accessibility. Yes, in this particular session, I did not bring up more on accessibility, but there are support for that. You can check out the Framer Motion webpage.
Thank you. And how do animation translate across screen resolution? Do you have to create a custom animation for various resolutions?
Oh, that's a good one. I don't have at the top of my head, but that's something that I would let you explore it on your own. I did not explore it.
Right. Thank you. And how will you use, for example, the motion, the div in addition to UI library, such as Chakra UI?
Okay. So I am not too sure about Chakra UI one. I will say that right away. But motion.div is a particular tag, and if you had seen at the top, if you import Framer motion, then you have to start using motion component tag everywhere in all the HTML tags that you want to animate.
And what about
Lottie is a new one?
Yeah.
I had to mention Lottie is a new one. A lot of Flutter uses it. A lot of yes, that's something. It's a new library. I did see this, but I was thinking that it's also for mobile as well. So I didn't want to go touch in that area.
Yeah, I use Lottie in React Native, and it's really a great library. Yeah. Is it possible to animate transition between pages using React Router?
React Router, I am not, but too sure of it. But I'm sure there should be options for this. I did do a lot of research on Framer Motion because that's the top one that's been used by a lot of people.
Thank you. And have you used any of these animation frameworks in any React Native application?
I am a web developer. Let's put it across this way. So I've not tried it out with native React native applications, but there are options like I showed in Framer Motion, and I think React Spring also uses it. You can check out.
Thank you. And the last one, why animate using React rather than having a low code with no code platform?
It depends on what you want to animate, right? How much of what effects you want your users to have. You don't want to have like I showed you all these beautiful. I showed you only two of the examples, but look at those animation. I would say that if you go to Apple's page, you tend to buy it, right? Because it's so engaging. It's like it wows you. So it depends on how you want to animate, what do you want to animate, what do you want to communicate with your users. That's the whole key here. You can use low code solutions or no code too. It depends on what you want to have. Like I said, there's no one right way to do this.
Yeah, thank you Deepa so much for joining us and sharing your knowledge. And also this will be my last of my moderation block, and it's coming to the end now. It's time to say goodbye and in order to pass to the next moderator. And I want to thank all the speakers who had pleasure and company to meet today, and also you for joining us. And also I want to say big thanks to Geekle team, and thank you all and see you.
Bye. Thank you.
We will have like kind of 2-3 minutes break just for you to breathe in, breathe out, and we will continue with next speeches. Thank you.
Hi, everybody. Welcome back from the break. Hope everyone's slightly refreshed. I know it's a short break. But for this, for the next speaker, I'd like to introduce Colby Fayock. Just need to add to the stream. One moment. All right.
Images, videos, and media are part of our everyday web experience. How can we take advantage of it from an e-commerce perspective and make sure we're delivering the best experience we can? So who am I? I'm Colby Fayock. I'm the one hugging BB-8 and Kylo Ren over there. I work with the dev community as a developer experience engineer for Cloudinary. You can find me pretty much anywhere on the web by just Googling my name, as I'm the only one in the world. So we're going to start off at the top with the king of e-commerce, Amazon. The first thing we see when we load this page is that it's covered in media. It's a good way to showcase the available products, so it makes a lot of sense. This is the landing page for their fashion store, which looks very similar to probably a lot of the top level landing pages that you might have seen, but we have large images that are intended to showcase a bunch of the available products. As we scroll down, we also have the ability to shop specific categories with images that represent each and every one of those categories. Once we dive in, we start to see a grid of images. Like here on our product listing page, the easiest way to browse a large amount of products is by putting them in a list, so they put them in a grid that we can scroll through. Once we get on our product details page, we want to get a closer look and be able to choose our options. Ideally, this also means being able to have a few options for how we can see it at different angles. Now, not to pick on Amazon here, but there's nothing really innovative going on, and I'm sure they A/B test every minute detail to make sure that they're not hurting conversion, which we'll get to later, but it's all very practical and functional. How can we use media to actually level up our e-commerce experiences? Here we have Star Cadet, where I'm a big fan of their Final Space merch, #FinalSpace. They take advantage of GIFs to display a video like category and product images. It's a little bit more of a creative approach, but they're taking a very static medium, a typically static medium, and making it very exciting. Glasses USA allows potential customers to get a first-hand look at their glasses, like what it would look like on somebody's face. Buying glasses is hard, and you want a pair that you're going to feel confident in. Traditionally, you'd have to hope for the best and see how they fit and they have a good return policy. But this gets us a step closer to feeling like we're actually in the store. Or better yet, iBuy Direct actually gives you a real-time feed with the virtual glasses on your face, moving around with you just like you're actually looking at yourself inside of a mirror inside of a store. As far as the product page goes, you still need to be able to have the ability to showcase your product. People need to buy something and it needs to be very clear. So you don't want to be over creative, but like Nike here, we can use embedded video as part of that experience so people can have a better idea of what the fit looks like. Now, as creative as some of that is, it's still fitting into that traditional medium. The web is changing, so what does the future of e-commerce look like? Nike recently acquired Artifact Studios, a team who creates shoes and collectibles ready for the metaverse. It's similar to the collectible game that Nike has always been a part of, but now as an investment to the digital world. And that wasn't Nike's only foray into that world. Nike also launched Nike Land, which is on Roblox. It's an experience that gives you the ability to connect to a digital version of Nike HQ, where they have games and sports and other community-oriented features. But they also have a showroom that lets you check out special Nike products, giving you the ability to deck out your Roblox avatar with exclusive gear. And while we still have a lot of time before this kind of thing becomes super mainstream, we're already starting to see a lot of creative solutions. There's a lot of change happening, and it's happening fast. But let's talk about some of the more practical ways where we can look at our media today. While the metaverse is likely coming at us fast, we still need to maintain an effective Web 2.0. While for some of you, this might seem like an easy one, it's super important to make sure you're providing and displaying large, clear images and videos to showcase your products. It's especially helpful when you make sure that you have more than one just single wide shot of your product. People care deeply about the products that they're buying, so being able to have a clear up-close look helps them to get a better idea of the quality they're getting. And we can't have e-commerce reference shots without Apple. Apple does a really great job at showcasing large detailed imagery, but that's not always clear enough to make sure that you know what all those features are. They make the extra point to highlight those features, diagramming the different points for the products, such as their potentially confusing use of 3 separate lenses on an iPhone, where they point out the differences for all those 3. And while it's important to have those big clear images, which Wise does really well, lifestyle photos are a way to place your product in people's everyday lives. Whether the potential customer knows it or not, this helps them how they can imagine how that product would actually fit into their real life. How could these Wise headphones help you out? While you're enjoying some music in bed? They're so comfortable you might forget that you're wearing them. ThinkGeek, a company that I used to work for who used to sell really cool things from all your favorite fandoms, took this a step further. Not only did they show the products in real life scenarios, they showed it with a fun twist. So you can fully imagine yourself as Darth Vader baking with your R2-D2 measuring cups. But it makes a extra difference going this extra step, helping to make a stronger connection to your audience. Upgrading media from static video images, we have video, which can help drive more context in visuals in a shorter period of time, along with audio to help with those more verbal descriptions. But we can do better than a video embedded inside of a pop-up. Like my examples earlier, we can use video in ways that will add to the experience without actually taking away from the existing one. Under Armour instantly sets the tone with video on their homepage. Their audience is full of athletes, so this is a great way to take somebody right into the gym and get them hyped up. And we can even make our video shoppable. As the video plays like anything else, we can make it interactive, allowing visitors to actually check out what that product is, without having to scavenge through the site, only, as you know, to find it on the very last page. So enough that looking at a bunch of pictures. See what I did there? How can we actually make some of this happen from a developer perspective? In reality, some of these answers might not include technical solutions. Like in order to showcase large clear images, the first thing you need is large clear images. But make sure that you're actually showing those images large and clear on the page. And make sure you're not over-compressing or only showing tiny thumbnails. People need to be able to have a clear look at what that product is. So take advantage of those big, beautiful images. But you can even take this a step further, where you can allow people to zoom in on those images right as they're on the page, avoiding unnecessary steps to take them off that page. There's a lot of great zoom-based libraries out there that can help out with this. React Inner Image Zoom gives us a similar experience to what you see on Uniqlo, where there's a lot of other traditional modal-like libraries out there, but some of them don't really give the experience that you would expect from Zoom libraries on an e-commerce store. But you could also try to replicate this kind of thing on your own. For example, once your zoom is enabled, we can dynamically grab that cursor position and update the image's position relative to its container. While this is just a really simple example, it shows the basics of how we can start to achieve that UX on our own. Providing point-based details is both a little easier and a little trickier. Adding some text overlaid onto an image isn't too bad. But each one of those lines are pointing precisely to the lens. While we can do that pretty easily for one viewport size, realistically, most of us are trying to build responsive experiences. Again, this is simple and an incomplete representation, but we can start to see that by using the resize listener and setting coordinates based on the original width and height, where here they're percentage based, we can dynamically update that position as it resizes. Lifestyle imageries is another one of those things where unless you're also the photographer, we're going to need creative support in imagery. But we can still see how we can provide nice banners like this without having to embed the text directly on the image. By including, we're helping both search engines read the text and accessibility, but we're also probably making it easier to make responsive so that the text is readable everywhere. As far as video is concerned, yeah, I would imagine you're probably thinking, I can just go ahead and slap a GIF in there. And yeah, you could, but GIFs can be huge, absolutely huge, especially if you want them to be big and high quality. We can instead take advantage of actual video elements on the page depending on the use case, may provide a lot better file size results. Using the HTML video element, we can hide all the controls and the player UI and set it to automatically play in loop. Just make sure that you test it in your app with your own images or videos just to make sure that the solution works with the best results for you. Now, when it comes to leveling up our video and making it shoppable, this starts to get a little bit more complex. You're likely using a custom player for this kind of thing. But again, we can start to think about how we could solve this kind of thing, where maybe we do have a custom video player, where we can define our products and define what we want our clickable nodes to be. Those nodes link to that product that open up in a new UI. So ultimately, it's creating a more interactive experience for your potential customers. Now, we have a lot of awesome tools at our disposal, but it's not as easy as dumping a bunch of images and video on a page. There's a lot of serious considerations that we need to consider about how we're actually going to deploy those experiences. Without considering the impact, we could be putting a lot of unnecessary load on our people's devices and bandwidth, severely slowing down their page loads and hurting experience, or worse, killing conversion rates. If you're not familiar, conversion rate is the percentage of your traffic that's actually going to buy something. There's a ton of studies about how website speed directly correlate to conversion rate. eBay, for instance, found that a 0.5% increase in their conversion rate with a 100 millisecond load time improvement. Now, that might not sound like a lot, but eBay is worth over $10 billion. So just as a real simple example here, 0.5% of 1 billion is 5 million. So that adds up pretty quickly. That means that while all of our images and videos might help build a good user experience, that media is going to take up a vast majority of that page size. So if we don't pay attention to how we're delivering it, we're going to bloat our pages and destroy that conversion rate. So what can we do to actually help optimize that delivery? So let's look at some examples of images, where to start off, while JPEG is probably a really great option, there's also some more modern formats that can help us deliver high quality images at reduced sizes. WebP and AVIF are two of those great options, and depending on the image, can bring some drastic reductions in size. We can also compress our images to the point where we're not impacting the visual quality. Maybe it won't matter for these tiny little thumbnails you see on the slide, but we learned that we want to display all of our images big and beautiful, right? So we want them to make sure that we're letting tech automatically decide how much to optimize where it can without making an actual visual difference in the image quality. We're not over optimizing, but we're also not wasting precious KBs, kilobytes in size. Now, if you're working with high quality imagery, your source files might be huge. If you serve them as is, the browser has to resize them down anyways. So you're just wasting bandwidth. Resize them down to the sizes you need. And don't try to crunch the images just to get a smaller file size. You'll end up with super blurry or pixelated images. Modern image delivery can give you the exact sizes you need on the fly, so take advantage of it. Now, bringing this all together, we have some pretty amazing results. Using modern formats and letting tech automatically optimize our images and serving up those images in the sizes that make sense for our web app, we were able to slash this particular example down from 4.3 megabytes to 51.2, all without sacrificing quality. Now, all those are great options, but how can we actually make sure that we're doing everything we can? Luckily, there's a lot of tools out there that can help us out, from inspecting our sites to helping actually build our sites. You may have already heard of web.dev, but it's a site from Google with a ton of educational resources for web developers. On top of that, they have tools to help you measure your website, including things like SEO, accessibility, and what we're talking about today, performance. While this is just a sample of their results, we can see that they inspect the media on the page and see if it's conforming to the best practices. Like, if we're not, they're going to let us know what's wrong. Like here, we're not taking advantage of modern formats, and we're serving our images way too big. A similar tool that's meant specifically for media is Cloudinary's website image analysis tool. Like web.dev's measure tool, it's going to review your site and check out how you're actually serving your media. It will show you exactly what media is costing you precious resources and what opportunities that you have to fix it. Like here, we can see the benefits that we get from serving our images in modern formats like we saw in my example earlier. For actually trying to implement some of these tips, we have Responsive Breakpoint Generator. This was a project that was created by media experts, sponsored by Cloudinary. Not only does it give you the ability to generate code snippets that you can use in practice, but it also serves as an educational resource for how these responsive images are actually working. So enough at looking at a bunch of pictures. Wait, I already made that joke, didn't I? So let's dive into some real code and see how some of this actually works. So we're going to check out some of the real world benefits of image optimization. It's pretty common for user content or media managed by non-technical people to be uploaded at full size without knowing the impact on that. So we can safeguard this by automatically optimizing all of our media. So we're going to check out how we can do that with the Cloudinary Netlify plugin. All right, let's dig in. All right, so getting started, I have this repository called Astro Image Gallery, where all it is literally a repository that shows a bunch of images in a gallery. And that's going to serve as our example, where I pulled all these images from Unsplash and I dumped them in the page, but it's going to serve as our example of how this is going to work. Now, if I head over to this other tab, I cloned that project so that I wasn't messing with the original one. But for this demo, what we're going to see is how we're going to take this. I'm going to deploy it to Netlify and see how we can actually use the Cloudinary integration. So I'm going to head over to Netlify. I'm going to click on add a new site where I'm going to authenticate with GitHub, which is where I'm hosting my project. And then under search repos, I'm going to search for that React global repository. And once the search comes up, I can select that. And we can see that because Netlify is able to detect that it's an Astro project, it already knows how to fill out what the deploy settings are. So literally all I have to do is scroll down here and click deploy site. Now in the background, Netlify is going to build my project. It's going to clone it down from GitHub, build it, and then it's going to deploy the results out onto the Netlify's hosting, and it's going to make it available globally for me, all the way from Elegant Croissant. I love their random names that they create. But we can even take a look at the console log if we look inside of here, where we can see exactly what Netlify is doing. It looks like it's actually almost done already, where it's going to have build the site. We'll see site is live. So I'm going to head up to the top and come over here, and I'm going to open up this page in a new browser where we can see Elegant Croissant, and it's that same list of images that we saw before, where what I want to do now is I want to open up my network tab where I'm going to refresh the page on the image filter where we can see how these images are currently being served, where I have all of them. We can see that they're all JPEGs. We're seeing that they're being served from that Netlify domain, and we can see the size. Now, you don't have to go down and write down every size. We're going to be able to see them back and forth. I'm going to leave this tab open, but kind of take note as to what we're doing. We're currently, it's 4.5 megabytes. That's a lot of megabytes that we're serving just for those images. So how can we take that to another level and actually optimize them for our delivery, even if we don't know where those images are coming from, if it is a content manager or somebody that might not know that optimization flow? So I'm going to head over to my Netlify tab. I'm going to go to site settings, and then I'm going to scroll down into plugins, and we can see that we can go and discover integrations on Netlify's library. Now they have a ton of different options available, but of course we're walking through Cloudinary, so I'm going to go ahead and select that. And we can see that we have the Cloudinary plugin, which is what we're going to use. So I'm going to click add build plugin. And we can see that we're taken back into this install step where we can search for that site. Now I want to install it on Elegant Croissant. So I'm going to go ahead and select that and click install. And once it's done, we now have that plugin installed on our site. So I'm going to head back up to the top, and we have actually two more things that we need to do. The first thing, we need to add our cloud name so that the site actually knows where to point our images to. So I'm going to first head over to site settings, and I'm going to go down to my build and deploy, where I'm going to click on environment, and I'm going to click edit variables, where I'm going to add my Cloudinary cloud name, and then I'm going to add my cloud name inside of here, which is going to be something that you can find right inside of your Cloudinary account, right on the dashboard. So once you have that in there, you can click save. We're at this point, I'm going to scroll back up. No, I do not want to save that. And I'm going to scroll back up, and I want to go back to my top level, where now all I need to do is redeploy the site. Because we're using a build plugin, it hooks into that build process. So we got to make sure that it has another chance to build and run those different things. So I'm going to go ahead and trigger that deploy, where it's going to go through that same process as it did before, where it's going to build that Astro site and it's going to deploy it. But we're adding some additional steps here now, where we're going to interface with Cloudinary, where we're going to upload it to Cloudinary, where in this instance, we're going to use the fetch API. So that happens on the fly. But once they're being served and delivered from Cloudinary, we're going to get those extra benefits that we talked about. So as we can see that this is going through, going through the Netlify build process. And if you remember before, it'd probably be almost done by now, but we can see that we now have these plugins for the Netlify plugin Cloudinary. And we're going to be able to see in a second here, which we just did, that that's still happening pretty fast, but it went through and it made those changes. Particularly, it's going to now serve all those on-page images from Cloudinary. So if I head back over to the top of my deploy, I'm going to open that up in a new tab again, and we can see that nothing looks different. Like we're seeing all those images just like we did before, but I'm going to open that network tab and I'm going to refresh, and we can see there's a big difference here. Did you write down all these sizes? Just kidding. We can see that they're now all being served from Cloudinary, but they're a different type. They're AVIF. They're not JPEG, and they're a different size. If you remember, the size that we're actually sending them is 1.5 megabytes as opposed to 4.5. And let's flip back between the different tabs here now. If I get rid of that dock bar, keep triggering it. So if I keep going back and forth, we can see that we have the AVIF versus the JPEG, but keep an eye on this size here. So the beach, for example, 566 kilobytes, and we go over to the AVIF serve, 125 kilobytes. That's a drastic reduction in size, and all we did was install that plugin. All we're doing is that automatic optimization. So imagine if we were serving these responsively and serving them lazily loaded, how much extra benefit we're going to get. But we did that all with this one step where we're now serving them completely with modern formats, optimized so that they're not visually different, and we're already making huge benefits and impact on our sites. All right, so just to quickly recap, we saw how we were able to easily optimize all of our on-page images. We also saw how much that actually impacts the page load and where we can help deliver better experiences to our visitors. If we pay more attention to our media, not only are we going to be able to more responsibly build great experiences for the web, we're going to be able to help ourselves by providing the best opportunity for conversion. Speaking of e-commerce, if you want to learn how to build your own online store, you can check out my course, Ecom Product Management and Storefront on Egghead, where we walk through building a new shop with Next.js and Snipcart, along with optimizing your media with Cloudinary. So check it out. It'll be in my talk notes, and you can find it on egghead.io. And that's it. If you want to learn more about the talk or anything, you can find me everywhere at Colby Fayock. I'll also tweet out a link with some of the stuff you've seen here today. Thanks, everybody.
All right. So Colby is not available today for Q&A, but you can obviously reach out to him through social media, as he said, and you can find those as well on the actual conference website, made available there too. So for the next speaker, I'd like to welcome Nivetha to the stage here. Hi, Nivetha.
Hello. Hi.
All right.
Devin. How are you doing?
Good, good. How are you?
I'm good too.
Excellent. Nice to meet you, and looking forward. We're going to learn all about React hooks, so I will hand it over to Nivetha. And all right.
Yeah. So cool. Yeah. Thank you for first of all having me here, and I'm really happy to be part of this amazing conference. I've been following Geekle community for quite a few years, and finally being able to present at the same conference feels great. Thank you, Anna and team, for giving me this opportunity once again. And before starting off with my talk, I would like to tell a little bit about myself. I recently moved to Berlin from India, and I currently work as a software engineer here in a company called Delivery Hero, focusing on front-end technologies like React. And apart from my regular job, I'm also one of the ambassadors for Women Tech Makers Berlin Tech community. So that's a bit about myself. And today we are going to learn about one of the interesting and most famous topics in React library right when it was introduced, which is React hooks. So today's agenda is like basically we're going to see why the React hooks was introduced in first place, and what are the difference between the Redux and React hooks, and what are the different types available, and what are some of the additional hooks that are present in the React library. So whenever we learn a particular new thing or a new tool, right, it's always advisable to understand why it was introduced in the first place. For example, even with the case of hooks, like whenever a particular feature is being introduced, it's always good to know what kind of problem it solves. So before learning about what is React hooks itself, we'll see a little bit of history why this was introduced in the first place. So in order to know why React hooks, so let's get back in time to get into some much deeper level. So all of us know that the React was introduced on May 2013, and it became super famous among web developers due to various factors. And at the time, there was no ES6 JavaScript classes that was released. So the React team decided to create a built-in class method called create class, as you can see here, to initialize the component with the initial state that was required for the component, right? So as you can see in this code snippet, we use a function called get initial state function, create class by React library. So this was like a built-in function that was created by the React library in itself in order to set the initial state for a particular component. And in 2017, then JavaScript became super powerful by releasing some of the cool features like arrow functions, classes, etc. Then the React team decided to use native classes from ES6 instead of reinventing the whole wheel again, because the main purpose of React is to make a developer-friendly web framework for us to create amazing UI and not to redevelop the existing JavaScript features, right? So they just moved from the create class, which was like initially introduced, to the ES6 features that's provided by the JavaScript in itself. And even after adopting to the recent JS standards, there were still some issues, like we need to always use constructor along with super to initialize that particular component. And apart from that, we also have to initialize on bind the functions that a particular class component uses. If we don't use it, like there will be a lot of problems that we might run into, right? So these are a couple of issues that were still present even after adopting to the classes provided by ES6 feature. And in these issues are not the issues that are being provided by the React in itself, but more of a superficial issues provided by JavaScript itself. So we all know how weird JavaScript is. It's a beautiful language, but it has its own way of its working, right? So these were the issues that's being provided by the JavaScript classes. So then the class fields were introduced, which didn't require us to use the constructor and binding. We can simply just initialize the state using this.state property. This did solve some of the problems, but then like there were some issues, like we were not able to share some non-visual logic like UI states among multiple components, and there was no way for us to share data among multiple components back then. And also there were no ways to create state in functional components. We always have to create a class component in order to use a particular state. So we cannot really do any functional components state manipulation, and also we are not able to basically just manipulate any lifecycle methods that we need to do in functional components. So these are some of the drawbacks that were still present even after adopting to the recent class fields. So to overcome all of those mentioned issues, React team came up with some superpowers by introducing hooks in the version of 16.8. And there are more than 15 hooks currently available, which tackles all of the problems that we saw previously. And we will just go each one of them like one by one and see in detail what problem they solve. So apart from just making us to use states inside a functional component, it can be a tagline. But then apart from that, they're also very easy to use, reusable and flexible. And it's also a completely optional way, not like a mandatory way to put in states inside of React components. And they're also 100% backward compatible, as in like if a particular React application contains classes or for all the components, it's not necessary for you to move to functional components in order to use hooks. You can use both hooks and classes in a React application. So there are no plans to remove classes from React anytime soon or soon. So it does sound similar to like Redux, which we already have, which is like a global state management, right? But like there's a big difference and also a slight similarity among these two. So what's up with Redux? So Redux and React hooks should not be seen as like the opposite of each other, but they are different things with distinct goals. But when React hooks were born, several developers seemed confused by the concepts introduced and how they will interpolate with the React library. And Redux and React hooks should be seen as like complements. So like for example, use context, use reducer are some of the hooks provided by the React library to manage local state in a particular component. And in order to maintain a more global state, like among big React applications, we always prefer Redux to do that. So if you're thinking about building an application, like both can be used, while Redux holds the global state and actions that can be dispatched, and the React hooks features to handle the local component state. So before seeing how to use them in our applications, we need to always make sure the rules that mentioned here are being followed before using them. So there are like a couple of rules that we need to adhere to. The first one being we should not call hooks inside loops or conditions or nested functions, right? And also we can use hooks only like inside the function components. And that's like one of the main tagline. We cannot use them like in class components. And also, we cannot call them inside a regular JavaScript functions, but we can also call them under custom hooks, which we will see more in detail in the later slides. So as I mentioned earlier, there were around 15 hooks that are currently available, provided by the React library, and each one of them overcomes some of the drawbacks that like we had before provided by the class components. So as you can see here, like there are hooks like state, use context, use reducer, and among these 15 hooks, we will see the most commonly used ones in detail with example and a quick walkthrough for the rest of them. Since it's kind of difficult to cover all of them in a single session, and it also doesn't make sense like to learn about everything at once. And so in this session, we will just learn about the most commonly ones in detail with example, and the rest of them I'll just give a pretty much introduction level knowledge about each of them, so you can come back and refer to them like later on if you plan to use them in your future projects. So let's get started with the most commonly used ones. So as you can see here, the three most commonly used ones in the React projects recently are like use state, use effect, and use context. The first hook being use state. So I guess you can get the idea of what it does from the name in itself. So this basically gives us an advantage to add a local state to functional components. So as I previously mentioned, there was a big, huge drawback of us not being able to add local states to functional components. We always have to rely on class components in order to add a local state. This was removed with the help of use state hook. So yeah, as I said, like with the introduction of this, we can now add local states to also functional components. So like this is a big advantage because we can now share a non-visual UI logics too among multiple components, right? So in order to use these functionality, there are three things that we need to make sure to do. The first step being like importing this function from the React library. So these functions are available only after the version of 16.8. So we always have to make sure that we update the React version to like 16, like more than 16.8 in order to import these functions inside our project and use them. So the first step being like importing them from the React library. So we call it inside a function component to add local state, and React will perceive the state between re-renders. So this use state function basically returns two values, one being the current state and a function that lets you update it based on array destructuring. So you can call this function from any event handler or somewhere else. This is actually similar to this set date in class, except it doesn't merge the old and new state together. So yeah, and the first step being like importing them from the React library, and the second step, like what does use state returns. As I mentioned here earlier, you can see that the use state accepts an argument, which is like the initial state, and it returns a couple of values, one being the state and another being another function which will manipulate that particular state. So like this is the pretty much like what's the functionality about use state. Whenever the value of this particular data that we pass to this use state function changes, the set date function kind of updates and re-renders the page. So the third step being, in order to update the state, we use set state. So this is similar to this set state to classes. So this is a classic and a simple example where we are just trying to update the counter value on a button click and display an updated counter value, right? So as discussed, the first step, like we are importing the useState function, and then we are setting the initial value to 0, and then we are using the setCount function to keep updating the value based on a button click. As you can see, we have added a local state to a functional component instead of not relying on a class component. So this is some of like one of the really superpower that React has introduced in the recent version. And also, we can use the state hook more than once in a single component. So like the use state accepts one single argument, which is the initial value, and it can be of anything like a number, string, or an object. So it's not restricted that you should use only one single state or one single local state to a particular component. There can be multiple local states added to the component. So for example, here, like we have created a one particular local data with a number, another particular data with a string, another data with an object. So all of these can be like considered as a local states to an to an particular component. So this is like pretty much about the use state hook. So moving on to the next one, next commonly used one, which is use effect. So for any React applications, it involves some kind of data fetching, like subscriptions, or manually changing the DOM from React components, right? So we call these operations like side effects because they can affect other components and can be done during rendering. So that's why the name comes from the effect hooks. The use effect, it gives the ability to perform side effects from a functional component. So and we usually split the logic amongst different lifecycle methods when a component needs to update the DOM based on a condition like in previously in class components. But like with the help of use effect, you just combine the different lifecycle methods in order to single API. So it basically tells the React to do something after render. So it serves the same purpose as component did mount, component did update, and component will unmount in React classes, but all of them together unified into a single API. So similar to useState, we have imported the use effect from a React library again in order to use that function. And then in this example, we are just simply trying to update the document title with the count variable after the page is rendered, right? So the use effect keeps executing after each render, including the first render of the DOM. So if you have done the same thing like before in class components using the different lifecycle methods, this particular piece of code would have grown to like at least 5 to 6 of them, and there will be a lot of duplicate repetitive code that we have to maintain across different lifecycle methods. So with the help of this use effect hook, we have actually eliminated a lot of repetitive code and also make sure that all the lifecycle methods are unified into a single particular API. So there are some functionalities, like as I said, like we can incorporate it under use effect hook, for example, network request, login, or DOM manipulations. But these kind of functionalities, it doesn't require cleanup. But there are some other functionalities, for example, like subscribing to a particular API, which will be requiring a cleanup after that particular component, like finished rendering in the DOM. Because like if you just keep as it is without cleaning it up, then there is a high possibility that memory leak can happen, because the use effect function just keep executing after after each render and after each update. So it's always advisable to clean up those effects which kind of has some kind of subscription and might lead to a memory leak. So in order to handle these cases where we need to clean up, after unmounting that component, we need to return a function inside the use effect itself, which will get executed before the component gets unmounted from the DOM, right? So like as I said, yeah, here in this example, we have returned a function which kind of unsubscribed from the APIs. So this will execute it before the particular component gets unmounted from the DOM, and this will avoid any kind of memory leaks even after the component renders from the DOM. So we saw that like the use effect just keeps running after each render, and we have to know the reason why it does the way it does, right? So there might be a question like why use effect runs after each update. This is because there might be cases where some of the properties or dependencies that we have subscribed might change, and there can be bugs introduced due to that because the latest properties are not taken into account, and that's why the use effect resolves this issue by executing after each render. So it kind of has a map to the latest properties that's being updated. So this will avoid any kind of bugs that might occur due to like dependencies. And like we can also make sure to execute this use for effect function to conditionally fire, not like every single time. However, this can be an overkill because like the use effect just keeps rendering like after every single change, right? So we can avoid this by conditionally firing effect by passing a second argument to the function as seen here. So now the use effect fires and renders only when the value of count variable changes. So with that, like we can also pass multiple arguments to this use effect function inside that parenthesis. So what does it mean is just whenever the value of that particular property which is passed inside that array gets changed, only then the use effect, whatever it's present inside that use effect, gets executed. So this way we are actually avoiding multiple re-renders or multiple execution of the function that's happening inside the use effect. So with that, we actually kind of covered what's the basics of use effect and how it actually helps us, combining like 3 different lifecycle methods into a single one of them, and also helps us with performance issues. And moving on to the next and the last commonly used hook, which is use context. So the context in general provides a way to pass data through multiple components among the component tree without passing down props manually at every level. So in any typical React application, you can see that it's all about the manipulation of data and presenting them like in a good UI, right? So in any typical React application, data is passed down from a parent to child via props. But such usage can be really cumbersome for certain type of props, for example, like a language preference or a UI theme, because that particular piece of information is actually required by a lot of other different components too. So we have to make sure that is being passed down the tree in multiple components. So we have to just keep adding that property to multiple components, which leads to again repetitiveness. So like in order to overcome that particular issue, React library, they introduced another context hooks called use context. This provides a way to share values like these, which is being used by multiple components without explicitly like trying to pass them through every different component amongst the tree, right? So when this use context function can be used in applications, it's actually designed to share data that can be considered global for a tree of React components, such as, for example, the user authentication, the theme, or the preferred language. So context is primarily used when some data needs to be accessible by many components at different nesting levels, as mentioned earlier. So before getting into the use context function, it's good to know about a couple of things. One is React.create context and the provider. So these are some of the functions that's already been provided by React. So we actually use these, both of them, and also the use context to bring about like sharing data among multiple components. So the first one being a React.create context. So as you can see that when React renders a component, it subscribes to this context object, whatever we create using this React.create context, and it will read the current context value from the closest matching provider about it in the tree and pass them onto the children component. So the whatever the value, or like for example, here as I mentioned earlier, it can be like a theme or a UI preferred language that needs to be passed, can be set as a context object, which needs to be passed among multiple components. So every context comes with a provider and a React component that allows consuming components to subscribe to context changes. So this provider component accepts a value prop to be passed to consuming constants that are descendants of this provider. So that's a couple of things like we need to be make sure that we know before using the use context. So in this example, like we have just created a simple context object, which is a theme context, which kind of stores the theme value, and that is a provider that we have added, like which has a value of 42, and this particular value is being passed to the different child components that is present inside this provider. For example, here we have a child component called display. So this particular theme provider value will be passed to all the child components present among this provider. So we have created a provider, we have created a context. Now we can import this use context hook from React by passing whatever context we created before, and use this value anywhere without passing down the props everywhere. So in this way, we can pass data which is used by multiple components without even just keep adding like props, like extra property for all of them. So like as I said earlier, you can use these for features like to store the authentication of a user, or a language, or a theme. And with that, we have seen like 3 of the most commonly used React hooks in many projects. Apart from that, the React team also introduced multiple additional hooks, as I said earlier. So, and I know it's already a lot of information to grasp. So the additional hooks, I'll just quickly walk through what are currently available and what is the main use of each of them. So you can all know that that is that function that exists to solve a use case. So later on, you can, whenever you work on something on your project, you can just come back and know that that is something that already that React solves. And it's also kind of difficult to cover each and every one of them in a single session. And we can refer to the React docs document for that. So with that, let's see like what are the different additional hooks apart from these 3 we saw early on. So the first one being useRef. So useRef are actually basically used for returning a mutable reference object, which basically stores a current property that can be initialized to the past argument. You might be familiar with refs primarily as a way to access the DOM. Like for if you pass a reference object to React, it will say that the current property to the corresponding nodes whenever that node changes, right? However, useRef is more useful than a particular reference attribute. It keeps handy like for just making sure that a mutable value is always being in accountable and being used for it. And the next one being useReducer. This is actually an alternative to useState. It basically accepts like a couple of values like state and action, which is similar to the reducer that's already been introduced in the Redux state management tool. It actually also returns the state like based on a particular action. So the use reducer is usually preferred when you have a complex state logic that involves multiple subvalues, or when the state depends on the previous one. So as I said, this is similar to the reducer provided by Redux, but the Redux is more useful when it comes to like maintaining the global state, and use reducer can be used for a local state of a particular component. So this is like one thing that you need to keep in mind, like when to go for Redux and when to go for hooks. And the next one being use callback, and this one is helping in returning a memoized version of a callback that only changes if one of the dependencies has changed. So this is pretty useful when passing callbacks to optimized child components that can rely on referring equality to prevent unnecessary renders. For example, if a particular callback function it's going to keep just returning the same value each and every time, it's actually advisable to kind of memoize them, so we kind of avoid a lot of performance issues, right? So in those cases, we can actually make use of use callback hook. And the next one being use memo, which is actually similar to use callback. It returns a memoized value to compute only the value whose dependencies changes. So we similar to use callback, we kind of store the values only when the previous and the current value changes, and this optimization helps to avoid expensive calculations on every render. And next one being use imperative handle. This is actually helpful in customizing the instance value that is exposed to parent components when using the useref. So we can actually make use of this, like, when you want to customize a particular instance value while working with useref hook. And the next one being use layout effect. So the signature is identical to use effect, but it fires synchronously after all DOM mutations. So use this to read a layout from DOM and synchronously render. So this update is scheduled inside use layout effect will be flushed synchronously before the browser has a chance to paint. So this is pretty much similar to use effect, but it's more of a, like I would say, a synchronous version of that. And the last but not the least, which is use debug value. This can be pretty much used for displaying a label for custom hooks in React DevTools. I know we haven't seen about custom hooks, which I think we'll see in the later slide. So this particular function actually helps us to display a label like for all the custom hooks that we create, like under the React DevTools tab, and to debug them. So, so these are the 15 hooks, right now, that was introduced by the React team. So, as I mentioned earlier, it's actually not mandatory to know each and every one of them, and it's not mandatory to use each and every one of them in our projects. But it's good to know that all of them exists in case we need any of them in the future. To know that that is some functionality that's already being provided by the React, right? So. Yeah, and if you still need more functionality according to your specific requirement, we can still create a custom hook like of our own. And React also provides a feasibility for that too with the help of custom hooks. So, like for example, when you have a component logic that needs to be used multiple components, we can extract that logic to a custom hook. That hook can also use multiple other hooks and just provide that functionality to a lot of them. So, for example, like here we have created a custom hook called useFetch. So here, if you want to write a function which fetches a given URL, we can create a custom hook for the same. And we have created a function called useFetch, which contains all of the logic needed for fetching a data from a particular API. And we have removed the hard-coded URL and replaced with the property URL. That's being passed to this particular function. So in this, as you can see, like we have used a couple of hooks and created our own custom hook to fetch a URL from any API and created a custom hook for that. So in this way, we can kind of create a custom hook, and so we can reuse this function and to component to each component and fetch data from any URL. So yeah, with that, I think we have come to the never-ending list of hooks functionalities. And just to give a quick highlights, like we saw why React hooks was introduced in the first place and what unique problems it solved. And also we saw various types of hooks to address each problem. And to sum it up, it's always not mandatory to use hooks in your project, but it's highly recommended to incorporate some powers like that's into our functional components, and also reiterate it, so it cannot be a replacement for a global state management. Redux is something which we use for a larger scale applications, but like hooks is something which we use for maintaining the local states for smaller components. So that's like the main idea that you can get from like seeing through the hooks and Redux. And like these are some of the resources that I would recommend if anyone wants to go through and learn more about them in deeper and gain some knowledge. So yeah, and that's pretty much about like I wanted to share with you all, and hope like right now you've got an idea what like what basically hooks are and when we can use them and why it was introduced in the first place. And thank you so much.
Thank you very much, Nivetha. Definitely very insightful on a very important topic. We can now open it up for some Q&A, and we got a couple questions coming in so far. So first one I've got here is, how can I become better at understanding and using hooks in my React app? And they are a new learner, new to hooks.
Yeah, so in order to start with at a beginner level, I would say that like it's not mandatory to replace all the class components with the hooks that's being provided by React. I would say, like as I mentioned in my talk, like we can start with the most commonly used ones. For example, use state, use context, learn about them and incorporate them and replace a particular class component with the functional component using this particular hook. So you can do this like on a case by case basis for each of these components. So it becomes a little easier since hooks are actually backward compatible. You don't have to you don't have to avoid the class components, but you can still create functional components and also add some local states to it.
Excellent. All right, and what is the future for React hooks in your opinion? Some experimental hooks like use, it's a big change that adds some complexity inside React, and that intends to be a library and not a framework.
Yes, I do agree with like the recent introduction of the Hughes hook itself. It's actually kind of a big change. But my opinion on like future of React hooks would be like it has given us a lot of power when it comes to like adding a lot of functionalities into functional components rather than class components. So instead of like just thinking about like is it like mandatory to use all of them, I would say we can use some of the superpowers that's being provided by the hooks currently and incorporate them, and like as and when like we feel if it's required for a particular project, we can use them instead of just using it just for the sake of using it.
All right. Okay, and another one. When exactly should we use context and use reducer from Redux?
Yeah, like as I mentioned earlier, I would highly recommend to use hooks while maintaining only the local states for smaller components. So if your particular, this actually depends on the React application that you're working on. So if your React application is kind of a large scale application which has a lot of global states, which is being used by multiple different micro frontends, then I would highly recommend using a Redux, which is actually a state management tool. But if you want to just add some kind of a local states being used by only a few components, then we can always go for use context and use reducer. So like for a big application which involves a global state, go for Redux, and for the local components, it's better to go for use context and reducer.
Right. And another one, how do we overcome the conditional hook call error? For example, if we have no data and we want to return an empty content before any hook is called.
Yeah, like in order to avoid this conditional hook call, like that is a particular value that we can pass like inside the use effect in itself. So inside the use effect, if you don't pass any value, like it just keep rendering for all the data change. But if in case like if you want to kind of re-render or execute a particular set of function under use effect only based on a particular value change, then you can pass that particular property inside an array to that function. So in that way, this function will execute only based on the value change that's being done by the property, not like on every change.
Thanks. And what is the difference between a custom hook and just a normal function?
Yeah, like I think I just gave a little bit introduction about the custom hooks. So like as in the talk we have seen, like we saw like almost like 15 different hooks that was provided by React team, right? So apart from that, there might be cases where we want to kind of abstract like some of the logic or some of the business logic and create a particular hook out of that, which needs to be used by multiple components. So here in my talk, I have took an example of fetching a particular data from a URL. So I have created that particular hook, which as a custom hook by using multiple other hooks like useState and useEffect. So depending on the business logic, if you feel that if a particular logic needs to be used by multiple components and that logic uses different hooks, you can put together and then create a custom hook out of that. The only condition for a custom hook is just you have to use that keyword like use. So that's the only condition, but then like you can create like custom hooks for any business logic. And I think normal function is just like, I guess it's just normal functions. Yeah.
All right, and we'll probably have time for one more. Okay. But is there any universal way of handling shallow comparing features of hooks when we have an object or an array as a dependency?
Okay, so I think this one is already being handled by the useEffect itself. It kind of checks the previous state version and the current version, and if both of the values are different, only then the component updates. If both of them seems to be the similar value, then they don't update. So this shallow comparing of values is already being handled by some of the hooks that's provided by React library.
All right. Okay, and that takes us up to time. Thank you so much, Nivetha, for being here and answering questions and giving such a great presentation.
Yeah, thank you. Thank you so much, Devin, for having me again, and have a rest of the good conference, and see you all soon.
Thank you. Take care. All right, and next up, I'm going to welcome Tyler Hawkins to the stage. And he is going to be giving us a little bit of an intro to test-driven development for building user interfaces. All right, take it away, Tyler.
Awesome. Thank you, Devin. Super excited to be here today. As Devin mentioned, the talk title is Test-Driven Development for Building User Interfaces. A little bit about me. My name is Tyler. I currently work as a senior software engineer and tech lead at Adobe. If you want to find me, you can find me in all the normal places, LinkedIn, Twitter. I also do write a lot, so you can find me on Medium or Dev or HackerNoon. Yeah, let's dig in. So for today, we want to answer 3 big questions about test-driven development. So the first one is, can we use test-driven development to build UIs? Second, if we can, how do we do it? And then third, should we use TDD to build UIs? Is that even a good idea? And so I'm going to assume that most of you are somewhat familiar with TDD. Maybe you practice it every day and you love it. Maybe you absolutely hate TDD, but I'm assuming you're at least a little familiar with it. If not, just a very, very brief overview. TDD is a paradigm or a mindset in which you write your test first and then you write your code. So you can see we've got a very simple diagram here where we begin with writing a failing test. So we write a test for some behavior that we want to implement. And that fails because we haven't written the actual app code yet. And then we write our app code. So we make the test pass. And from there, we can refactor if we need. And then we go write another test, and that cycle continues. And this is called the red-green refactor cycle. You can see up at the top that as soon as you write the failing test, you're in a red state, right? Your test is failing. Then you make the test pass, so you're in a green state. And then you do your refactoring while you're in a green state. You always want to do refactoring while tests are passing, not when tests are failing. So that's TDD. That's how it works. And so why do people use TDD? Why does this development paradigm even exist? There's a few good reasons. The first is that when you use TDD, tests are built right into your development cycle, not as an afterthought. And so sometimes if you're writing tests after you've already written your code, sometimes it can feel a little tedious. You know, maybe you've already manually verified that your code works and it feels like, why do I need to write these tests? It's not super important. I know this works, or at least I think it works. But with TDD, that doesn't really become a question. You're just writing tests as you go. It feels a little bit more natural. Secondly, it makes sure that your tests are testing the right things. When you're doing test-driven development, you are writing these tests largely based off of product requirements and the things that your code needs to do or features it needs to support. And so rather than trying to go back and write tests after the fact, where maybe you're just kind of trying to, make sure your code coverage is good and increasing those lines covered, With TDD, you're actually making sure your tests are covering the right product requirements. Third, with TDD, every branch is covered in theory. Again, the idea is that you write the test and then you write the code to make the test pass. And so in theory, you shouldn't have written any code that's not tested. So you should have 100% code coverage, or at least very close to it. And then fourth, higher productivity. This is according to some studies. This is, of course, highly subjective. It's very hard to define and measure developer productivity. But there are many people who claim that it will make you more productive. So that's why we use TDD. That's what it is. When do you actually use it? TDD is great when you have clear project requirements, so you know exactly what you're going to be building, what the functionality needs to look like, how it needs to behave. It's great when you have clear inputs and outputs. So for things like pure functions, where if I call my function with X, it returns Y. And no matter how many times I call my function with X, it will always return Y. That's a great use case for using TDD. Similarly, API endpoints are great for TDD as well. When I call this endpoint with these parameters, it gives me this response. That's a very clear input and output. And then third, bug fixes are a great time to do TDD too. When you have a bug that's been reported, it's a good practice. Go write a test to say this is what it should be doing, this is how it should be behaving, and then go write that code to fix that. Right? TDD is a good use case for that. When not to use TDD, though. Oftentimes, TDD is not very helpful if you're doing exploratory programming. If you're just kind of prototyping something, or you're doing some research and trying to figure out how something would work, TDD is probably not going to be very useful, largely because you probably don't have very clear requirements. It probably would not make very much sense to start writing tests before you write your code. And then second, and this is the one that we'll explore today, is UI development. Oftentimes when we discuss TDD as engineers, the conversation kind of turns to, okay, yeah, that's well and good for back-end development, or just writing some functions, but TDD isn't very useful for building UIs. And so today, I'd like to question that. I have a hypothesis here. That TDD for UIs isn't as hard as we think it is. And so let's explore that a little bit. And so if we just revisit those three requirements that we've outlined of when to use TDD: clear project requirements, clear inputs and outputs, and bug fixes, how could that map to front-end development? Well, first, for clear project requirements, we have design mocks. Typically in the software development lifecycle, prior to starting on any new feature work, a UX designer might present, okay, these are the mockups, this is what we're going to build, and UX and product will walk the developers through that. You'll talk about what it's going to look like. You're going to talk about how it will behave. Developers can ask questions, and hopefully you can really think through all of the various states and edge cases, right? Like, what's the empty state going to look like? What are what's going to happen if an error happens? What happens if there's no data, right? And so you should have pretty clear project requirements as far as what you're building. Clear inputs and outputs. If you think, especially in the React world, components are just functions. React components are functions of props and state, and it's written in a declarative manner where for each component we say, okay, when you give this prop to this component, you should render this output, or when it's in this state, it should render this output, right? And so components are actually very deterministic. These are a pretty good use case for things that have clear inputs and outputs, because again, these are just functions of props and state. And then finally, bug fixes are still applicable, right? If we have clear project requirements and we have clear inputs and outputs, then we should still be able to use TDD for bug fixes in our UI. So in theory, this should work. But when we talk about that and we kind of present those ideas, a common objection that you'll often hear is someone will say, okay, yeah, but I don't know how I'll end up building my UI. I don't know what it's actually going to look like. I don't know what components I'm going to use, what the state or props are going to be. I don't know the name of my functions. I don't know what HTML elements I'm going to use. Is this going to be a div or a span or a paragraph tag? I don't know. And so they kind of object to that, saying, well, it's not super clear. And so let's explore that for a minute. So we have those unknowns. We don't know the component state and props. We don't know the function names. We don't know the HTML elements used. But we do know how the UI looks, and we know how the UI behaves. And so my response to that kind of objection would be that, well, the unknown implementation details don't matter. That kind of thinking, I think, largely stems from older ideas of testing philosophies, largely between kind of the rift between Enzyme and React testing library. Before React testing library came about, Enzyme was kind of the leading React component testing library. And Enzyme very much focused on the implementation details. You could reach into a component and programmatically update the state or the props, or you could reach into the component and directly call a component method. React testing library very much takes the opposite approach, where as opposed to focusing on implementation details, it focuses more on user interactions, with the whole philosophy being that users don't say, I'm going to trigger this method, or users don't manually update pieces of state and props. Users interact with the UI. They click on a button, they fill out a form, they use these interfaces and don't really have to think about or worry about the implementation details. And so as long as we're using a library like React Testing Library to test our code, the takeaway here would again just be that the unknown implementation details really don't matter. We should still be able to use TDD to build UIs because we have those clear inputs and outputs. We know how the UI should behave and what it should look like. That's my pitch. Hopefully that is a compelling enough argument as far as why TDD should work for UIs in theory. But theory sometimes breaks down in the practical world. So let's do a demo. Let's try this out. We're going to do a little bit of live coding here. So this is what our demo is going to be. We are going to build a simple little request form. And so you can see we've got, these will represent 3 different screens. So these are our mocks that UX is presenting to us. So we're going to have a very simple form. So imagine this is like something on a product landing page, and you want people to be able to request a demo to try out your product and have someone get in touch with them, right? So over on the left, the first mock, we're just going to have a simple form here. Someone can add their first name, their last name, their email, and then click request demo, that button. If they don't fill out any of those fields, we'll have just some very simple form validation right there. We'll just ensure that each of those are not blank. So in that second mock in the middle, if they try to request it with any of those not filled out, we'll get those error messages. And then third, over on the right, once they fill out the form correctly and clicked request demo, the form will be replaced and they'll see a brief confirmation message, right? So that's going to be what we're going to build. So let's go build this thing. So I'm going to come over here, and yes, you should be seeing the browser on the left and my text editor on my right. So we're going to play around in this example demo app. If you want to check this out later or follow along at home, you can find it. It's at thawkin3 TDD for UI demo 2022. And you can see here we've got those same design mocks right here. We've got this running in our browser. Over on the right now, this is the editor. I've blown up the font size a little bit. Hopefully that is large enough. So right here we have our editor, we have our app, and we're running 3 things in our terminal. We have, hit that real quick. We have the app running, so that's just yarn start. We have a formatting script running, so I'm just using Prettier here to format my code as I go. And then we have our tests running. So let's do this. Let's use this demo and let's try to build something. Let's try to build a user interface using TDD. So if we go look at our mocks, we want to build this form. We want this first name, last name, email. So I'm going to start with a test because this is test-driven development. So I'm going to create a file called requestform.test.js. And we're going to import React from React. And we'll also import render and screen from React testing library. And then we'll also import our component. So we'll import request form from request form. Okay, and then we're going to set up a describe block. So we'll say we're describing our request form component, and then we'll write our first test. So let's just say it renders without crashing. And let's try to write a test, and we'll just say that we expect that when we render the request form, we expect that not to throw. Okay. So let's run that. And so you can see that our test fails. And it says, okay, we can't find the module request form. And that makes perfect sense. We have not created a request form thing yet. So TDD, right? We've written the test, it's failing. Now let's go make it pass. So let's go create that request form file. So I'm going to create a request form.js file. And we'll import React from React. And we'll export a constant called request form. That will be a function. And we'll just say it's going to return a form element. Okay. Now we've got our test running in the bottom. And you can see it passed. Great. Wonderful. So we've moved from red to green. Just as one little thing, I'm going to make sure our app actually renders this too. So I'm going to say import request form from request form, and then we'll render that in the app. You can see over on our left, we have our app that is not displaying anything because we just have an empty form, right? So, okay. So we've written our first test. We have a component, it exists, and it renders, albeit it's just an empty form and it doesn't actually show anything meaningful. So let's write a second test. So we can say it renders a first name input. And so we're going to render the request form. And we'll expect that we can do a screen.getByLabelText first name. We'll expect that to be in the document. Okay. And oops, not get by label text. Let's fix that. Okay, here we go. Okay, so our test is failing, and it says unable to find a label with the text of first name. And you can see it helpfully prints out what's actually being rendered to the DOM. We just have a body, a div, and a form. So that's expected, right? So we're doing TDD. So let's go write that first name input. So we're going to return a form. And in here, we'll have a label. So we'll give it a first name. And then we'll have an input. And we'll give that input an ID. We'll call that first name. And we'll give our label the HTML4 attribute so that we can hook up those two. And we'll save that. And perfect. So our test is passed down at the bottom. And you can see over on the left, we have a first name right there. So we've created part of our UI. Now here's one of the important parts. So we talked about that red-green refactor cycle where we have red, we write a test, we have green, that test is passing, and then we have refactor. We can refactor in the green. And so when we're doing UI development and test-driven development for UIs, what I would recommend is that style changes be part of these refactors. And so we've got a first name and an input, and we probably want a little bit of space right there. So we could do some style changes, right? So we could say request form.css. We could say for a label, we'll just put some like padding right of 1 rem. And then we'll actually go import that into our code. So we'll import from the CSS. Okay, now we've got some spacing in there. And so note, as we do that, our tests were passing, and now they're still passing after that, right? So we're still doing that red-green refactor cycle. And as we refactored, we started in the green and we stayed in the green, okay? Okay, so let's go on to our next one. So we have it renders a first name input. So let's do the same thing. Let's write another test. We'll just copy this one and we'll say we want it to render a last name input. And so we'll render our request form and we'll expect screen.getByLabelText to last name to be in the document. So now you can see our test fails. It says unable to find a label with text of last name. And that is, of course, expected because, again, we're doing TDD. So let's go create that. So we can grab this right here. We'll just copy that first name, last name input. And I'm going to change first name to last name for the HTML4 and the ID. Change the visible text to last name. Okay. And that passed again. So now we have passing tests. We're in the green state. But it's time to refactor, because if you look back at our mocks, we want these to be in rows. And right now they're just next to each other on the same line. So let's go do that. Let's refactor that. So I'm just going to put a div in here. Put that, and then another div. Okay. Let prettier format that for us. So now you can see here we've got two rows. Are still in the green. It's still passing. We probably want to style that up a little bit still. So we could do div, and we'll just say class name equals form group. And then for there, that's our code. And for each form group, we'll say we want a margin bottom of, okay, that looks pretty good. There we go. So now we're still passing. We're in a green state. We finished our refactor. So let's move on to our next test. So now we want to render an email input. So we'll say renders an email input. We'll expect that we get the label text of email. And our tests are running now. And of course it fails. Expect it again. It says we're unable to find a label with the text of email. So let's go do that. So we'll come over here and we'll create another form group. This one will be for email. Email. And just to make this a little more accessible and to pull up the email keyboard on a mobile keyboard, we'll put a type equals email on there. Okay, so that passed. We're in the green again. Now it looks like it's time for another style refactor. In the mocks, you can see that these all line up nicely. And here, the first name and last name kind of line up, but email doesn't. So let's go fix that. So we can go fix that with our, probably with our label. So for that, we could just display that inline block, and then maybe just hard code a width here. And then we can get rid of that padding right. And there we go. We've got that set up here. Wonderful. And we're still passing. We're still in the green because that refactor was done in the green. So let's do one more test for our submit button. So we're going to say it renders a request demo submit button. We're going to render our request form. And we'll expect, this time we'll say screen.getByRole, and we'll look for a button with the name of request demo. And we'll expect that to be in the document. Okay. Now that's going to fail. So it says unable to find an accessible element with the role button and name request demo. It says, okay, here's some things we can find. We found a first name, a last name, and an email. And that again is expected. We wrote our test and it fails. So let's go implement that. So for here, we'll just do a button and the type will be submit and the text will be request demo. Okay, and that all passes. Great. So here we go. We've got a form. We've got a first name, last name, email, request demo, and it's starting to look a little bit more like our UI. In the mocks, you can see that it's got a border around it and it's centered. So let's do that really quick. So for that, we'll probably go write some more CSS up here. And we'll say our form, we want a border. We'll just say solid 0.065 round. That's 1 pixel right now, and black. Okay, so we've got a border in there. We'll put a border radius. We want those edges kind of rounded. We'll put some padding in there. That's great. We don't want it to span the entire width of the page, so we'll probably just display that inline block.
Tyler, just a second. I think these are asking us to increase font a little bit. Can you do it, please?
Yes,
Perfect. Thank
absolutely.
You so much.
Thank you. Thank you for telling me. Is that big enough now? If we go through here and here. Seem a little better? Okay. Thank you. Perfect. Hopefully that's a better size for you. Okay. Just to recap, if you missed any of that, just looking at it. So we've written our tests. So we've written a few tests for renders without crashing, first name, last name, email, and submit button. And we've started creating that form right here, right? So there you go. Nice and big. Hopefully you can see that better. Okay. And so now as we finish up these style changes, we have the form and it's looking good, but it's not centered yet. So let's go change that. Let's go say, just like text align the body, center, and that's great, but now our form's not aligned. So we'll come back to our form and we'll do text align left here. Okay. All right, there we go. Okay, so we've finished that first mock. We've used test-driven development to build that initial UI. And it's looking pretty good. That should be about what we're looking for. So now let's start going into some of the behaviors. So the second mock here is that we want error messages to appear on form submission if the fields are left blank. So how could we implement that? And how could we write a test for that? So let's start with one test here. And we're going to say it displays error text if the user submits the form without filling out all the fields. Write that. So how can we do that? Let's render our request form. And then we're going to use the user event library. So this is a companion library to the React testing library. We can import user event from testing library /user event. This is a great library for triggering, just triggering events in your React tests. So we use user event, and we're going to say user event dot click, and we're just going to click that request demo button. So I'm going to come over here and just paste that right there. So user event dot click screen.getByRole button with the name of request demo. And when we do that, we're going to have some expectations here. So we'll expect screen.getByText first name field is required. We expect that to be in the document. And then we'll just copy and paste that a couple more times. We're going to expect that same thing for the last name field and then also for the email field. Okay. All right, so we've got our test and it fails. So the first error we have here, it says not implemented HTML form element.prototype.submit. So it's saying that our form doesn't have a submit method. So let's go do that. So we'll say on submit, we'll say handle form submit, and spell that correctly. Okay, and we'll define a function here, a function of e, and inside of that, we can do e.prevent default, and we'll save that for now. So that e.prevent default, that's going to avoid clicking on that button, basically making a GET request and refreshing the page. So that's great. So now we have a new error message, and it says test fails, unable to find an element with the text first name field is required. And that should again be expected because we haven't implemented that. And if I click request demo, it just does nothing. So we want to go implement that red text here, that first name field is required. So let's do that. And so to do that, we're going to start using some state here. So we're going to pull in that use state hook from React. And we're going to set up a couple pieces of state. So we'll say const first name and set first name. And that's going to be with the use state hook and just an empty string. And then we're going to create an event handler. And we'll say handle first name change. That will be a function of e, the event, and we'll say set first name with e.target.value. Then we'll start using that. So we're going to put that down here in our first name input. So we'll say the value is the first name, and the on change is going to be the handle the first name change. Okay. We'll save that. And then from there, we want to be able to display an error message if we click the submit form and it's empty. So we're going to set up another piece of state here. We're going to say const first name error and set first name error. We'll do another piece of use state, and that will be an empty string. And then let's see, as we do that, what we're going to do is on our handle form submit, we'll say set first name error, and we'll say if there's a first name, then it's just going to be an empty string. And if it's not, we'll put that text in there. We'll say first name field is required. So we've got that. And then finally, we need to actually display the first name error. So probably just right below our form group, we're going to say first name error, and we'll just do a paragraph, and we'll display that first name error. Okay, that was a lot. Hopefully that will pay off in a minute. So let's try that out real quick. So if I just click request demo, ta-da, we've got some text in there. Great. We've got the first name field is required. And you can see that our test has also given us a new error message. So now it says unable to find an element with the text last name field is required. So we're making progress. We've got that first name field is required in our output, which is wonderful. So for the sake of time, I don't want to bore you with me doing the same thing for the last name and email. So we're gonna cheat a little bit here, and I'm just gonna grab this stuff. So this is the validation for all three fields. So I'm gonna pull that up here. You can see that basically what we're doing here is the exact same setup. Now we have state for first name, last name, and email. We have errors for first name, last name, and email. We've got event handlers for those, and then we're checking the handles form submit. And then we've got each one of these displaying in UI. So we're going to paste that real quick so you don't have to watch me do that for the next 10 minutes. So we'll do that. And here's the moment of truth. You can see it passes. So super exciting. So that passes. And if I click request demo, you can see it's working, displaying that text. It's not quite styled up yet, but it is passing. And so now that we're in that green state, we could style this up a little bit if we wanted. So we could say maybe for each of these paragraphs, come in here and let's just give that a class name of error message. We'll save that. And then over here, we'll say .error message. Just give that a color of red. So that's great. We'll give it a margin top of 0, kind of tighten that up a little bit. And then let's see, we'll probably want to get rid of some of the spacing on the form group. And so we can come over here to our inputs. And so for each of these class name equals form group, we could instead turn that into a template literal string. So we'll say form group. And then if we have first name error, and we'll clean that up for each one of these. But if we have that, then we'll do something. Otherwise, we'll do an empty string. And if we have that, we'll put an error in there. Okay. And yeah, there we go. Okay. And then we have a first name error. We have changed that to last name error, and we'll change this to email error. And then as we get into this form group, we can say form group dot error. We'll say margin bottom is 0. So there we go. And then you see if we were to just click that, it kind of jumps a little bit. So we could fix that with like the line height. Just say line height is 1. That should avoid any jumping here. So there we go. Okay, wonderful. And as we did that, as we did all that refactoring, that style refactoring, you can see that we are still in the green. It's still passed. So let's write one more test. This is going to be the last part of our demo. We've got our second mock, and that's great, but we still haven't done the confirmation text yet of submitting it successfully. So let's go make sure that works. So let's write one more test, and we'll say it, sorry if I could type here. It replaces the form with confirmation text when the user successfully submits the form. Okay, so we're going to copy these 2 lines. We're going to render it, and at some point we'll click that button. But before we click that button, we're going to want to type into each of our inputs. So we'll say user event.type, and then the element will be screen.getBy label text first name. And the value that we type is going to be, I'll just type my name. And we'll do the same thing for last name. Type that in. And then we'll do email. Okay, we're going to type that. We're going to click this button. And then from there, we want to expect that we have the screen.getBy text. And that text is going to be, thank you. We will be in touch with you shortly. And we'll expect that to be in the document. Okay. So we've got that. And let's see what our test does. You can see that it fails, and it says unable to find an element with the text, thank you, we'll be in touch shortly. So that makes sense because we haven't implemented that yet. So let's implement that, and this will actually be really short to implement. All we need to do is we could just set up another piece of state. We could say submitted and set submitted. We'll start that with use state of false. And then as we render our form, we can say if it's been submitted, then it's going to render something. Otherwise, it will render this form. And if it's been submitted, it will render thank you, will be in touch shortly. And then finally, in our handle form submit, we can say if first name and last name and email, then we'll set submitted to true. So we'll save that. And look at that, it passed. And so just as kind of a final confirmation, if we want to look at that real quick, if I were to type that in, a period instead of comma. Okay, wonderful, it worked. Okay, so we did it. We built a UI, and we built it using TDD, and it worked. And we got all our tests to pass. We implemented everything. We got the correct behavior. We got the correct styles. And then even as a bonus, I'm going to show you if we just run yarn test coverage is another script that I've set up. We can look at the test coverage here. And if we scroll down, it's too big a font size, but we have 100% coverage. Everything is covered because we use TDD. And so just in the last couple minutes here, just to recap, if we were to go look at our presentation one more time, let's go look at that. Here's the wrap up. Here's the conclusion. Can we use TDD to build UIs? Yes, we absolutely can. And so as people have this debate, right, of can we do it? And it's not really possible. I'd like to dispel that myth. It is absolutely possible. You can do it. How can we do it? By following that red-green refactor cycle, where we write a test, we go write the code to make it pass, and then we refactor as needed, with an emphasis being that as we make refactors, that's often when style changes are done. And then finally, should we use TDD to build UIs? Maybe. I don't want to try to say that this is the only way to build UIs, the only software development method, because obviously that's not true. And many people build great UIs without doing TDD. But I think you should try it. I think you should embrace the idea that it's possible and that it's worth giving a shot. So if anything, what I hope your takeaway here is that using TDD to build UIs isn't as hard as we think it is. Thank you.
All right, thank you very much, Tyler. Definitely very informative and interesting to watch. Awesome. All right, so let's take a look. It's time for Q&A, and we've got plenty of questions coming in. So let's start with the first one here. All right, adopting TDD in a small startup as a tech leader, how can I promote this in a small team, maybe 5 devs, knowing that an MVP should have the minimal effort investment, but also should be a reliable product?
Yeah, that's a great question. How can you promote TDD in a small team? I would say, I mean, honestly, whether you're a small company or a large company, the principles we've discussed here should still apply, especially as you're building an MVP, right? You can still define those product requirements beforehand, right? You can define, here's the MVP. And with that, you can still define the mockups beforehand. And so TDD would be a very viable solution, right? As you build your UIs. And then, you know, as we're talking about MVP, oftentimes that means is we had these grand ideas and now we kind of scaled it down a little bit. We dropped out some of those extra features. And so those discussions can still be had, right? If you need to drop something, great, drop that from the mocks. If you need to, maybe you finished the MVP and now you need to build something out. That's just adding a new product requirement. So now you've added a new requirement and now you can add new tests to go implement that. So this kind of paradigm and way of thinking actually works fairly well, really no matter the scale of your company.
All right, thank you. All right, and how would you recommend to architect components to make testing better? Make them as small as possible or test all of them already composed in the parent component?
Yeah, that's a fun one. So there's kind of 2 questions in there. Is like, should components be small or large? And then secondly, like, where do you write your tests? And so generally, yeah, I'd recommend having small components, right? Components should be focused to one thing. This is kind of that single responsibility principle, is the component should do one thing and it should do that one thing well. So the smaller the better, right? If you have bloated components that take 60 different props and have 1 million different branches, that's going to be a burden to test. As the complexity of that grows, the complexities of your test and your app will grow. As far as where to test them, that's kind of a fun, larger discussion that I think React Testing Library kind of opened up for us, because a lot of these tests are really integration tests because each component renders its children components, and we're not just like shallow rendering or mocking these things. And so oftentimes my recommendation there is that we should test all of the edge cases and kind of various branches and logic inside these smaller components. And then for a larger component, so maybe like at the app level or like a parent component level, test some of the bigger picture stuff. So test like the happy path of, okay, I've done this, you know, right? I've used this as expected and it worked. And then also test a few error cases, but don't necessarily test like every single small little path you could take, because otherwise you're going to have like hundreds of tests on this parent component. So push the more specific tests into the smaller ones and then test them as a whole on the parent one.
All right, thank you. And in larger projects, is there a way to run only specific tests automatically rather than having all tests in the entire repo run or automatically or on consecutive code saves?
Yeah, absolutely. So it depends on your test runner or your test framework. I'm using Jest, and for that specifically, like Jest's watch mode is great. It only runs the tests for files that you've changed. So yeah, right, if you have like 100 different components in your app, but you're just working on one component, if you're running Jest in watch mode, like it'll just run the test for that one component. And then I guess probably the test for the ones that component affects, right? So you might have a few test files, but yes, you can run it in watch mode and that will narrow down the scope so you're not running all your tests at the same time.
Right. And is it a good approach to have all the same expect types in the same test? For example, you test all the errors and the required fields in the same test.
Yeah. Oh, wouldn't it be better?
2 out of 2. Wouldn't it be better to test each field separate test?
For sure. That's a fair point. And I think, yes, I do agree with the person who asked this question. In that one test, right, I expected that it showed the error message for first name, last name, and email. We could probably break those up into 3 separate tests. We could say it shows a first name error message when first name is blank, and it shows a last name error message when last name is blank. I combined those for sake of time, but yeah, I think that's a fair point, and it probably would make more sense to split them out into 3 separate tests.
All right. And is it good practice to write tests for the styling as well? If we have mockups, we should ensure that the styling and possibly animations are happening correctly.
Yeah, so that's a fun one, because with like things like unit tests, there's not really a great way to test styling. You could do things like snapshot tests, right, which just basically takes a XML representation of the DOM and stores it in a snapshot. That's what people commonly do for styles. You could write unit tests specifically, like you could do like a to-have style matcher. So you could say like it has the style text color red, right? Or you could use something like totally separate, like I think the name is right. I think it's called Chromatic, but they do some really good like visual regression testing where you can check if things have changed. Anyway, that's kind of a long-winded setup for the answer. So yes, I mean, you could write tests for the styling. My one like thing I would ask you to consider is probably if this is an implementation detail or something that's actually important, like, is it important to test that it has a padding of 2 rems? Like, probably not. If you have something like stylistic that's very important to test, then sure, go write a test for that, however you see fit, whether that's a snapshot or unit test or something more advanced like a visual regression testing tool.
All right. How do you balance wasted time? Working in a fast-paced environment, sometimes requirements can change while building, which will change test expectations and possibly requiring test rewrites.
Yeah. So I would first probably preface that by saying I personally will never view writing tests as a waste of time, which I know is not what this question is saying, but I think tests are always worth it to write those. But yeah, in a fast-paced environment, sometimes the requirements will change, which means that now the expectations will change, which means that those tests will now be thrown away, right? You can hopefully overcome that in some cases by testing, again, the interface and what the user actually does as opposed to implementation details, right? So like if a prop name changes or a function name changes, like your test should still all pass as long as you're testing the interface as opposed to implementation details. But yeah, sometimes stuff will be scrapped or expectations will change, which means you need to delete the tests or you might need to refactor the test or rewrite them, which happens. But I think that is, I don't know, kind of a necessary evil of writing tests, because the alternative is maybe you don't write the tests and then maybe the UI doesn't change. So now you're just without tests, right? So it happens.
Right. And is there a good rule of thumb for when to introduce TDD to your project?
As far as like a certain point in the project, probably not. I mean, if you have not been doing TDD and now you'd like to start doing it today, like I'd say go for it. Like there's no reason to not. I've also been on many teams where, you know, some developers use TDD and some don't, and we all still get along fine. So I don't think it really matters so much. I think that's more of a personal preference for your coding style and how you approach software development.
All right. Looks like last question. On a large-scale product, is there a risk of creating a test suite that is too large and cumbersome to run? What are some strategies on mitigating this?
Yeah, there absolutely is. Because as your app grows, your tests are going to grow, and you might end up with a massive test suite, and maybe you've got CI pipelines that run those tests, and now your CI pipelines are slow because the tests take a long time to run. So yeah, that's a real risk. I think that risk, though, is largely when it comes to like end-to-end tests, because those are much slower. For things like what we looked at today of just using like Jest and React testing library, those unit tests are super, super fast. So like even if you have thousands of those, the execution time isn't going to be over like a few minutes, right? And so I don't think that's like a super big problem with unit tests. It's more something you need to look at for end-to-end tests. But with that in mind, like some strategies for mitigating this, one would probably be to find a way to conditionally run only the tests that you care about. I've seen some places where we annotate tests, and so even though we have a large test suite, based on what files you've changed, it will only actually run the related tests. So that's one option to kind of run that subset. And then another is just to revisit your test suites. Like maybe you've got a bunch of tests in there that you really don't need. Maybe they don't add any value, or they've been covered elsewhere. Maybe there's kind of some duplicate and overlap. So it's useful to review your suites from time to time, especially if you feel like they're getting too large, and maybe there's a way you can kind of cut them down.
All right, excellent. Well, thank you very much, Tyler. Definitely much appreciated. Greatly insightful on a great topic. And yeah, with that, I think it's about time for a break. So I think we've got about a 10-minute break in between here, and we'll see you back.
Awesome. Thank you.
Thank you.
Hey everybody, how is it going? I get the last block and I just can't wait. Oh my word. Welcome back everybody to the React Global's online summit. How's everybody doing out there? Hope everybody's doing good. I'm in sunny Palmdale, California, and I am super excited. Oh my word. I just love this summit. Here, I'm telling you what, there's so much we've learned here, isn't it? Oh my gosh. Anyway, guess what the next one is? I got a really good one for you guys. I got Griffin Solot-Kehl, and he's going to talk about using React UI kits to build a video conferencing app. And when I saw that, I was like, are you kidding me? This is super cool. I can't wait for this one. I mean, we've had some really good demonstrations and presentations. So I'm just going to let him take it away from here, and I'll see you guys in a bit.
Everybody, thank you so much for inviting me to come speak, and thank you so much for attending the React Global Summit this year. My name is Griffin Solot-Kehl. I am a developer advocate at a company called Dolby.io, where I work a lot with the audiovisual space in a lot of different languages and frameworks. So I'm very excited to be able to speak today on using React UI kits to build video conferencing applications, as well as going over what React UI kits are, why you might want to use them, or why you might want to build them if you're part of a company, and just kind of going over a little bit about this nice little feature in React. So without any further ado, let's start talking about the schedule that we have. I'm going to start off with a little bit of an agenda, where we're going to talking about what is a React UI kit. And we're going to get into some examples. We're going to get into kind of what makes it up before we start actually going into a demo where we're going to do a little bit of live coding, understanding how we built a video conferencing application just using only a few lines of code, all with a React UI kit. Then going into some advantages, some disadvantages, and why you should consider building your own if you're part of a company or a brand that is heavily using React already. Then we're going to close things up with some concluding thoughts before we have our Q&A session a little bit later on in the day. So let's keep on going. So what is a React UI kit? And some of you might already know this. This is the React conference, after all. I hope you all know what React is. But in short, a React UI kit, or UI stands for user interface, is all about letting you create custom React components for ease of integration for other developers to use and kind of build their own components without needing to build their own CSS or HTML. It all looks great out of the box, where you're going to be able to get consistency every single time you're going to be using these code blocks. It's going to look very polished, similar across different applications, and it'll also provide easy onboarding of new features, because these are essentially kind of concatenating a bunch of different lines of code and different blocks together so that you can just kind of streamline the process of what a component in your own application or framework is going to look like. So we have some examples of this, including the formerly run by Google Material UI, to Palantir Blueprint, Microsoft Fluent UI, Shopify Polaris, Salesforce Lightning, JetBrains Ring UI, Elastic UI Framework, and all these range in complexity and how deep into the actual product it gets into, from ones like Material UI, which focus mostly just on providing UI, and that's all it's really doing. Things like buttons, tiles, just kind of making sure that the design philosophy stays consistent the entire time, towards ones that actually bring in API-based components directly into them, in ones like Shopify, where you're actually going to be able to interface with APIs and kind of streamline behavior intended for Shopify stores instead of just like a generic Android app or things of the like. One use case that we have in these areas is in account connection, where you might want to be building something that's going to enable you to connect people's different accounts. So this example over here is from Shopify's, where they have an account connection little UI kit component over here on the right, where you're going to be able to see that they just have a little description and they are telling you what clicking the connect button is. And literally what it is it's kind of a little block of code they're able to paste into your React application, and it's going to give you exactly what you see in the picture here. You're able to kind of do some modifications, of course, but it makes it all so it looks very consistent and generic throughout the entire time, so you don't have to worry about making sure that you're creating standard levels of CSS the entire time. This is here to condense API calls to a single button. It's going to standardize the account integration process that you might have if you want to add in things like, in a shop example, it might be adding your PayPal account, or it might be connecting to the shipping notification area. And it's also going to encourage specific behaviors from your user base, as well as the developers who are building integrations with your own application. By making things consistent, you're going to have consistent behavior across different developers, especially when you're running an open source community where people are building in your own plugins. This is a very important thing so that you have standard behavior across all the different kind of new and interesting components people are building with your application in mind. Additionally, we have a use case at Salesforce Lightning in a welcome map, where it's very useful for areas like guiding users through your product. You're going to be able to highlight features and add shortcuts to settings changes all directly within, again, a UI component, where you can see in the example over here, this is a little welcome guide where it's telling you to do things like learn about different products, open up and customize your views, utility bars, access documentation, things like that, to just kind of make the process a lot more, once again, streamlined, obvious, and user-friendly for everyone to kind of participate in. And you can see how this can easily be replicated, forked over, and turned into something very similar but related if you're building a new plugin and you want to make sure people know how to use the plugin. Ta-da! Here is the framework for you to build your own tutorial within the same ecosystem. For this example would be Salesforce developers. So let's already get into a little bit of live coding. That's, I think, what kind of the cool part of this is going to be. This has all been very abstract so far. And what I have already over here is just a VS Code instance with a project that is pretty bare bones. This is mostly just create React app, which I hope most of you are familiar with right now, with a few different Dolby.io specific things that we put into it right here. So we are importing a bunch of different components directly from our Dolby.io Comms UI Kit React. And that is really kind of exactly what we're looking at here, where you can see how we've split a lot of different components into different things that are just as easy as an import. You have the benefit of this being directly imported from NPM, where you can kind of take a lot of the different steps that we'll go into in a moment and kind of sort them out, decide what people want, what people don't want, and then can be used later on down the road. Then we're just doing a little bit of constant mapping, which we're going to be using a little bit later, which is just ways for us to kind of create some text variables for the components that we're creating, add in a little bit of customization directly for the components that we've built in. So it's not everyone has the same exact text. You're able to actually put in a little bit of customization so that it's relevant towards what you are building, and a couple other things. You'll see that I have an API token over here. It will expire and I will delete it. So don't go and try and steal that. You can't even see the whole thing, but that's just how you get access to what's going on over here. And then inside the app function is where we're actually putting everything together, where you can see a lot of these different components over here that you can see very easily by the text provided within carrots, is where we're actually building everything. So we have the theme provider that is going to help theme everything correctly. And then we're able to put in all the different building blocks. So some things going on like the authentication by the comms provider over here. We can see the session definitions so that we're able to actually determine who the participants are. We're able to add in the join options so you can actually properly join, add in all the different buttons as components. So you're going to see those as UI as well, and then provide in just all the different things that you might typically see within a conference interface that you'll see over there. We'll go into them in a little bit more detail. I just want you to get a nice little look about how we built this all together. This is the verbose way. You can easily condense these into even more kind of helper functions for your functions themselves. But this demonstrates an example of what you might actually see being built instead of needing to actually do all the coding yourself. You'll see that I haven't touched any of the typical CSS or HTML within Create React App. It is exactly the same as you would expect from that going on over there. App.css, didn't touch any of that as well, just the app.js that we've gone over here. So if I go over to the window that we have over here in Chrome, you'll see that this is what happens when I just load the React app right here, where we have this join video call button over here. We can inspect the source so that we can view the console and see everything that's going on over here, where we are properly loaded into our SDK, and we can click the join video call button. This is then going to connect us over to our server, and it's going to put us directly inside of our instance over here, where we have the video, we have everything that we might expect. So we have our name, John Doe, we have a hang up button, we have a mute button, we have the video, the microphone, the camera, the speaker, everything going on over there, which we can kind of toggle and see work exactly how we might expect it would, where I can even open it up on another browser tab that I'm not going to show you right now. And we should be seeing the same thing. So we can click join video call, and we get some echo. But you can see I'm right there. Going to close that before it becomes too much more of a nuisance. But it's a working video app, and the only things that I've added are just, 50 lines of code directly within the Create React app. So pretty easy to even get started and can be easily reduced into multiple more. We haven't done that much more customization of the view and the CSS. We can make it look a lot better if we really want it to, but let's actually kind of dive a little bit deeper into what's actually happening directly within here. So what we're doing over here is we're naming a bunch of these things. So the username, John Doe, we can change. So my name is Griffin, so I'm going to change the username to Griffin. We can even do something like a prompt feed over here to have the user input their name, or add that as its own JavaScript component that we're going to add over there. The meeting name is something that you also would be able to change and then add in different participant names. So instead of participant info being hard-coded, you might want to actually implement the name as equal to username, so that you can actually make it the same as what you're directly inputting in there. We have different things like local text, so that you're going to be able to see you instead of seeing your own name, you'd see you because it'd be personal to you, as differentiating everyone over there, and then putting in other things like muting text, unmuting text, and everything just having a label so that it's very clear when people are looking at it what's actually going to be seen. When we actually go into the React components, you'll see that most of them are being passed in those variables that we defined earlier on, where we should be able to see the name change just by saving right now and going back to our screen, where after it recompiles, I should be able to refresh, rejoin, and see that my name has now been changed to Griffin, all dynamically, just via that code. So you can see that we did it via username. So if we look for username directly within our code, you'll see that it's just directly being inputted in. And that's all just from the join conference button framework that we have directly within our UI kit. And these are all defined the way that you want it to be. I didn't change any of the CSS, and it's looking how we want it to look. You can do a lot of different component changing all over the area. You can kind of mess with how things are looking in terms of, I personally don't like these being stacked together, so you would probably want to modify how the CSS looks in that area. I'd probably want to add in the background so that this text of my name doesn't look very hard to see in terms of everything going on over here. But at the end of the day, what we've done is we've connected to an NPM package over here in the UI kit, and we've just been able to use it directly with the React app, putting it all directly within this function return key, and it works as intended. I should be able to build this, upload it to a server, and be able to share it with all of you if I wanted to right now. That is all that really needs to be done in terms of that. So let's go back very quickly to the presentation, where let's talk a little bit about some of the advantages of being able to use the React UI kit that we have over here, where it makes the onboarding a lot easier. When building the same application with the traditional SDK, it still is going to take a lot of code. And that's even with the SDK, where you're not doing specific requests and you're not doing manual promises to load everything together. You're able to build it very, very quickly and a lot more dynamically without needing as much of kind of technical knowledge of knowing how to code. I should be able to hand this over to somebody and they should be able to kind of add components the way they might want to in whatever way they might kind of desire. So you can see an example of how we built this out just over at the NPM page that we have over here, where we have a little bit of an overview about what this actually is doing over here, where you can see this is all just using Node.js and some client tokens, as long as just installing our NPM package of what's going on over here. Pretty typical stuff you'd see in a typical React application, where we are setting this all up with the My app. We're setting it all up, and we are able to initialize everything and provide all the different providers that you want over here. So this is the initialization of the SDK, and we're putting in the content that we might want to see. But then we can do things like open sessions, display the participants, and add these all as dynamic and modular components that are all being placed in areas that you might want it to be. The keyword, I would say, being modular, where you're able to kind of cut and paste things to be exactly where you would want them to be, no more, no less, and being able to kind of let users have full control over how they want the application to look. Instead of telling them exactly how it should be, giving them the pieces, but letting them kind of decide what they want to do with it. And you can see there's different dynamic options for things like theming, if you want to let them have a little bit more control over that, and provide different things like screen sharing and areas like that all directly within the application, and however you kind of want it to be, as long as all the documentation you have. You can even see even more directly with the GitHub on how it is directly built. With all the same prerequisites set up and all that directly on over there. This is going to be pretty typical of most React UI kits that you see these days, where you're going to have a lot of developers encourage people to kind of get creative and build their own things. If you go back over to the advantages, we can see that part of kind of the reason why we built this and why we'd expect other people that would want to build a React UI kit themselves as well is things like easier onboarding, where you're going to be able to give people a pretty easy way to start coding with your platform. You have less of confusion about making sure that they're using the SDK or your APIs in the exact way that you expect them to. It's a little bit more streamlined. If they know React, they're most likely going to be able to use a React kit, assuming that you have well documented the different parameters that you're putting directly in your components. You're going to have more beautiful hello worlds. So instead of the classic, not so pretty HTML-based components that we typically see from most hello worlds, you're going to be able to let them actually feel like they're going to be in your brand and a part of your design philosophy by giving this as the option for people to actually use. And it also is going to be able to abstract some of your more confusing backends. If you don't have the cleanest way of integrating a bunch of things together, or if there are going to be multiple different API calls that you're expecting people to need to make one step or one big progress happen, you can kind of put those all together into one component so that you don't have to have people write the same thing over and over and over again. You're able to kind of abstract those and put those together if that's kind of the best practice in the first place. which then encourages the intended workflows from happening altogether in the first place. So just, again, encouraging people to behave the way that you would want them to behave. Some disadvantages are going to be, well, the obvious ones, where you're locking them into specific frameworks. React likely is going to last for a very, very long time, but this only works on React right now. If they want to use Vue or something else, that's not going to be the exact target audience. So I would hope that when you are building out a React UI kit, you already have an existing very enthusiastic React audience of developers, customers, third-party kind of contributors in your open source projects already, so that you're not building something that isn't relevant towards the existing community that you already have, which then would also provide issues like technical debt, because you have to maintain it and support it, especially when new versions or when vulnerabilities come out. This is another thing you need to add to your list of things that you need to make sure stay up to date. Otherwise, if people are coming over to this, using it, and it doesn't work, which they're trying to use this as an easier way to get started in the first place, that's not going to be the best user experience people are going to have in the first place. People expect you to keep things like this maintained and up to date and working with the newest version of your API that you have. So making sure that is all kind of brought together and supported, and also even with things like design philosophy, up to date in those areas is extremely important. There is also kind of the controversial issue of pigeonholing creativity. This one is a little bit more of an if, but because you're providing the same design philosophy across all the different things, it's kind of indirectly discouraging people from getting as creative as they might necessarily want to be. They always do have the option of ignoring the UI kit in the first place and just being as creative as they want. But if this is the main thing you're directing people to for, say, your getting started guide or your hello world, that might discourage people from going outside of this philosophy. So while it is an advantage, and a lot of times in creating design unity, it will not necessarily be the best thing to encourage every user to do. And then you also need technical designers. You want to make sure that your CSS and HTML looks good. So you want to make sure that your designers are actually technical and know how to build something like this all together in the first place, where you don't want it to look ugly. Like, part of the whole point of having a UI kit is that it looks pretty and attractive for anybody who's using it in the first place, and encouraging them to actually want to use it. So let's talk a little bit about building your own, where there are a few different tools that I recommend that you use to start building your own. So the first thing is going to be TypeScript. TypeScript is just great for a lot of different reasons. What I showed off today was pure JavaScript, that we do have examples in TypeScript as well. And one of the big advantages that I want to specifically point out for this, among the many that already exist, is that types make it so it's very easy to add auto-completion of properties and values. If it's not kind of a native thing that's brought directly through your package, TypeScript makes it a lot easier, where you're going to enable people to actually know what they're supposed to be completing in, know what the actual modules are expecting, provide help functions, especially with the integration built directly into VS Code. It just makes the development experience a lot better. So instead of needing to go between your documentation and the actual IDE, you're able to let people stay coding and building with it as long as possible, keeping the attention in, and just making the whole build experience a lot better. TypeScript builds directly into JavaScript. It should be pretty easy for your team to get started building directly with it. Highly recommend it. The second thing is going to be an application called Storybook.js, which allows you to create reusable components in isolation. If we go over to the website, you're going to see it's all about building UIs without the grunt work, is their little theme that we have going on over here. It is essentially an NPM component that's going to allow you to build these different UI components in isolation from each other, so that you're not having to kind of mess with different dependencies, different development environments, different kind of things colliding and clashing with each other in terms of actually building it. It is built for UI development. So that works perfectly with a UI kit. So you can see in the little example over here, they're able to actually determine things like the labels of the text over there, where you're putting the images, how it's all going to look independently with itself. So that's going to look the same on every machine, on every build. It's going to be consistent which we know is very important for the UI kit to actually establish the brand directly in there, and it's made directly for it. It's built for this purpose. Some of the best teams use it. It is a very good technology. I highly recommend checking it out. And finally, styled components is another tool that allows you to use theming instead of bare HTML to kind of build it all together. Again, making it a lot more of a streamlined process. So it uses ES6 and CSS to style your apps, where you can kind of see, again, some more examples of making the styling consistent. Instead of needing to kind of hand build every single component yourself, it allows you to kind of create a little bit more stylization, again, installed directly via NPM. It allows you to actually, so you can see over here in this quick start, import it directly and then make it a styled direct button that is a React component that you can style just like you would in React. It's built for this purpose, and it's built for you to kind of create this whole thing the way that you would expect it to be. This is here to make consistency key. It's here to make the building process as easy as possible, and it's here because, I mean, people in the industry are actually using it to build their UI components. This is kind of the main kind of stack that you're going to expect a lot of people to build and work together with. There are other important things that I would appreciate if you put directly into your own UI kits as well, such as linters, so that your code looks neat, well commented, consistent, and expected, so that if people do run into any issues or want to contribute and add it directly to your code, they understand it. I can't overstress how important that is to me, at least as a developer, to make sure that is a part of the actual implementation that you have. And just working together, getting feedback, making sure that you have public forums for people to let you know what works, what doesn't work, what features they want, what features they want removed, improvements, and you might get some pretty good feedback from there. So as some conclusions, as we get towards the end, I have been having a lot of fun with React UI components and building these different video applications, but overall, I think there's a big benefit towards the React development community in helping introduce more developers to your platform, helping simplify React code, defining brand identity, making it easier to start building. I think if we are all working together to kind of try to make the development process as easy and streamlined as possible, it's going to enable a lot more people to start building and kind of generating their own content themselves, and letting people kind of stop getting a little bit rogue in terms of making their own standards for what things are going to look like, and making things a little bit more consistent, not only within your own company, your own platform, your own application, but as a React community as a whole. So thank you so much for attending and listening to my talk. I had a lot of fun, and I will catch all of you live in the Q&A in a little bit. Thank you so much.
Wow, that was really cool. I was sitting there thinking about, that would be something really cool to build for my work. But anyway, we'll talk about that later. We'll have him back, like he said, in the QAA session. But right now, I have Hemanth. How's it going, man? How you doing?
Hi, Mike. Thanks for having me. Going good. How about you?
Oh, I'm doing good. I'm sitting there finding the wind here. It's really windy here in Southern California. So if you hear like a hurricane in the back, just ignore it, okay? Hey, man. So tell me, what do you have for us today? What are you going to talk about?
I'm going to talk about web performance and how it's more important than you think. So folks underestimate that.
Yeah, you know what? I was reading your topic and I was like, yeah, that's kind of important. So I think you got a really good topic. So I'll tell you what I'm going to do. I'm going to go pull myself away. I'm going to bring in your presentation and I will talk to you later. Have a great talk there. Oop, that was me. Sorry. Oh.
All right. Thanks to the team at Geekle and Anna for having me here. Hey, guys. My name is Hemanth Udupi. I work for Adobe. I'm a senior software engineer. Also, I represent Adobe at the Web Performance Working Group at the World Wide Web Consortium. Also, I am a senior member at the IEEE organization. So we're going to talk about the very important topic. Web performance is more important than you think. So let's get started. So looking at this talk, I'm going to be talking about a couple of things. So let's look at what we're going to experience today. I'll come forward with some prerequisites, which I expect you guys to know, right? And what is web performance, why it is important, how a network request works, some things about the performance API and tools, some tips on how to improve web performance, best practices, and how do you attack the problem, and some sneak peek at upcoming web standards at the W3C. Well, here are some prerequisites which would help understand this talk better. One is HTML, CSS, JavaScript. You have tried building a React application, which would be great. And basic understanding of the document object model, the browser DOM. And if you have done these, you would probably have used the Chrome DevTools. All right, so what is web performance? Web performance refers to the speed at which the web pages are downloaded and displayed on the user's browser. It's all about making the websites fast or making them seem fast, so the user do not wait long to start using your application. So why is it important? Have you ever grown impatient waiting for a page to load? You know, you have a busy day, like, oh, why does this page take so long, right, forever? Well, you're right, because usually we comprehend anything greater than 2.5 seconds as slow in this modern age of high-speed internet and fast machines. So this is a good example of the spectrum of what your application loading is good or bad, right? If it is within 2.5 seconds, it's good. Anything greater than 4 is poor and needs improvement. Now, to understand web performance, let's understand the mechanics of how things work on the browser side, right? And which is an HTTP network request. So folks familiar with this would easily recognize this diagram, but for guys who do not, right, this is the client and server model. So we have a lot of clients like a cell phone, laptop, computers, etc., right, which communicate over the internet to a server, which responds with the web page, right? So there is something called DNS, domain name service, which resolves the IP address of the server. So your device communicates with the DNS server, and then once it gets the IP address, it establishes a TCP/IP connection to the server, and it does the handshake, TCP/IP handshake, and then returns the data for you. So in the Chrome DevTools, you would have observed this when you inspect any network call, right? So this is the life and timings of a network request. You would see something as queuing, stall, DNS lookup, SSL, waiting, content download, etc. We'll understand more on what these are, but you might have been familiar with all of these. And let's look at it a little bit more in detail. This is a timeline of a network call, right? There are a lot of stuff here. You don't need to remember all of this. The thing we would care about is fetch start and response end. That is the time taken from when you started making the network call and you received the response from the server, right? And then there is the DOM content loaded and processing, which is not in our control, which is what the browser is doing to digest the data received from the server. So what is web performance? The API, right? So all these data is available graphically, visually, right? And you cannot go click on every network call to figure out the web performance of your application, or even in production, which we'll come to later, right? So we have a performance API, which is available through window.performance. It is a read-only attribute which gathers all this data. How exciting. So looking at the performance timeline API, it's the extension of the performance API, right? It has some 3 main methods, which is get entries by name, entries by type. So we'll look a little bit more into what each method does. But this is basically when as soon as you loaded your website, right, and the browser loaded everything, and at any point of time you make this call, it returns all the entries the browser has captured so far. So what are the benefits of using this performance API? So they augment the experience, what we see visually in the profiling dev tools, right, or the network tab in the Chrome dev tools. There are other tools which utilize this, and like during the CI continuous integration checks, like the Lighthouse, right? It also captures these metrics, right? And there are real user measurement in production, which will come to in the future slides. Is right now you measure during the development time, but what do you do when your product is out there, right? When your application is out there, how do you know if the users are seeing the same good performance you see on your high-speed internet and fast machines? Not everybody has the luxury of it, right? And then we get precise timestamps for all the network calls. So here's a look at some browser compatibility. Most of the major browsers are supported. There are different methods. This is available through MDN docs. And we have some important definitions. So on the left, you see when you do in your devs console, right, window.performance, you would see a list object, a read-only API returns this object, which has all this amazing data. So some important ones to keep in mind are navigation timing. This is basically the time reported for the page from the time you hit go to the time it starts loading. So that is the time it took to navigate from 0 to a new page, or from previous page to a new page. And there's the paint timing. So painting is the activity in a browser which involves anything drawing, basically pixel. Any pixel drawing, anything it starts rendering for the browser rendering engine, that's called painting. So there are different metrics. One of the first is the first paint. So that means the browser was able to paint the first pixel on the page. So that is the time it took to paint. And first contentful means, pixel might not be useful, right? What is the user going to do with one pixel, right? So when you have something meaningful to show, the first bit, which is like a text or image or a canvas render, the time taken to show that is the first contentful paint, and both are already available, as you can see in the left. And there's a resource timing. This is basically any resources like the CSS or the JS files, or any network calls you made, which is HTTP requests, which we'll see, right? You can measure those. And also the memory of your application, the heap size limit, how much is available, the total heap size, right? And then the heap size used, so you can know the percentage of memory consumption by your application in the document. And then let's deep dive into this, right? When you do window.performance.get entries for a web page, you will see something like this. You'll see a lot of entries, right? You don't need to go through the details now. We'll look at it one at a time. So here, this is all the entries you would see. So the first thing we are going to talk about is navigation timing, right? In this image, you can see, right, the performance navigation timing I've expanded with all the 34 elements in the array, right? So there are different timings over here, durations, start, finish, etc., right? So you can use these data to understand the page navigation timing, whatever data you feel is valuable to use here, right? But mostly we do not have control over this, because it depends on how long the user's network communicates with the DNS server and time it takes the browser, right? This is just a reference for you. This is something we can work with, right? So the paint timing, it's a time taken to paint something on the web page. So if you expand performance paint timing, you will see first paint and contentful paint. So like I mentioned, first paint is first pixel on the page. First contentful paint is the first content painted on the DOM, which could be a text, image, or a canvas render. Now come to the more interesting stuff, which is performance resource timing, right? So there are different resources a browser would load. It's not just about network calls, right, or images. It could be even the bundled JavaScript files or the CSS. So this captures all the resources we are trying to load, and you can filter by type. So let's look at this, right? Something we would be interested in. We make a lot of network calls in our single page application, right, to fetch dynamic data, do some rendering as such. So you need to look at this particular one, which is XML HTTP request. And the more important things what you have is the fetch start and response end. So like I mentioned, fetch start is the time when your application, the browser starts in the network call, right, asking the server for data. And then response end is the time the browser received it. So if you look at this API, right, for this particular endpoint, you can see name value. We had the fetch start at 416 milliseconds and response end at 536 milliseconds. And the the yellow arrow, which is pointing the duration, is the difference of this, which is 119 milliseconds. So you can do this with, like timers, say start timer, stop timer in your code, and report this data. But it will not be the accurate decimal point measurement of what the user is experiencing. And there are certain things the browser does, like processing of JavaScript. JavaScript is single threaded, it keeps going, doing its thing. It may not be accurate, right? If you're really interested in fine-tuning your performance, why would you want to add overhead, more work for JavaScript when the browser is already telling you this data? So you would just report this duration field. All right, looking a little bit deeper into this. So this is a network request, right? So in the network tab, you might be familiar with this, like we saw earlier. So this is one of the network call this particular website is making. So like I mentioned earlier, there's this queuing. So browser queues the network calls, and I think there's a certain limit. The browser can make network calls in parallel, so they need to queue it. And stalling is basically any time it took to send the request, and the request was sent. It took 0.24 milliseconds to send the request, and the browser waited for our server response for 38 milliseconds, right? So it just waited, right? And then the content download took about 55 milliseconds. Well, the content download is the thing which the browser does, which we do not have control over, but we do have measurement of that as well. And you see in the yellow box, which is 40.53 milliseconds, that is the total time taken for the network call from request to response and the browser processing it. Looking at the right side, we can do the same using the web performance API. Right, you do web performance, the window.performance get entries by name, and you put the endpoint you're interested in, right? The endpoint name. There you see duration, which is 40 point some milliseconds, right? Well, it doesn't match 40.53. You know why? Because it doesn't include the content download. That is not part of the network response. So all we care about is fetch start to response end, which is in our control, and we report this duration. We can do more fun stuff with this API. So we have, let's say we can filter by type, resources, and we say filter by name, XML HTTP request. We get all the requests made by your web application, right? The network calls. On the left image, you see there were 5 elements in the array, right? And that means there were 5 network calls made by this website. Now I'm interested in the network calls which took greater than 100 milliseconds, right? You can change this number. Instead of going through each network call and seeing, oh, which one took longest, right? And visually doing it, you want to do it programmatically, which takes like fraction of a second. You just say item duration greater than 100, like as such, and it would filter and return the array of network calls which took greater than 100. So you can see this took 122 milliseconds duration, and it returned 1 element in this array. So that was the outlier there. Well, so now we have web performance tools. How can you measure it? right? There are different tools you can measure visually versus programmatically. There are these dev tools. There's React DOM dev tools, which are available in a Chrome browser extension, Firefox, and even through a Node package. So most folks would have used this. There are dev profiling tools. And there's the packaged with the Chrome browser, the Chrome dev tools. There's the performance tab, where you can, once a web page is loaded, you can refresh and just start. It'll start the profiling and complete and generate a report for you. One thing, pro tip is reduce the CPU to 4x slowdown, right? Why is because we usually develop with fast machines, right? Fast computers and good internet. But when your product is out there, people use it on mobile devices, tablets, or computers, which may not be fast, and different types of devices. So a good practice is doing 4 times lesser, slowing the CPU so that your web page takes intentionally longer time to load and your spectrum is larger. If it is like 0.1 milliseconds, it's hard for you to analyze. It's maybe like 200 milliseconds, maybe you have a wider spectrum to analyze. And this is how a spectrum would look once you are done. So now you get my point on why bigger is better, right? So if you expand the user timing, you see there are different things which happen in this waterfall model. And what we are interested in is this, the pulse, right? So here you can see in this view, there are different methods which are used over here, and you can pick one of them. And over there in the dev tools, you can see each line of code and how long it took. So going to the level of detail in our code, how much our code is taking and where you can optimize. Maybe there's a lot of data to process there. Maybe you should use a different method, right? Or instead of map, maybe filter or something else, right? Or you have your own for loop. Maybe that is not efficient. Map would be better. As such, you know which is the long pole, and it would help you discover your slow functions. Now, how to improve web performance? Well, this is a general overview, right? It's not specific to your browser. So it's common sense, reducing your overall load time, right? It could be server side, client side. One more trick is to make the site usable as soon as possible, and through lazy loading, in the background, you can start loading stuff, but make something the user can start using right away. Having some good transitions, smoothness, interactivity would be helpful. And this helps improve the perceived performance. Even though your web page, you can, up to a certain extent, improve your performance, but some things are out of your control, right? You'll hit your limit. You can improve the perceived performance through these techniques. And of course, performance measurements, right? Through Web Performance API, you can understand your application better on your development environment and in production, what your customers face. Now let's look at some best practices. React is awesome. It already has some several clever techniques to minimize the number of costly DOM operations through virtual DOM, right? It figures out which DOM it needs to mutate, basically on data change. But there are still ways to fasten your React application. Let's look at them, right? These are something you would do for bundling. Use an optimized library instead of building your own, right? Maybe there's some kind of operation you would like to do, and you write your own method with for loops and while loops and stuff, which may not be the best optimized way to do, but there's already a library which does that, and they're already highly optimized and used in the industry widely, right? It could help, Google it, find it on npm.js, and you just try to use that. But one more thing to keep in mind is there are libraries which are out there. Let's say there's one method you want to use, and there are like 1,000 methods in that library which you don't need, which will increase your bundle size. So it would make sense to just take that and put it in your util file and utilize it. They already have an optimized method for it. But if you need more than that, you feel it's more valuable to have the library because you have in other places you plan to use. Make it as a shared node module in your local, or just use that optimized library, which is publicly available. Bundle only what you need. Also, while you're doing Webpack, right, and you're giving the payload to the browser. If the payload size is big, right, huge, that time you would want to split it into multiple chunk files so that the network calls are quicker, right? The first network call takes the longest because the browser needs to understand which server it needs to talk to, so the DNS resolution takes longer. But the subsequent network calls are relatively faster because the browser caches, right? It already knows this is the IP address for the server, and there's a time it remembers that information before it tries to refresh. So you're good that way, and not maybe 100 files, maybe like a couple of them, like 2 or 3, depending on your bundle size. Maybe just one will do just fine if it is a pretty low file size, right? And also using production mode flag in Webpack when you are creating your bundle output. Some folks forget it, but if you don't, you're doing great. Then there is a React Pure component, right? So when you're writing your code, looking at a little bit deeper in the code, so you want to use Pure component instead of React just component, right? This would avoid re-rendering when prop states are not changed. So this does a shallow comparison of the data. If you want a deep comparison, you would not want to use Pure component. So it also is good to use when your state and props are immutable. That means they do not change state. Then like if you're the class-based way, if you're writing code, right, you would have probably used should component update lifecycle method. If you have special conditions like controlling when your component should update, then you should not use this because there's already an optimized way of doing it. If you're overriding it, then pure component doesn't make sense for you. Right. Also, there's a common mistake folks do is while using index as a key for the map, right? When you're trying to render a list or certain things in a carousel, maybe you would say, hey, do this in for loop, and I'll give the index as the key, which may not be a good idea. You might want to use something unique in the data. So when that data changes, that value changes, and the key will change, and React will know which node to re-render. Some folks use UUID, so that means every time the page is rendered or something changes, it generates a new ID, and that forces React to keep rendering again and again, even though there's no value change, right? Just the key changes. So that is not a great way of doing this, going against the React optimizing what it's already supposed to do. So that's one thing to keep in mind. And also React fragments. So folks, you might have observed React complaints, right? You say you have H1 paragraph, and it says, oh, you can't just return it. You need to wrap it in a div. So folks keep just wrapping it in a div. Then div does nothing. It doesn't have a class. It doesn't have any CS associated with it. No ID. It's just a div wrapper, which adds extra elements on the DOM. So why would you want to do that? So React provides something called React fragment, or just 2 angular brackets is a short form of it. When you do this, React knows that it's just a section you're trying to load, and it doesn't need an wrapper. Now, looking at some delivery methods on how your package you would want to deliver to your clients, that's the browser. Right, there's something called a CDN, Content Delivery Network. So these are basically servers around the world. There are CDN providers, right? There are so many, and you can upload your bundle.js, right, and your CSS, HTML files over there. When your web page loads, instead of a server responding, the CDN will respond the data, and it is faster. And there's also caching happening over there. There are different other caching techniques. Will not go deep into it. So they will handle all the network latency issues for you. So, and also there's something called as web workers for CPU extensive tasks. And JavaScript is single threaded, like I mentioned. So it's good if you can parallelly compute. So you can try pseudo parallelism. That means try to mimic it through set timeout function. Basically, you're delaying the operation you want to do. Or you can use web workers. So web workers is something, a script running on the background thread. Is not the main execution thread. So you should not put stuff which the UI needs. This is just some calculation or some computation you need to do in the background, which does not affect necessarily the UI. And when you do this, this doesn't affect the page performance. Also, one more thing you can consider for SEO, that is search engine optimization, is server-side rendering. So that means the page is already rendered on the server side, and the payload is given to the browser. So it is faster for a pre-digested payload to be rendered on the browser side than the browser doing everything, right? Because like I said, some people can have slow machines. And also this is good for SEO because there are web crawlers like Google and other search engines use. They go to your website and crawl, they try to load it. If it's already pre-loaded, right, to some extent, and so the web crawlers are able to get all the information from your website better, and your ranking, search engine ranking, will improve, and it'll start showing up maybe in Google better, right? So this is something you could use. Last but not least is gzip compression. Here, this is a compression technique which works well with JavaScript, CSS, and HTML because there's a lot of repeated text and white space. So it can improve up to 70% of your bundle size, right? And the browsers natively support when you do through CDN, you do gzip, and the browser will automatically decompress and display the page. And this is an illustration of how that works. Well, now we learned a lot of things, right? So now how would you start? Now, okay, Hemanth, I know all these things. Now, how do I start? So these are the 3 things I would do. First is everybody's application is unique. It's not a one solution for all. These are just tools at your disposal for you to figure out and analyze your application. So first step is take a step back, measure, analyze your web page or application. Then you identify the areas that need performance and improvements, right? It doesn't make sense to optimize areas which are already fast or don't need optimization. Identify the long pole and then work on them, right? And the last step is to take necessary measures to improve web performance, like I already mentioned, and always try to have using the web performance API to capture in your logs in production so that it helps debugging in the future. Well, exciting stuff. So these are some upcoming web standards, right? Like we saw first paint, first contentful paint. Now we have largest contentful paint, which is almost ready to be published, right? We're almost there. So looking at this, it's a user-centric metric for perceived load speed, right? So this is perceived. It's not what we display. We already have a measurement for it. It's what the user perceives, and we have certain elements for that, right? So this is a new user-centric metric, which is called first contentful paint. It captures the very first beginning of the loading experience. The older metrics also work, but they're not as good, like load or DOM component loaded. Sometimes simple is better. This reports the render time of the largest image or the text visible within the viewport. And this is the way you calculate, like I said initially, right? 2.5 to 4 is the range which start needing improvement. So within 2.5 is good. This measures that score where you can use in your application. And good threshold is to measure 75 percentile of your page loads across the users, which will give you a good estimate. And these are the elements it considers for evaluating image, video, background image, like CSS gradient, and it also includes block level components through children. So there are different tools you can use in development, Chrome DevTools, Lighthouse, which can use this. The field tools like page speed, Insight, Search Console, there are so many, Chrome User Experience Report, or you could do it yourself through using the largest contentful paint API, which is exposed through the performance API. How to improve your slow server response times, work with your server team, or if you build your server yourself. Also rendering block of JavaScript and CSS, reduce the resource load times, the network latency through CDN and such. And instead of client-side rendering, you could use server-side rendering or improve client-side rendering through measurements. So this is not perfect. It is also still error-prone, but it works for most of the cases. Algorithm stops when users does some kind of input, mouse or keyboard input. Let's say it stops capturing the time before something started loading. The user starts clicking. The measurement could not be accurate. And there are splash screens like placeholders, especially for image carousels. Those could also skew the metrics here. This is the interface we would use. This is available through the links I've given below, right? It is published already. So have a look at it. And now we are ready to build a performant web application in using React. So hope you found it useful, and thank you all. And you can please connect with me on LinkedIn. So thank you, folks at Geekle.
Wow, that was really awesome, Hemanth. Let me go ahead and pull off this, and I'm gonna bring in Griffin. Hey guys, how's it going? Are you guys ready for a QA session?
Yeah, sounds great. Thank you so much.
Awesome, man. I tell you what, both of you guys, it was so super awesome, your presentations. And as it was going on, I saw some questions popping up, right? And okay, this one always comes up. Okay, so React is super awesome. It's got all the bells and whistles, you know, it can do everything, but then it always comes down to one thing, right? How would I convince management to move to React? Any tips on how to convince them?
You want to start, Griffin, or should I go ahead?
Yeah, you guys, that's right, open forums. Does any of you guys start? And let's just drop right in, you know? So
yeah, so I mean, it really depends. I mean, I think the biggest thing is, of course, technical debt. How much, like, would it actually take you the migration to React in the first place? Where I think kind of your action you can do there is you can actually kind of do a little bit of an analysis and determine what the actual migration would look like, how many resources, what the timeline would look like, because that is going to be one of the big indicators. People don't want to lose money spending time migrating things. People want to spend time building new things. Even determining if it's worth switching in the first place. Like, you might be using an equivalent framework that just does everything that you need. So it might not even be worth switching in the first place. I know this is a React conference, so I should be React the whole time. But I think kind of the big things are kind of the smaller scale it is, and the more you're able to kind of show successes. So if you're able to do some sample applications or some kind of side projects built on React and kind of showcasing how kind of well that worked out and how you were able to build that out, I think those are going to be some of the better ways that you can kind of demonstrate proof of concept.
I think that's awesome. In other words, like in incremental steps, right? We might build a small little project and then work our way up to, I don't know, convince our management. Hemanth, do you have anything you want to add to that, or?
No, thanks, Mike. Just want to add to that. I agree with what Griffin said. Yeah, it would make a good comparison whenever you're starting a project or current project. Identify why do you want to move, right? There must be some reason why you feel it's not working for you. Try to compare current versus React. Make a small application. Try to compare. And also a good idea to pitch is the React community, right? There's a lot of things available. You have a community which has already figured out a lot of things, and you have a solution there for you. There are always a lot of tools and optimization techniques as such. But I agree, there's no one solution for all, but most of us, React has been useful.
Right. And you know what? Speaking of performance, what about this one here, Hemanth? This is for you. I use DevTools to test app performance. Wondering if there are any others worth checking out. So is there anything else out there that you know of that this person could look at?
Yeah, there are a lot of commercial products out there. But it's not a free one, I would say, right? You need to buy a subscription for that. Maybe there's like PageSpeed, which kind of goes through iterations of your web page over periods of time and generates a report for you. And of course, there are some open source or like ones which Google has provided, for Chrome. Chrome has been really great, and I think most of us developers prefer Chrome over others for development. There is Lighthouse, and like I mentioned in my slides, there were some other tools. It's not on top of my head right now. But if you want to build something of your own, right, you want to have logs in production, I think the Web Performance API is the way to go, right? You have customization, which allows you to do whatever you want. You can build whatever you want, even through dashboards, through that data. But there are most tools which help you only till development, but there are tools in production like PageSpeed. I might be getting the name wrong, but there is a company which does that. So there are different commercial tools, but if cost is a thing you want to avoid, you can do it yourself through these APIs.
Yeah, that's really interesting. Griffin, do you have anything to add to that about any tools that you can come to mind or anything?
Not really.
Oh, that's okay. I don't mean to put you on the spot, bro. I'm just you dropping in. This is the open forum for all three of us to kind of, just come together and collaborate. I'll tell you what, this is something that I found really interesting when this was dropped. Can you list some security features that can help in design reviews? In other words, if I'm trying to pitch this to my management's a little theme here, right? What can I say to them about, because they're going to go, is it secure? So can you guys just kind of come up with some tips that can help us out there?
I mean, I think, again, I think about it in comparison towards other things. If you're using older, outdated technologies that haven't received updates in a long time, or you don't have proper maintainers and you haven't been able to update to the latest versions, of course, those aren't going to be as secure as if you are able to migrate over to newer technologies and you're keeping those more up to date with any vulnerability patches put directly on there. A lot of kind of more traditional security features are going to be ones that you're going to be able to need to add yourself, no matter what platform you're using. But again, the more modern the technology, the more kind of modular it tends to be, and making it more streamlined to add those new technologies rather than having to build them directly yourself.
Yeah, that's really well put. This is about Lighthouse, I think, for you, Hemanth. Is Lighthouse a great choice to measure website performance?
Well, I'm not sure if I can give an absolute answer to that, but many companies do use that. I've been to Google Chrome Summit, Dev Summit, and of course, Google would pitch for that. Many companies do use that, right? And it is a good choice to have. But again, there's no one solution for all. Depending on your product, you would want to see there are different alternatives out there. But if you don't know where to start, it's a good one to start with.
I really like that, because I think that you got to kind of start off with the foundation, right? And then from there, that's where you can start to really expand on your research. This one's really interesting too, and this is, I guess, for both of you guys. Because I remember one of you mentioned, what is the best approach to set up performance testing for each environment test system in production? Because we're dealing with different environments here, and I know there's different variances to this.
Yeah, sure. I can start with this one. So yes, usually we have a dev environment, stage environment, and a production environment. And there are different ways of performance testing, right? Like I said, there are products like PageSpeed and stuff which measure. You would not want to measure on stage, right? You would be wasting companies' money on it. You would want to measure on production. But if you have budget, good to see stage, because you know how things are progressing before you get your code onto production. So if let's say the team checks in some kind of code, which is probably worsen the performance over time, and even the CI checks, so let's say Lighthouse didn't catch it at that point, right? You would know in the real browser rendering something went wrong real bad. So we do not want to push it to production. So it is valuable to have on stage and production. And of course, there are ways to add logs.
Right.
So in my talk, I had three environments, basically two environments, right? So development and production. There are different tools for each section. But the web APIs, which the browser already has, right, it's easily available for free. It works on both development and production. So this is my take on it.
Well, that's awesome. That's great. You want to add anything to that, Griffin?
No, I'll just defer over to that. I don't focus much on performance testing as I focus on just getting it built.
Yeah, right. Just pass the baton on. I get it. That's no problem. Okay, so yeah, one of you mentioned this too. What is the best approach to support React apps? And then here come the updates. Because I'm thinking about, we build this amazing product and then we're ready to hand it off, right, for our IT department to maintain. So what can I tell them if I'm trying to convince them to use React?
Well, I would start off by saying, typically, if you build it, you're kind of signing up to help maintain it.
Okay.
I'm not a fan of you building something and handing it off and going on to the next thing. I'm a believer in DevOps and kind of saying you're building it and you're helping maintain it in the same time. So kind of keeping an eye out. If you do need to hand it off, like, give them ample documentation, not only on what you built and kind of keeping things like you need to proper README, comment the code properly, make sure that it's just very obvious, but then also providing the resources that you use to build it. What documentation the React apps to be used to kind of build. What are the typical things that you might need to continuously update, like your NPM packages and areas like that. Just making sure that it's foolproof, because I think we have a tendency as developers to kind of assume that people understand where we're coming from, where then you look at somebody else's code and you're like, what is this? I don't understand any of this. So put yourself in the hands of the developer who is taking the code and going, what is this?
Oh my gosh, you know what? When you said that, okay, I have to add this in here. I saw this thing on LinkedIn. I just got to throw it in there. And it was like a video that someone put in there, and it shows NPM update. And it's got a whole bunch of these ducks that are come running out of this little hole, and they're flying out and flooding like a million of them. And that's kind of how it is, right? Sometimes you NP update and you don't know what it is. Go, I can see that on this. Anyway, okay. That was my crazy little joke. Anyway, okay, so let's get back to this. What is the best way to override styles, themes of UI kits? I think override CSS within it. What is it? Not important. It's not the GRUD approach.
So the exclamation point important. It's
not. I saw the
not. So usually, like most of the UI kits that I've been able to experiment with, either are going to be open to it or not open to it. So for example, the ones that are built, for example, like in Salesforce wants you to stick with their CSS theme. That's kind of the point. Salesforce is trying to keep everything pretty standard in terms of how it looks compared to some of the other ones, where the other ones are going to kind of provide a little bit more options in terms of letting you theme it yourself, kind of built into the platform, where the CSS is a little bit more easily customizable. Yeah, the important isn't a great approach. It's definitely very, very hacky. And this seems like a little bit of a cop-out answer, but like checking the documentation usually is going to be the first place to determine that, because again, some UI kits are going to be a little bit more accepting of you trying to change the styles over others. But like, I think for the most part, taking a look at what the CSS actually looks like and seeing if any of them actually make sense to you, and just mainly editing those yourselves instead of kind of putting in important overrides for that, I think is going to be the way that I would tell you to do it.
That's awesome. Hemanth, I think this one was for you. React and virtual DOM isn't performance killer? ? WASM could be better choose. Does React make too much work at loading?
Yeah, there's been definitely discussions on this, right?
Yeah.
But in general, for most of us, right, React, well, the more complicated your application goes, you would want to think of other alternatives or optimization techniques for a beginner to start with, right? When you're building your React application, React does a great job in understanding what it needs to render, and virtual DOM understands how it needs to re-render and which nodes to re-render. Basically, if you look at how the browser works, let's say anything in the parent node, something changes, it re-renders all the children. So virtual DOM is something special which identifies the nodes and renders only the nodes and the subsequent children which need to re-render. So avoiding the re-rendering operation, making it seem faster. Well, that's my take on it. I'm not sure, maybe some folks will not agree.
Well, you know what? That's really interesting you say that, because I think that there may be different ways of, taking this approach, but obviously it works for you, right? And so, hey, it's very successful. So I think that was really awesome what you said. Do you want to add to that there, Griffin? Anything you want to add?
No.
I am going to do this one time. I'm going to get it, bro. I'm going to get it to where I pass it on to you and you're like, bam, what's great. No, but this is fun. I'm really enjoying this, guys, really. Okay, speaking of browsers, all right, what is the best way? Because I've seen this in my job before. Your company comes with requirements at you and they have this browser, this browser, this browser you have to test, right? So what is the best way and best approach to test performance on the required browsers, especially since we use more than one browser? What's the best way to do it? please.
Yeah, so yes, there are definitely different browsers in the market. We probably have a personal affinity to Chrome as developers, but our users may not, right? Even though I think Chrome, I read somewhere it says 60% of the market share, but there is the rest 40%, right? We need to cater for all the 100%. So identify who your customers are, through browser user agent. You can capture it through your logs, understand who your targeting audience is, right? Pick the top browsers you support, right? If it's IE, I'm sorry for you, but if it is other browsers, right? Like Chrome, Firefox, Safari, there's Edge, which also uses the Chromium project now, right? And you understand who your targeted customers are, and fix on them. First, gather the data through your logs and understand through user agent data, and add these web performance, using these web performance APIs, understand how long it took to load. And then you would want to say, these are the top 5 browsers I would seriously test on. The rest of them come under the other segment. I have maybe less than 2% users. You would not want to spend time for those 2% users versus the other 80%, right? And then you would focus on your testing. And like I said, the web performance API is supported on all the major browsers. So anything performance metrics you capture, it will capture, and the browser will report to you, and you can use it in your logs. And every browser is different. It has different internal workings. So there could be different load times, and that could even help you understand. And some browsers work on different platforms, right? It could be Mac, Windows, and Linux. So those could be factors as well. And all this metadata is readily available for you in the browser. And I'm sure there are many companies who have products they can sell you for a subscription to analyze this for you. Or you can use the APIs which W3C has already specified, right? And do it yourself. So it's again, you pay off your problems, or you solve it yourself.
That's awesome, Griffin.
I do have an opinion on this one, actually. No, so just kind of basically the same thing. Just kind of picking back onto the end of it, there are companies that can pay for it. So synthetic tests are the keyword that I would actually make sure that you take a look at. I used to work for Datadog, which is why this is relevant to me, where they do automate a lot of those testing directly for it. So they have options for Chrome, Firefox, and then iOS, Android, Mac, PC, all of that. You are absolutely able to do it yourself, though there are a lot of different products out there, not just Datadog. That's just the one that comes top of the head because I used it, that you can use for all of that.
That's awesome. That's awesome. And thanks for that extra input there, or insight. Hey, I think both of you will answer this one. I mean, people out there are really curious. I mean, you guys have really amazing careers and where you are. And because this is junior track, there's a lot of junior developers here, right? And I'm sure they want to hear your story, man. So just tell us about how you arrived at this point in your career. A lot of people are curious to know this.
Griffin, why don't you go ahead?
Sure. So I had a pretty traditional tech career where I have a computer science degree as my bachelor's, and just kind of went through less of a traditional development course. So instead of becoming a software engineer, I got into developer relations, and mostly just kind of stuck with it, where I make sure that I make connections, learn new things, open to trying a bunch of things, where I stay both a combination of technical and non-technical the entire time, which is why I'm doing things like talks like this instead of just staying in my little hacker node and just coding the entire time. So I don't really know how to be more specific than any of that, other than just a lot of participation, communication, and time, frankly.
Yeah, how do we stay current? I mean, technology is advancing so fast, right? So how do we stay current? I mean, it sounds like you guys are right in the cusp right now on what you're doing. So any tips for new things? I'm an old guy, okay, and I'm just trying to stay up with the speed of light train.
I mean, my position itself does a lot of focus on learning a lot of things really quickly instead of becoming an expert on one specific thing. So I kind of by consequence have to always stay up to date with the new things that are going on and just kind of keeping up to date. So it depends kind of what your priorities are, because there's validity towards both.
Yeah. Hemanth, do you want to share some?
Yeah, so my career path has been, I would looking back, I would say a little bit weird. So I knew I was always wanted to be in the engineering field, so I took classes and courses that way. So I did my bachelor's in hardware, electronics and communication engineering in India, right? And then I figured, hey, you know what? I like computer networks, so let me do my master's in there. Then I came to California, and I did my master's there in computer engineering, specializing in computer networks. And I was a teaching assistant for many software engineering courses, and I started liking full stack development. I was teaching those courses, for the professor I work for, and that got me interested and gained an internship there as a full stack, intern, and then eventually a job in full stack just as I graduated. And that's how I got into this building applications full stack. And then I moved from Juniper Networks to Adobe, where I'm built from the past 5 years. I'm building amazing front-end applications which millions of people use, and that inspires me. And I think it took me a journey, right? If you asked me 10 years ago, Hemanth, would you be doing this? I would say no, I probably not, right? Every couple of years, I reevaluated myself, my interest, and see where it goes. And things about being current, right? It's an illusion that you just finish your education and you're done studying and just work, right? That's not really true. You have to study while you work, because there are so many things which are new, and you need to keep yourself updated. So during my time at Adobe, I did a front-end graduate certificate from Harvard, which my company sponsored. So I've been developing my skills on that, things I do outside of work, like W3C, IEEE, and like speaking at conferences as such. That is how I have been, trying to improve myself and get to a position where I can help others. And that has been my goal, and I keep working on that.
Wow, that was awesome. Another guys, that was amazing. It really was. Another question just popped in here, and I just want to say thank you guys for just persevering in your careers and everything, and the impact I'm sure you've had. It's really awesome. Both of you are so amazing. Okay, here's one. I think the last question is: will React become a framework?
I think only time will tell.
That's what Future says. Yeah.
So I'm not even that old, but I'm sure most developers kind of remember, so we're mostly using JavaScript frameworks now, but before that, Ruby and Ruby on Rails was the big thing. Before that, PHP was the big thing. Yeah. Who knows? Maybe there's going to be something that completely supersedes JavaScript, that completely changes the game, and React then just becomes the next Ruby on Rails. Maybe React continues on. It just kind of depends what the needs of the industry and what new technologies are available in the future. So I can't.
Wow, that's great, guys. I think we're done. Oh my word, that was so fast, and that was so great, and we really appreciate your time, and it's just the great answers. There's Anna. I'm just gonna be quiet and let her talk now.
No, it's fine. I love when you are talking. When you are talking, we have so many people who are listening. That's why we are calling you for that, because you're really a great moderator for our events, and we really appreciate it. So, guys, thank you so much for joining us, for giving your amazing speeches, presentation. It was really great. Thank you for your time that you spent preparing it, submitting it, and here presented it. So thank you so much, and I hope to see you at our next event. Of course, Mike, of course, I'll see you for sure. No,
I will be back. I will be back. I love it.
And Griffin, Hemanth also. I really hope to see you at our next React event that will be in April. So please don't miss it before, or anyway, I'll pin you. So see you.
Thank you.
Thank you so much for having me.
Oh, he put it out there. I saw that. That was the last message, and Ed put it out there. Hi, Ed. Good to see
Yeah,
everybody.
he really wanted to show it. Yeah, thank you. Have a great rest of the day. Spend time great, productive, have some more fun, and see you soon. And also, I want to say a huge thank you to our attendees who were with us for a really long time. And see you tomorrow. Senior track is waiting for us.
Bye, everybody. Thank you. Guys, you were great. Everybody's great.
See you.